All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Vedantu NEET English. Just a sign. Okay. So, let me know in the live chat if I'm audible and visible properly. Let me know in the live chat if I'm audible and visible properly. Good evening, good evening, good evening. Okay. Great. So make sure you hit the subscribe button and make sure you like this particular session. So this is the very important session from the NEET perspective. As I have told you, this is the chapter from which 4 to 5 questions are asked every single year in your NEET exam. So you cannot afford to miss, okay? So this is the chapter which you guys are supposed to learn over here in this one. And most importantly, I'll be starting from the scratch, and from the basics I'll take you to the level which you actually need. Every problem pattern will be solving over here, and most importantly, each and every single concept we will be basically learning over here in this session. Good evening. Okay, so how is everything going? How is your Josh? Is it high? Okay, great. So guys, so we have to start this current electricity chapter, and if you have not liked this session, make sure you like it as soon as possible. Okay, then only I am starting. Okay, great. Okay. Shall we start the session? Give me the thumbs up, give me the signal in the live chat, and we are starting this particular session. Take your pen and paper out, okay? We have to complete this entire chapter in just one go, okay? It will take a bit more time, but we have to complete this chapter because 20 marks will be basically completing by today only, okay? By tonight only. Okay, great. Okay. So guys, let's start this particular session over here. Now, before starting this session, let me just tell you over here. See, the name of the chapter is current electricity. The name of the chapter is current electricity. And in this chapter, the first topic that we will be studying is nothing but we say electric current. Now see, let me take you from, I'll be starting from the scratch, I'll be starting from the basics, okay? And I will show you every problem pattern which you actually need in order to solve all the questions out there in this particular chapter. Now see, let's first understand this electric current. Let's suppose I have over here a conductor. Sir, what does a conductor mean? Let's suppose I have a wire over here. We know we have a wire, and through that wire current flows. You say either this is a wire, or you say, sir, this is nothing but conductor. It is a wire or conductor. And sir, when it comes to the wire, when it comes to the conductor, there are, we say, so many free electrons present inside a conductor. There are large number of free electrons present inside the conductor. Okay, free electrons. We know, sir, there are large number of free electrons present inside the conductor. If I say these free electrons, these electrons over here are moving in a proper direction, in a unified direction, like they are moving forward over here. These electrons are flowing over here, okay? They are flowing over here, okay? So, whenever electrons flow or whenever charge flows, we say, sir, current is being produced. Current is being produced. As simple as that. So whenever we say charge flows or electrons flow, because electrons contain charge, so means current is being produced. So we say this current is nothing but it is the flow of charge. It is the flow of charge. Okay. So whenever charge flows, we say, sir, current is being produced. Okay. And we represent this current with I. We say current is being produced. Now, if I have to write the formula over here, okay, guys, my Josh is high. I want you guys to have the same Josh in the live chat also. Okay. Now, we say over here, sir, whenever we talk about the current is nothing but how much charge is flowing. Okay. Flow of charge. More charge flows through a wire, more charge flows through a conductor, more will be the current. Less charge flows through a conductor, less will be the current. Okay. I guess. Okay, we have the Pankhuri ma'am in the chat. Hi ma'am, what's up? How are you? So if I talk about the current, if I have to write the equation for the current, so I can simply say this current is nothing but, we say, sir, charge flow, how much charge has flown upon, we say time. Charge upon time, or we simply say I is equal to Q divided by T. I is equal to Q divided by T. More charge flows through the conductor, more will be the current. Less charge flows through the conductor, less will be the current. As simple as that. Okay. Now, guys, listen to me very carefully. Sir, we have a wire over here, and through that wire, charge is flowing means current is flowing. As simple as that. Okay. So whenever charge flows, current is there. Now, basically, we say the SI unit of current is ampere and everything, that basic things you basically know. Now, listen to me very carefully. Now, let's talk about what is average current. Let's suppose we have over here a conductor. Let's suppose we have over here, this is a wire or this is a conductor. And in this conductor, we say, sir, electrons are flowing, electrons are moving inside this conductor. Let's suppose I am saying that from 9 a.m. in the morning, till 1 o'clock, till 1 p.m., sir, charge was flowing through the conductor. Listen to me very carefully. I'll give you the feel of this average current. We say, sir, from 9 a.m. in the morning, we check basically the clock. Okay. So from 9 a.m. till 1 p.m., charge was flowing inside this wire. Charge was flowing over here. Can we say, sir, whenever charge flows, current is being produced? So we say, so current is produced. So current is produced. Okay. Now my question to you is, my dear friends, that is nothing but, if I ask you, how much current has been produced over here? How much current has been produced from we say 9 a.m. till 1 p.m. over here. From 9 a.m. till 1 p.m. over here. Or how much current has flown from 9 a.m. to 1 p.m. That current will be average current. That will be average current. See, if I ask you, sir, what is average velocity? It is total distance traveled upon, or total displacement traveled upon total time taken. Similarly, over here, average current is total charge flown from 9 a.m. till 1 p.m. So we say, sir, this average current is simply that is total charge flown divided by total time taken. As simple as that. Okay. total charge flown upon total time taken. From 9 a.m. to 1 p.m., how much charge has flown, how much current has been produced, divided by total time taken. That will give you the average current. Now, my dear friends, if I ask you, I'll take the same conductor over here and we say, sir, these electrons were flowing from 9 a.m. as we said till 1 p.m. My question to you is, when it was a time exactly, when the time was exactly 10 a.m. in the morning, how much current was produced, or how much current has flown when it was exactly the time 10 o'clock. Okay, so we say that will be the instantaneous current. So basically, instantaneous current tells us the current at any particular time. If I ask you, sir, tell me how much current has flown from 9 a.m. till 1 o'clock, or how much current has flown from in this time duration, like for 2 hours. That's we are talking about the average current. Whenever I ask you when the time is exactly 10 a.m., okay, at this particular point of time, how much current has flown, how much current is produced, that's what we call the instantaneous current. We say it is the current at any particular instant, and when we talk about the average current, it is the total current from time t1 to t2. Okay, so we say, sir, that is what we call the average current. And the simple formula in order to find the average current is, we say, sir, this I average we write that is a delta Q divided by delta T. That is total charge flown upon total time. You can also write it something like this: Q2 minus Q1 upon, we say, T2 minus T1, something like this. And if I write the equation for this, we say, sir, this IINS instantaneous current is simply dQ divided by dt. As simple as that. As you might have studied, when it comes to the average velocity, sir, average velocity is nothing but delta S by delta T. And when it comes to the instantaneous velocity, instantaneous speed, that is, we say, ds by dt. It is exactly similar. So we say, I hope it is clear, guys. Let me know in the live chat. Everyone, is it clear? Is it clear, guys? In the live chat, with the thumbs ups, with the fire symbols. Is it clear or crystal clear? Everyone. So we say whenever charge flows through a conductor, whenever charge flows through a wire, current is being produced. And if I ask you the average current is nothing but total charge, how much total charge has flown, or total current. In general, what is the value of current? And when it comes to the instantaneous current is nothing but current at any particular instant. When it was exactly 10 o'clock, how much is the current? That's what we call the instantaneous current. Is it, guys? Is it clear? Okay. And when it comes to the formula for instantaneous current, we say it is dq by dt. And when it comes to the formula for average current, it is delta q by delta t. That is total charge flown upon total time taken. Yes, yes. Now let's move on to the question number 1. We have an equation over here. Q is equal to T square plus T plus 1. What is Q? Q is charge. So basically, it is like we are given a conductor over here. We are given a conductor or a wire. And in this wire, we say charge is flowing. We say charge is flowing in this wire over here. And if I ask you how much charge is flowing, that is given over here. Q is equal to T square plus T plus 1. Now the questioner asks, find the current at T is equal to 2 seconds. At T is equal to 2 seconds means we have to find the instantaneous current. At t is equal to 2 seconds means, am I going fast? Am I going fast, guys? At t is equal to 2 seconds means we are talking about the instantaneous current. If I say find the current from, like I'll give you the question one more. Next question is q is equal to t plus 1. Find the current from 0 to 2 seconds. From 0 to 2 seconds means average current, total. And when it comes to at t is equal to 2 seconds means instantaneous current. Current at any particular instant. Between the time intervals, whenever we talk about the current, we talk about this. Yes, great. Now see, sir, here, to find, we have to find IINS, okay? Because it is current at t is equal to 2 seconds. Sir, we know instantaneous current, formula for instantaneous current is dq by dt. That is differentiation of charge with respect to time. So can I just write it something like this? IINS is equal to d by dt of, and instead of this q, can I say this is t square plus t plus 1? So it will be t square plus t plus 1 over here. Yes. Now differentiation of this will be, sir, IINS current instantaneous will be differentiation of t square is 2t, power down, power minus 1, plus differentiation of t is 1 with respect to t if we are talking about. And differentiation of constant is 0. Now we have to find at t is equal to 2 seconds what is the value of current. So put t is equal to 2 seconds over here. We say IINS instantaneous current will be 2 into 2 plus 1. So this will be 4 plus 1, that is 5 ampere. As simple as that. This was the basic question just to make you understand what instantaneous current is all about. Is it clear, guys? Is it clear? Now, let's talk about this particular question. So can I say in this case, here, we have to find, we say average current. Here we have to find the average current because they are asked find the current from 0 to 2 seconds. From 9 a.m. till 1 p.m. It is exactly like that case. At 10 a.m. exactly that is the instantaneous current. Is it crystal clear, guys? Guys, I want you guys to show me the same Josh like I have. If your Josh is getting down, if your Josh is getting low, mine will be automatically, okay? My energy will decrease something like this only and I'll sleep over here. I'll keep the stream on and I'll sleep. Is that cool? Is that cool, my dear people? Okay, great. Now see. So we say, sir, over here, when it comes to the average current, we know the formula, sir. Average current is delta Q divided by delta T. That is total charge flown from 0 to 2 seconds upon total time. Or you can say, sir, this is Q2 minus Q1 upon, we say, T2 minus T1. Now the question over here is, my dear friends, that is nothing but what is this Q2? We say Q2 is the charge, Q2 is the charge flown at t is equal to 2 seconds. So when it was exactly 2 seconds, how much charge was flown? So how to find that? Take this Q equation over here. Q is equal to t plus 1. Okay. Now, at t is equal to 2 seconds, how much charge was flowing through the conductor? How to find? Put t is equal to 2 over here, you will get Q2. So 2 plus 1, so means 3 coulomb. So when the time was 2 seconds, at that point of time, how much charge was flown? 3 coulomb. Now, we say, sir, Q1 is the time when time was, Q1 is the charge flown when time was 0, Okay, so we say, sir, this is nothing but t plus 1. And I'll just write over here, sir, this will be nothing but how much is 0 plus 1? That is 1 coulomb over here. And if I have to write the average current, sir, average current will be Q2 minus Q1. Q2 is 3 coulomb. So we say, sir, 3 minus Q1 is 1 upon T2 minus T1. T2 is 2 seconds minus 0. So this will be 2 by 2 is equal to 1 ampere. Okay, guys, I have the best of the best questions which I have put up in the today's one shot. Okay. What I'm trying to say is that, see, as I told you, I have to start from the scratch. I have to show you every problem pattern. That's why sometimes questions will be of, okay, moderate level. The questions will go higher level also. Okay. So do not worry at all. Whatever I'm saying, just keep following it, as simple as that. Okay. Okay, great. Now, let's move on to the next one. So, two types of problem patterns already done. Let's move on to the next one. Over here, my dear friends, listen to me very carefully. Given I is equal to t plus 1, calculate average current from 0 to 2 seconds. See. Over here, we were given that charge Q is equal to t plus 1. This is the charge flowing in the conductor. And we were asked to find the average current. Sir, we know the formula delta Q by delta T is equal to average current. But this is the formula we use when charge is given. But over here, sir, current is given. We have a conductor. And inside this conductor, current is given, that is this. And if current is given, they are asked to find the average current. What is the formula we will be using in this one? Can anybody of you tell me in the live chat? Okay, we cannot use the previous formula, but we have to use different formula over here. Can anybody of you tell me in the live chat? Yes, it is sufficient for all the students. That's why I say I'm starting from basics. Now see, let me just tell you over here. Let's suppose, if we have a quantity X, any quantity, listen to me very carefully. If we have a quantity X and we have to find its average, we have to find its average. Okay. I'll tell you the formula. If X is the quantity and we have to find its average, see, we say, sir, its average of this quantity X will be, remember this formula directly. We say, sir, integration of X dt upon integration of dt. Remember this formula directly. If we have a quantity X and we have to find its average, this is the formula we'll be using. Let's suppose if we have a quantity Y and we have to find its average with respect to time, sir, we'll be doing integration of Y dt upon integration of dt, as simple as that. If we have a quantity A and we have to find its average, we'll be saying integration of A dt upon integration of dt. Now over here, we have a quantity I and we have to find its average. Sir, we can simply write over here, I average will be integration of, we say, sir, I dt and integration of dt over here in the denominator. So we can write over here, sir, this I average will be integration of I. What is the value of I over here? You can simply say, sir, this is t plus 1. And we have to find its average from 0 to 2 seconds. So we'll be putting the limit 0 to 2 upon integration of dt from 0 to 2 seconds over here. Now do the integration and you are done with the question. So we say over here, sir, integration of t with respect to t. Integration of this is I and this will be dt. So we say, sir, integration of this t will be simply, that is t square divided by 2. Integration of x with respect to dx is x square by 2. So we say t square by 2 plus integration of 1 will be, sir, t over here. And the limits are from 0 to 2 upon integration of this, see, d and this integral sign will cancel out over here, or integration of dt is t from we say 0 to 2. From 0 to 2. Okay. Now, if we just follow it on the next page, I can write it over here. Sir, this I average will be simply, see, this is t square by 2. First, we have to put up the upper limit, that is 2 over here, 2 square by 2 plus. Then we have to put, see, if you put the lower limit, that is minus 0, it is nothing. Okay. So then put this 2 over here in this one. So what we can write, that is 2 square divided by 2 plus 2 over here. I have put up the limits, and in the denominator also we'll put up the limit, that is 2 minus 0. So that will be 2 only. So now how much is this, sir? This is nothing but, we say 2 square is 4 by 2 is 2, 2 plus 2 is 4 divided by this 2, and this will come out to be 2 ampere. 2 ampere is the correct answer. Is that clear, guys? Is that clear, guys? Is it crystal and clear? Each and every one. Is it crystal and clear, guys? Now, we have got the next question over here, okay? This is the another type of question. See, you can clearly see from the board, in the first question, we were supposed to calculate the instantaneous current. In the second question, we were supposed to find the average current, but charge was given. And in the third question, you can clearly see, sir, we were supposed to find the average current, but current was given. And over here, in this question, sir, current is given and we are supposed to find the charge. Now, my dear people, listen to me very carefully. Listen to me very carefully. Listen to me very carefully. Over here, listen to me very carefully. Sir, we know as here, current is given. Let's suppose we have got a conductor over here, and in this conductor, current is flowing. Sir, what is the value of that current? We say 4 plus 2t. Current is changing with time, okay? So current is flowing, I is equal to 4 plus 2t in this conductor. And if current is flowing here, we are supposed to find how much charge has flown, because when current flows means charge is flowing. What is current? Current is nothing but charge. So we say over here current is given. Here current is given. And to find, what we have to find is, we say charge. We have to find how much charge has flown through the conductor. Now, as we know, listen to me very carefully. As we know, sir, I is equal to dq by dt. We know, sir, current is dq by dt. Now take this dt over here, sir. We can write I dt is equal to what remains over here, that is dq. Now I want you guys to basically integrate from this side, integrate from both the sides, okay? Now see, sir, integration of dq. Integral means you are adding. So dq, when you keep on adding the small charges dq, you will get the total charge q. So we say, sir, this is nothing but, so what is this? This is nothing but integration of I dt is equal to over here q. Or this d and integral sign will cancel, what remains q. So q is equal to integration of I dt. Now, this is the formula you will remember from now onwards. If current is given and you are supposed to calculate the charge, this is the formula which you will be using. Q is equal to integration of I dt. Now, my dear friends, can I use this formula? Q is equal to integration of, what is the formula for I? We say, sir, 4 plus 2t over here. And then we say, sir, dt. Then this dt. And you are supposed to find how much charge has flown from 0 to 2 seconds. So we say, sir, from 0 to 2 seconds. So Q is equal to, we say, sir, integration of 4 will be 4t. And then this will be plus, what is the value of this? So this will be 2t square divided by 2 over here. 2t square divided by 2 over here. Why, sir? Because this is 2 and 2 will get cancelled. Because difference integration of t is t square by 2. And then put up the values 0 to 2 over here. So this q will be simply 4 into, put up the upper limit, that is 2, 4. Instead of this t, you will put 2, because put this limit. Then you have plus t square, then put over here, that is 2 square. So this q will be simply 4 into 2 is 8. 8 plus 4 is, that is 12 coulomb. Is 12 answer the correct answer? Great, 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 great. Is that clear, guys? Is that clear? Is that clear, guys? Everybody. Great, great. Everyone, I want all of you to let me know If this is crystalline clear, if this is crystalline clear. Okay, okay, my dear people. Okay, my dear people. Then we have over here the next. Okay, this is the slide that I'll be explaining over here. I told you I'll be showing every problem pattern. And guys, you have not liked the session yet. Okay, 200 people are watching out there. Like the session, I'm not continuing. Okay, I'm stopping the session. I'm going. Okay, I'm pulling up this mic. Everyone, I want you guys to make this like count. It should cross 300 right now only. Everyone. Now see, my dear people, if I say, sir, charge is given. Listen to this is a very important slide. If I say, sir, charge is given, Q means charge. If I say charge is given and you are asked to find the instantaneous current, what is the formula that you will be using? I is equal to dq by dt. Sir, which question we did on this particular formula? This question we did on this particular formula. If charge is given and we are supposed to find the instantaneous current, see, we use this formula I is equal to dq by dt. Now, second, sir, if charge is given and charge flowing is given and you are supposed to find the average current, what is the formula you will be using, sir? I average is equal to delta Q by delta T. That is Q2 minus Q1 upon T2 minus T1. Already we did this. Now, my dear friends, if charge is given and, if current is given and you are asked that find the value of average current, sir, this is the formula I'll be using. Did I tell you this? Yes, we did the question on this pattern also. I average is equal to integration of I dt upon dt. And the last question was, if current is given and you are supposed to find the charge, then this is the equation that you will be using, integration of I dt. This is the question we did recently. This is the question, Q is equal to integration of I dt. Now, is it clear, my dear friends? Is it clear, my dear friends? Now, let me just show you one more type problem pattern over here. If let's suppose we have got a conductor over here, okay? And in this conductor, charge is flowing. That charge is given. T is equal to, Q is equal to T raised power A. Let's call it A over here. I know it is 3. Let's suppose generalize it. It is A. E raised power minus 4, or don't write minus 4, e raised power minus bt. And in this particular question, it is Q is equal to T cube, means A is given as 3 over here and B is given as 4 over here. Okay. Now, they are asked, if charge flowing in a conductor is this, find the time when current changes its direction. If they ask you the question of this sort, charge is given and they ask you when will the current change its direction, maybe current, if the current is flowing something like this, it will change its direction something like this. If they ask you the question of this sort, just directly use the formula, sir, that time will be nothing but A divided by B. As simple as that. That time will be nothing but A divided by B. As simple as that. Okay. Now, if I ask you in this particular question, sir, charge flowing is this. Find time when current changes direction. There is a long method of this one also. I will not be doing that, but we'll be doing this. Simply use this formula. Now, over here in this question, we say, sir, if charge flowing is this, find time when current changes direction. We say, sir, T is equal to A divided by B. Sir, T is equal to, what is the value of A over here? That is 3. And what is the value of B over here? That is 4. Now, if I give you the question something like this, if Q is equal to T raised power 7 and E raised power minus 8T, find the time when current changes direction. Can I simply say, sir, that time will be A by B. A is 7. B is over here 8. That is 7 by 8. Is it clear, guys? Is it crystal and clear, guys? Is it clear, guys? Now, the next question, next pattern of question, that is, this was the question which was asked in NEET 2019. What is the question? Question is, if we have a conductor over here, if we have a wire over here, okay, and in this wire charge is flowing, that is given as Q is equal to AT minus we say BT square, AT minus BT square. Charge is flowing something like this, and questioner says that find out time till the current flows in the conductor. Let's suppose we have got a conductor over here, and in this conductor current is flowing for some time. Let's suppose for 1 hour, 2 hours, 3 hours, 5 seconds, 6 seconds, let it be something. So we are supposed to find that time. What is the value of that time? Okay, till the current will flow. How many seconds, how many hours? Listen to me very carefully. We say, sir, current will flow in a conductor, current will flow in a conductor till it becomes zero. As simple as that. Sir, if we have a wire over here and inside this wire charge is flowing, means current is flowing. So this current will flow till the current becomes zero. If current becomes zero, means current was flowing. Let's suppose this is the wire, and inside this wire current is flowing for 1 hour. So we say after 1 hour current will be zero. After 1 hour current. Yes, JEE students can listen to this lecture also. I have put up the JEE PYQs also in this particular one shot. Now see, so we say, sir, current will flow in a conductor till it becomes zero. When it becomes zero, there will be no flow of current. Now, if the charge is given, how to find the current? We say, sir, I is equal to dq divided by dt. So that will be differentiation of this. Now, differentiation of this with respect to time will be, sir, it is nothing but for this AT, it will be A. And then we have minus. Differentiation of this will be, take the power down, so it will be 2BT. So it is 2BT. Okay. Now this is the current in the conductor, and we have to find the time till the current flows. Now current flows till it becomes zero. Now put the value of current is equal to zero and find the time. We have this current, that is A minus 2BT, make it equal to the zero. Now find the time over here. Now take this 2BT over here. So A is equal to 2BT. And if you have to find the time over here, this time will be A divided by 2B. So means, sir, current will flow till the time T is equal to A by 2B. I hope this is clear, guys. I hope this is clear. Is it clear, guys? In the live chat, everyone. All of you. Is it clear? Is it? Great. So now comes the next topic. That's what we call the drift velocity. I have shown you approximately 8 problems, okay? And all were of the different patterns, all were of the different types. Now let's talk about the drift velocity. Listen to me very carefully. Let's suppose we have got a conductor over here. This is a conductor. Conductor means, sir, this is a wire. And we are connecting a battery to this wire. And we know, sir, battery has got the potential difference. Let's call it V. Okay. As my dear people, I have told you when we were learning the electrostatics over there, whenever we connect the battery to something, to capacitor or to something, it sets up the electric field. It will create the electric field. Or simply remember, as battery will set up the electric field. Okay, just remember it directly. As we know, I have told you, sir, this battery will take charge from one end, it will place onto the another end. If positive charge comes onto this end, negative charge will come onto this end. So electric field will be set up from positive to negative charge. Directly I am saying that if we have a wire over here, If we are connecting a battery to it, this battery will set up the electric field from positive end towards the negative end. So we say as battery will set up the electric field. And we know, sir, this conductor carries so many free electrons, a large number of free electrons. Okay, yes. Now, sir, electric field is set up because of the battery. And now we can say over here, these electrons are present in this electric field. Now, sir, whenever we place the negative charge in the electric field, we say, sir, force acts on the charge. As I have told you previously, if we have this electric field, if we are placing the charge inside this electric field, force will act on it. That force is equal to Q times of E. If this is a negative charge, force will act in the opposite direction. Now, my dear people, sir, over here electric field, over here we have charge. So this electric field will apply force on the charge as electrons will experience force due to external electric field, and that force will be equal to Q times of E. And more specifically, we say, sir, this force is equal to, what is the value of Q over here? That is charge on an electron. That is nothing but we say E. Charge on an electron is E. And this capital E is the electric field. As we know, whenever force acts on something, acceleration, it accelerates. So what is the value of acceleration over here? We say, sir, F divided by M. Because according to Newton's second law, F is equal to ma. So we say over here, instead of force, we can write E divided by M. So we can clearly say, sir, over here acceleration is E capital E divided by M. Okay, this is the acceleration. Now, my dear friends, tell me one thing. Sir, over here, we can clearly see that these electrons will experience force in the backward direction. Okay, that force is equal to, sir, Q times of E because of the electric field. This is the force. Now, I am asking you the simple question over here. That is nothing but, if this force is acting on these electrons, don't you think they will move forward? If I say this is the electron, force is acting on this in the forward direction, so it will move forward. So we say here as electrons will move forward. Okay, move forward. Or another word I can use over here, electrons will be drifted forward, or we say drifted forward. Yes, sir, electrons will be drifted forward. Now, if these electrons are being drifted forward, means they will gain some velocity, they will gain some speed, and that speed is called the drift speed. So they gain some velocity, and that velocity is called, we say drift velocity. Means we say, sir, drift velocity is that velocity with which electrons are being drifted, with which electrons are being basically pushed in the forward or in this direction over here. So we say that is what we call the drift velocity. And if somebody asks you how to find the value of drift velocity, let me show you. Sir, we know as V is equal to U plus A into T. This is the formula we know. Now over here we say initially this electron was at rest. Okay, we don't have to entirely study this gas model in detail. I'm just telling you this to the point. So we say over here, between the two successive collisions, if the electron perform over here, it comes to rest. So we say, sir, this initial velocity is 0 plus acceleration of this electron is E divided by M. So we say this is E, capital E divided by M. And this time we call the relaxation time, or you call this simply time over here. Sir, V will come out to be E divided by M into, we say, tau. So this is the drift velocity. This is the drift velocity. This is the drift velocity of electrons in a conductor. Tell me, is it clear, guys? Is it clear? Is each and everything crystal and clear? Is it clear? Everyone, I want all of you to let me know in the live chat. It's not like some people will say, because a lot of students are watching this. Everyone. I'm seeing how many of you people will say in the live chat. How many of you will give me the signal? See, where m is the mass of an electron, this acceleration is F by m. F is the force on electron. Okay, force is equal to E into capital E. E is the electric field, and this small e is the charge on an electron, where E is the charge on an electron, and capital E is the electric field, and m is the mass of electron, where m is the mass of electron. What do we have to do with the mass of conductor? This is not mass of conductor. Okay, great. Now, my dear friends, so this is the drift velocity. Okay, now let me summarize this. If we have a conductor over here, we are connecting a battery to it. Sir, battery will set up the electric field. Because of that electric field, free electrons inside the conductor will move. They will gain some velocity. That velocity is what we call the drift velocity. Drift velocity is nothing but it is that velocity with which the electrons will move. Yes, electrons will move opposite to the electric field, because I have told you previously, if we have, this is the electric field, if we have the positive charge, force acts in the same direction. And if we place the negative charge inside electric field, force acts in the backward direction. Opposite. Okay. Now, relation between drift velocity and current. My dear people, listen to me very carefully over here. Let's suppose I am taking a conductor over here. Let's suppose this is a wire or this is a conductor. And we know, sir, inside the conductor, there are so many large number of free electrons over here. Yes, sir. And we are connecting a battery to this particular conductor over here. Yes, sir. And we know, we recently studied, this battery will set up the electric field over here. Let's call that electric field E. Now, because of that electric field, these electrons will move forward. We know, sir. Yes. Now, over here, as due to the electric field, we say electrons move. Okay, electrons come in motion. So we say current is produced. And I'll not write the move over here. Let me just write electrons drift. Sir, electrons drift. With what velocity? Drift velocity. So, whenever electrons are being drifted, electrons are in motion, we say, sir, current is being produced, and current is produced. Now, we have to see the relation between drift velocity and current. We have to see how much is the current being produced to find that current. You say, sir, I'll find that current. I know the formula. I is equal to delta Q by delta T or BQ by dt. I say, no, you don't have to use this particular formula. You have to use something else. What is that? Let me just tell you. That current will be, we say, sir, I is equal to, we say I is equal to NEAVD. Sir, what is this? This is the value of current in terms of drift velocity. Here you have to find the current in terms of drift velocity, because this is the relation between drift velocity and current. When electrons are drifted, current is being produced. How much is that current? NEAVD. Now listen to me very carefully. N is the number of free electrons per unit volume. Number of free electrons per unit volume. Now see, inside the conductor there are millions of, we say, free electrons. Now we take a unit volume over here and check how many free electrons are present inside this unit volume. So that is what we call N. N is the number of free electrons per unit volume. And sir, E, what is E? E is charge on an electron. We recently saw 1.6 into 10 raised power minus 19 coulomb. Now, sir, what is A? A is the area of cross section. How much is the area of cross section of the conductor? A is area of cross section. We don't have to derive this formula, just remember it directly. Area of cross section. Now, my dear people over here, if A is the area of cross section, I is what? I is current, and VD is what? VD is drift velocity. Is it clear? Is it clear? Is it clear? Is it clear, guys? Everyone in the live chat. Is it clear, guys? Are you loving the session or not? Make sure you hit the like button. Every one of you, make sure you hit the like button. Okay, great. At the end of the session, I want everybody of you to comment down below how was the session. Okay, when the session ends, over there in the comments. Now, this is the question we have over here. The drift velocity of free electrons in a conductor is V. Let's call it VD. The drift velocity of a free electrons in a conductor is VD. We are given a conductor over here. Okay. And inside this conductor, electrons are flowing, okay. And given is that drift velocity is given, that is VD. If they are flowing, they will have some velocity. That is what we call the drift velocity. And let's suppose area of this, radius of this cross section is R, okay. And then how much will be the area of cross section? We say, sir, area will be pi into small r square, because this area is pi r square. If the radius is r, so this will be pi r square. Now, and let's suppose the length of the conductor is L. Can you tell me what is the drift velocity? How much will be this drift velocity? You say, sir, as I is equal to NEAVD. I is equal to NEAVD. Now, can you find this VD over here? Sir, VD will be I upon NEA. This VD you can calculate I divided by NE, and this is A. I is the current, N is the number of free electrons per unit volume, E is the charge on an electron, A is the area of cross section. Now let's call this as equation number first. Now see what they are asked. They have asked over here. Now this is the initial situation, okay. This is the drift velocity. And more specifically, if I just write over here NEA, instead of this A, I can write pi r square, because A is equal to pi r square. Okay, let's call this as equation number first. Now, now they say, if the radius of conductor is doubled, they have doubled the radius of the conductor. They have made the conductor something like this, okay. Now this R dash will become 2 times of R. Initially, if it was R, now it becomes 2 times of R. And current is also doubled. Now in this case, we say, sir, current, now more electrons are flowing. Sir, over here, I dash is also 2 times of I. Current is doubled. We have to find the new drift velocity. Sir, we have to find the new drift velocity. As a drift velocity is I upon NEA. Listen to me very carefully. Instead of I, how much current do we have? That is 2 times of I. I say 2 times of I upon. Then we have N. N is the number of free electrons. Both are made of the same material. N will be same. And E, charge on an electron is same. Pi r square. Over here we can write pi. We can write pi. And instead of r, we have 2r because the radius is doubled. So this will be 2r whole square. Now this drift velocity will be, let's call it Vd dash, Vd dash. Initially, when radius is r, so this is drift velocity, current is I, this is drift velocity. Finally, when current is doubled, radius is doubled, how much is the drift velocity? That we have to calculate. So this will be, sir, 2I upon, this is N E pi, and this is 2r whole square, that is 4r square. 4r square, 2 1s, 2 2s. So it will be I upon, take this 2 out, that is 2 N E pi r square. Now see, I upon N E pi r square is Vd. So this Vd dash we can write, it will be, sir, I upon N E pi r square. Instead of this, I can write Vd. That is the drift velocity initially. That is Vd. Divided by, we have 2 over here. Now, you can put up this in the box. Is it clear to each and everyone? Is it clear to each and everyone? Is it clear, guys? Okay. Let's move on to the next question. Now in this question, what they have asked is, in a conductor, drift velocity is doubled and radius is halved, find new current. See, we are given a current, we are given a conductor over here, okay? This is a conductor, okay? And inside this conductor, electrons are flowing, okay? Electrons are flowing. Now, we say, sir, how much is the current being produced? I is equal to N E A, we say Vd. And we can write it something like this. I is equal to N E. Instead of A, can I say if the radius is R? Can I say if the radius is R? So instead of this, I can write pi r square. And then you have, sir, Vd. I is equal to N E pi r square Vd. Cool? Yes, absolutely cool. Now, my dear people over here, if now it is saying that in a conductor, drift velocity is doubled. It says now drift velocity is doubled. Let's suppose we have this conductor over here, okay? Now these electrons are moving with the drift velocity, that is 2 times of Vd. If initially it was Vd over here, sir, now it is 2 times of Vd. And radius is halved. Over here, r dash becomes r by 2. Initially, it was r. Now it becomes r by 2. What is the current? What is the new current? I call that I dash. That new current will be N E A. Instead of A, I can say pi r square. Now, r is how much over here? That is r by 2. So that is, we can write pi into r by 2 whole square, pi r square, because radius is halved. Then into Vd, instead of Vd, how much is the drift velocity? That is 2 times of Vd. So this new current I dash will be N E pi. This will be r square by 2 square is 4. And this will be 2 times of Vd, 2 1s, 2 2s. So this will be I dash is equal to, see, N E pi r square Vd. N E pi r square Vd is I. So this I dash will be I by 2. Is it clear, guys? So current will be halved. So in a conductor, if drift velocity is doubled and radius is halved, then new current will be also halved. Is it clear, everyone? Now, okay, this is a question which is very important. I want you guys to solve it before I do it now only. I want you guys to solve it as simple as that. I want you guys to follow it as simple as that. I'm waiting for your answers in the live chat. I'm waiting for your answers in the live chat. Everyone, everyone, guys. And make sure you like this session, all of you. Now see, in this particular case, we are given two wires. We have a wire over here. This is the wire over here. This is the wire over here. Okay, we are given two wires. This is the wire A, and we are given another wire over here. That is the wire B. That is the wire B. Okay, this is the wire B. We say, sir, this is wire A and this is wire B over here. Listen to me very, very, very carefully. Sir, if this is wire A and this is wire B, two wires A and B have the same material. Both are made of the same material. Have the radii in the ratio of 1:2. The radius of this wire R1 is 1 and the radius of this wire R2 is 2 because the radius ratio is 1:2. Carry the currents in the ratio of 4:1. This has the current in it flowing, that is I1 is equal to 4 and I2 is equal to 1, 4:1. The ratio of drift speed of electrons, we are supposed to find what is the drift speed of A and what is the drift, if the drift speed of electrons of this conductor is VA, and if the drift speed of electrons of conductor B is VB, we are supposed to find what is the value of VA divided by VB in this particular case. Now, my dear people, can I just write over here, sir, simply if I just write VA, sir, V is equal to I upon NEA. Recently, I told you I upon NEA. And I can write over here, sir, in this conductor, it is I1. Now, let me just write over here, sir, it will be simply that is I1 upon NE, and instead of area, I can say pi R1 square. Okay. And then if I just write, sir, VB over here, that will be, sir, I2, that is current in this wire, that is I2 upon NE pi, and this will be R2 square because radius of this wire is R2 or RB. Now, if you divide this, if we say VA divided by VB, how much this will be? Sir, you can say in this particular case, that is nothing but I1 upon, that is NE pi R1 square upon, this will be, sir, I2 upon NE pi R2 square, as simple as that. Now, NE pi and NE pi will get cancelled out over here. Further, we can write this VA divided by VB. It will be simply I divided by R1 square, I divided by I1 divided by R1 square, whole divided by I2 upon R2 square. And if you take this in the numerator, if you do the reciprocal, it will be R2 square. It will be multiplied by R2 square upon, we say, I2. Now, this will be, what is the value of I1 over here? I1 is 4 and R1 is 1. So we say, sir, this is 4 upon 1 multiplied by, what is the value of R2? R2 is 2, I2 is 1. So this will be R2 square, that is 2 square divided by 1. 2 square is 4, 4 is 16 by 1. So 16:1 is the correct answer, and that is over here. Is it clear? Is it clear, guys? Now, let's talk about the current density. Okay, let's talk about the current density. See, let me just tell you over here. Let me just tell you over here. Let's suppose we have a conductor. Let's suppose we have a conductor. Okay. And in this conductor, electrons are flowing. These are the electrons which are flowing inside this conductor. Okay. These are the electrons which are flowing inside this conductor. And we have one more conductor over here. We say in this conductor also electrons are flowing. We say electrons are flowing in this conductor. Can you tell me the difference between the two? Can you tell me the difference between the two? You say, sir, in this case here, more electrons, you say, sir, in this case, more electrons are crossing. More electrons are crossing the unit cross-sectional area. Cross-sectional area. If you take a unit cross-sectional area over here, if you take a unit cross-sectional area over here, okay, through that cross-section, we say more electrons are flowing. And in this case, we say, sir, less electrons are crossing. Less electrons are crossing through the unit cross-sectional area. Why? Because less electrons are present. So we say, sir, over here, density of electrons is more. More number of electrons are crossing. So if we say large number of people are crossing this door, we say density of people is more. Less number of people are crossing the door, we say density of people is less. So we say here, current density is more. And we say over here, current density is less, as simple as that. More electrons are flowing, we say, sir, more current is being produced. Less electrons are flowing, sir, less current is being produced. So density of current over here is more. Density is what? How much current is crossing through the unit cross-sectional area. Over here density is more, over here density is less. Same as what I have mentioned. It is simply the amount of current passing through per unit cross-sectional area. If more current is passing through unit cross-sectional area, more is the current density. And we represent this current density with J. This is J. And we say, sir, this J current density is the amount of current passing through the unit cross-sectional area. That is, current upon area is what we call the current density. I hope this is clear. Current density is nothing but current upon area. How much current is crossing through unit cross-sectional area? If more current is crossing, we say more is current density. If less current is crossing, we say less is current density. Now in this particular case, if I just tell you, my dear friends, that is nothing but, let's suppose we have a cross-sectional area something like this. It is, if we have cut the cross-sectional area something like this. Now, when it comes to, sir, area will be something like this. This is the area A. Area vector is always perpendicular to the surface. If we say, for example, we have a phone over here, okay? If we say this is the phone over here, and if I have to find the area vector, you draw perpendicular to this board will be its area vector. So we say, sir, this is the area vector. And let's suppose, sir, this is the current flowing over here, that is I, in this conductor. Let's call this as theta. Can I say if this is A, this will be A cos of theta? Yes, sir. And this one will be A sine of theta? Yes, 110%. Now, in this case, if I ask you to tell me the current density, you say, sir, current density J is equal to I. I is the current flowing through this conductor divided by area of cross section. Now over here you have A cos theta and A sin theta. You will be taking the A cos theta because this current is along what? A cos theta. So this will be A cos of theta. Now if you take it over here, sir, you can write I is equal to, that is J A cos of theta. Or you can say I is equal to J dot A also. Is this clear? This is also the formula for current density, Ja cos theta or J dot A. Clear? Is it clear? Is it clear to each and everyone? So current density is simply how much amount of current is crossing through unit cross-sectional area. More current is crossing, more will be current density. Less current is crossing, less will be current density. Okay. Current density in terms of drift velocity. Now we have to find the relation between current density and drift velocity. See, this is the formula of current density in which current is present and area is present. But we have to find the formula for current density in which drift velocity is present. You tell me one thing. As we know, sir, what do we know? We say, sir, J is equal to, we say, sir, I is equal to NEAVD. This is the formula we know. Relation between current and drift velocity. As we recently studied, as current density J is equal to I divided by A. I want you guys to basically do one thing. Multiply this area over here. So current will be J into A. Now put this in the equation first. This is equation first. I say put in first. If you put it in the first, so this will be J into A. This is J into A is equal to, then you have NEAVD. This A and this A will get cancelled out over here. So J is equal to NEVD. Now this is the current density in terms of drift velocity, NEVD. So we say this is the relation between current density and drift velocity. This is the current density in terms of drift velocity. This is the current density in terms of drift velocity. Is it clear, guys? Now we have the question over here. See, you guys are supposed to tell me, we have a conductor. It has the same cross-sectional area. It has got the same cross-sectional area. You guys are supposed to tell me the current density and drift velocity at A, B, and C. Where will be the more current density or current or drift velocity in this particular case? This is what you are supposed to tell me over here. Come on, everyone. See, over here we say as we say current is same at A, B, and C. See, when it comes to the current is if this is a neutral conductor, we say if this is a neutral conductor over here, we say, sir, the amount of electrons or the amount of current or the amount of electrons flowing over here will be same over here, because this is the neutral conductor. Same current will be everywhere. Just keep this thing in your mind. So we say IA is equal to IB is equal to, we say, sir, IC. Current will be same at every point. Okay? Because this is a neutral conductor. The amount of electrons flowing over here will be equal to the amount of electrons flowing over here Yes. Now, as when it comes to the current density, Sir, current density, we say, sir, J is equal to, I divided by A. Current density is current upon area. As current is same everywhere, so we say J is inversely proportional to area. Now over here, sir, area at A is equal to B is equal to C. We can clearly see that, area is same in this case, current is same. So we say current density will also remain same. If electrons are flowing over here, we say how much current density is at A will be equal to the current density at B will be equal to the current density at C. Now, if we talk about, drift velocity, as for drift velocity, sir, we know when it comes to the drift velocity, we recently studied this equation. J is equal to NEVD, relation between current density and drift velocity. We say J is equal to NEVD. Now see, sir, drift current density, it is same at every point. If current density is same, number of free electrons per unit volume will be same, charge on an electron is same, means we can clearly see that drift velocity at A is equal to drift velocity at B is equal to drift velocity at C. So this will be the relation in case of drift velocity. This will be the relation in case of current density. This will be the relation in case of current. Is it clear? Now, can you guys tell me over here? Compare current density and drift velocity at A and B. Now you guys are supposed to compare over here current, drift velocity and this. Can you tell me in the live chat, everyone? Now see, let me just tell you over here. Sir, as for current, you recently said if this is a neutral conductor, means the amount of electrons flowing over here will be equal to the amount of electrons flowing over here. No matter, it does not matter, sir, area of cross section is different. So we say, sir, current at A will be equal to current at B. So current will be same. But when it comes to, sir, current density, we say, sir, current density J is equal to I by A. Now over here at this point, area is less. J is inversely proportional to A. Area is less, so density will be more. Over here, area is large. If area is large, density will be less. So we say, sir, current density at A is greater than current density at B. Now also, sir, J is equal to NEVD. Relation between current density and drift velocity. Now, it is directly proportional to the drift velocity. Now, if we say, sir, current density at this point is greater than this point, so drift velocity at A will be greater than drift velocity at B. As simple as that, because J and VD is having direct relation. Can you solve this question? The current density, drift velocity at A, B and C will be. Can you guys solve this particular question over here? Can you guys solve this particular question over here? Sir, over here in this case, as for current, we say, sir, IA is equal to IB is equal to IC is equal to ID. Okay? Because for a neutral conductor, we say current will be same at every point. Yes. Now, when it comes to the current density, sir, as current density is equal to J is equal to I by A. It is inversely proportional to area. So where there is a less area, current density will be more over there. Can you see D portion? Sir, at this particular point, area of cross section is less. So we say, sir, current density at D is more. It is greater than current density at A. It is greater than current density at A, which is greater than current density at B, and which is greater than current density at C. Now, if I talk about, sir, drift velocity, sir, as drift velocity and current density are having the same relation, J is equal to NEVD. So means whatever the relation will be for current density, same will be for drift velocity. So drift velocity VD is greater than VA, is greater than VB, is greater than VC. Is it clear to everyone? Ohm's law. Ohm's law. Let's talk about the Ohm's law. Now see, let's suppose I am taking a conductor over here. Let me give you the feel of Ohm's law. And this conductor is over here. This is the conductor over here. And inside this conductor, we know, sir, there are large number of free electrons. There are large number of free electrons. And we are connecting a battery to this particular conductor. And we are connecting a battery to this particular conductor. Okay. So we are connecting a battery to this particular conductor. And we know, sir, this battery will set up the electric field. Now listen to me very carefully. We know, sir, as due to the battery, or due to the potential difference of, or you say due to the potential difference V, or you say due to the battery, we say electric field is set up. Now, if electric field is set up, so these free electrons will experience the force. Now, we say electrons will move, or electrons are drifted. Electrons will move because of electric field. Yes, sir. These electrons will move because of electric field. So we say, so current is produced. So current is produced. We know, sir, whenever electrons move, whenever charge moves, current is produced. So we say current is produced over here. Now you tell me one thing, sir, because of this potential difference, electric field is set up. And because of this electric field, these free electrons experience force. Force is acting on these electrons. And because of that force, these electrons move. And because of the motion of electrons, we say current is produced. Can we not directly say, sir, if because of V, electric field is set up, because of electric field, sir, charge moves, and because of charge motion, current is being produced? We can directly say, so we can say, sir, we can directly say V is directly proportional to I. Sir, more you increase the potential difference, means more positive charge will be occupied over here, more negative charge will be occupied over here. Strong electric field will set up. Sir, strong force will act on these electrons. So more electrons will move, more current is produced. So directly we can say, sir, because of potential difference, current is being produced. Because of potential difference, current is being produced. Potential difference and current are directly proportional to each other. Yes, sir. And replace proportionality with a constant. And that constant is V is equal to R into I. This is what we call the Ohm's law. So we say, so according to Ohm's law said basically, the more you apply the potential difference across a conductor, more current will flow over here, more current is produced. According to Ohm's law, we say the more is potential difference across a conductor, more will be current. And most importantly, Ohm's law said, according to, this is the actual statement of Ohm's law. According to Ohm's law, current and potential difference are linearly proportional to each other. Okay, they are linearly proportional to each other. What does linearly proportional mean? V is directly proportional to I. V is not proportional to I square. Okay, that's what we say, linearly proportional. If I is 1, V is 1. If I is 2, V is 2. We say they are linearly. V is not proportional to I square. And this is, we say, this is what we call the Ohm's law. Simply, sir, Ohm's law says that if you apply a potential difference across a conductor, current will flow in that conductor. I told you why, because this is the logic. And that potential difference is equal to I into R, where R is the constant, where we say, let me just write over here, where R is the resistance of the conductor. Resistance means opposition to the current. If we have, let's suppose, for example, we have a conductor over here, okay? And inside this conductor, these electrons are moving. They are moving. So they are producing the current. So it is not like they'll move freely. There are atoms, molecules, ions over here with which they collide. So resistance is being produced over here to the current. Resistance is being produced to the flow of electrons. That's what we call the resistance. Is this clear, guys? Is this clear? Is this clear? Is this clear, guys? Duration of the class will be 8 to 10 hours. Okay, because there's a big chapter. 8 hours, we'll finish this chapter in 8 hours. Okay, great. Now, let's talk about the ohmic conductors. Sir, what does ohmic conductors mean? We say these are those materials which follow Ohm's law, which obey Ohm's law. What does Ohm's law say? V is directly proportional to I. V is directly proportional to I. This is what Ohm's law says. V is not directly proportional to I square. That is not Ohm's law. Potential difference is linearly proportional to the current. That's what Ohm's law says. And if you make the graph between potential difference and current, this is V and this is I. It will be a straight line. Why? Because for graph if the graph should be linear, then it has to be something like this. Because over here, V is directly proportional to I. If V was proportional to I square, then the graph would be something like this. But then we say it is not Ohm's law. Ohm's law is V is directly proportional to I. Linearly, V is linearly proportional to the current voltage. So this is basically the graph between V and I in case of Ohm's law. Okay. And for those materials, if I say this material is an ohmic conductor, means it follows Ohm's law. Means if you apply the potential difference across this conductor, we say current will flow and that will flow linearly. It is linearly proportional to I. Now, if I make the graph between potential difference and current, so the graph for Ohm's law will be straight line, I told you. Okay. So this is the graph for ohmic conductor, for that material which follows Ohm's law. Now, you guys tell me one thing. Over here, as we know, sir, V is equal to I into R according to Ohm's law. Can I just write, sir, V divided by I is equal to R? Yes. Now, from this graph, if I just ask you what is the value of slope, you say, sir, slope is nothing but, if I let's suppose tell you over here, if I let's suppose tell you over here, I have this graph over here. This is y and this is x. The graph is something like this. And if this is making angle theta, if I ask you to tell me the slope in this graph, sir, what is slope? Slope means how steeper it is. This is between the two graphs which is having more slope. Sir, this is having more slope. Why? This is having less slope because the slope is less. If you keep on increasing something like this, the slope will increase. And for this line, it is infinity. So we say slope is more. And how to calculate that steepness? Slope means steepness. How to calculate that slope? We say, sir, slope is equal to tan of theta. Slope is equal to tan theta. And that is equal to tan theta in trigonometry is equal to perpendicular by base. Like you have sine, perpendicular upon hypotenuse. Similarly, tan theta is perpendicular by base, which is equal. What is the perpendicular over here? Take this y over here. Okay, this is y and this base is x. So what is the perpendicular over here? That is y. And what is the base over here? That is x. So slope is y by x. Similarly, in case of potential and current graph, what is the value of slope? You say, sir, slope is tan of theta. And tan theta means perpendicular divided by base. And what is the perpendicular over here? That is this v. So, sir, this is v divided by, what is the base over here? Base is I. So, v divided by I. So, we say, sir, this slope comes out to be v divided by I in case of vi graph. In case of yx graph, it is y by x. Now, sir, this is equation first. This is equation second. From first and second, see, clearly you can see v divided by I is equal to r. V divided by I is equal to slope. So, can I say, sir, from first and second, we can clearly say that this r is equal to slope. Slope is equal to, sir, r. Means what I'm trying to say is that in case of VI graph, in case of VI graph, that is potential current graph, slope represents resistance. Slope represents resistance. Means from now onwards, if somebody gives you the graph between V and I, and if he asks you, tell me the resistance of that material, how much resistance this conductor will basically create. So you will find the slope of this because that slope is equal to the resistance of VI graph. Now, this is the important point what I'm trying to make over here, my dear friends. Now, listen to me very carefully. Now, over here, if I say on this y-axis, I place current. On this x-axis, I place potential. This can also be the case. Over here, you are placing the voltage. Over here, you are placing the current. If the graph comes out to be something like this, okay? Now, over here, can you guys tell me what is the value of slope? You say, sir, over here, slope will be simply perpendicular upon base, tan theta. Sir, perpendicular is how much? I. That is I. This, if you take it over here, this will be I. And base is how much? That is V. I divided by V. Okay. Now, according to, we say Ohm's law. According to Ohm's law. Now, according to Ohm's law, we say, sir, V is equal to I into R. V is equal to I into R. Okay. Now, from over here, can I just write, sir, R is equal to, sir, V divided by I? Now, yes. Now, if we do the reciprocal of this, I can write, sir, 1 divided by R is equal to, sir, I divided by V. Yes. Now, let's call this as equation first. Let's call this as equation second. So, I can write from equation first and equation second. I can write from equation first and second. See, over here, I by V is equal to slope. Over here, I by V is equal to 1 by R. So, can I say, sir, slope is equal to 1 by R. So, slope is equal to 1 divided by R. Now, what, sir? When it comes to V by I graph, over here, slope represents resistance directly. slope is directly proportional to the resistance. But when it comes to the IV graph, we say slope is equal to 1 by R inverse of resistance. So in case of we say IV graph, slope is inverse of a resistance. Slope is inverse of resistance. I hope this is clear, guys. See, from now onwards, if the questioner gives you the graph V by I and he asks you to find the resistance, you'll find slope directly. And if the questioner gives you IV graph and he asks you to find the resistance, he tells you to find the resistance, you'll find, sir, resistance, and then you'll do its, you'll find the slope and you'll do its inverse. That will be the resistance. Now, let me just give you the question over here. Let me just give you the question. That will give you more feel. First, we'll solve this question. Now, we have a VI graph. Now, first graph is this A. Now, we have 3 conductors. For first conductor, the graph comes out to be something like this, VI graph. For second conductor, potential difference changes with current, something like this. Now, for conductor C, this is the graph. You have to tell me, in these 3 conductors, which has got more resistance? In these 3 conductors, which has got more resistance? Now, as we know, in case of VI graph, listen to me, my dear friends. In case of VI graph, if we have to find the resistance, we find slope. Sir, slope is directly proportional to the resistance. Now, clearly we can see over here, sir, slope of A is more than slope of B, than slope of C. Slope of C is less. Why? Because this is not that steeper. Slope is increasing. So we can say, sir, over here, slope of A is greater than slope of B is greater than slope of C. Now, slope is directly proportional to the resistance in case of VI graph. So we say resistance of A, this conductor has got more resistance, and resistance of B is greater, and then we have resistance of C. Guys, is this clear? Is this clear? I just need to know. If I give you the same question over here, okay, this is over here I and this is B. Now the graph is IV. Now over here I am giving you the IV graph. Now this is the same conductor A, B, and this is C. This is A and this is B, this is C. Now in this case I am asking you the question, compare the resistance of A, B, and C. Compare the resistance of A, B, and C. Now over here, as in case of we say IV graph. In case of IV graph, we say, sir, slope is inversely proportional to the resistance. I told you few minutes back. Slope is inversely proportional to the resistance in case of IV graph. Now, if you have to find the resistance of the 3, how do you find it? Sir, over here, see, slope is inversely proportional to the resistance. The one which has got more slope will have less resistance. Over here, A has got more slope, so its resistance will be less because slope is inversely proportional to resistance. So we say this conductor, resistance of A is less than resistance of B is less than resistance of C. So C will have more resistance in this case. Guys, I hope you like this. Is it clear? Guys? C has got more resistance because slope is inversely proportional to the resistance. Is it clear to each and everyone? And guys, I want all of you to like this session. Make it 400 plus right now. Make it 400 plus right now, every one of you. Okay, now let's come over here once again, and see, in case of and for ohmic conductors, we say, sir, VI graph, potential difference versus current graph, is a straight line. And we know for a straight line, the slope is constant. Okay, remember from now onwards, sir, slope is what? Steepness. Over here, what does slope indicate? Resistance. And for a straight line, slope is constant, means a resistance is constant. Okay, that's what I said. Sir, we know in Ohm's law, V is equal to IR, where R is the resistance and is constant, depends upon the material. So we say over here, sir, resistance slope is constant, resistance is constant in this particular case. So for ohmic conductor, slope is constant, resistance is constant. Now, if we talk about, sir, non-ohmic conductors, these are those materials. If I say this is a non-ohmic material, these are those materials which do not follow Ohm's law. Now see, sir, what is Ohm's law? Ohm's law says V is directly proportional to I. But what? Linearly. V is not proportional to I square. Over here, if you see, sir, for non-ohmic conductors, the graph is something like this. This is not a linear graph. This is a curve graph. Sir, in this case, does potential difference vary with current? Yes. For non-ohmic conductors also, here also, we say potential difference varies with current. Potential difference varies with current for non-ohmic conductors, but not linearly. That's what I'm trying to say. This is the difference between ohmic and non-ohmic conductors. Means over here, if the graph is curved, will the slope be constant, sir? No. For a straight line, slope is constant. So we say over here, slope is not constant. If slope is not constant, means resistance is not constant. Resistance is changing over here. And we know in Ohm's law, resistance is constant. Is it clear, guys? Is it clear to each and everyone? Now, can you tell me the value of resistance over here? Find the ratio of resistance of A and B. You guys are supposed to find RA divided by RB. You have got one conductor over here, that is A. Another conductor over here, that is B. And then you have to find the ratio of their resistance. How much is the resistance of A divided by resistance of B? As we know, sir, resistance in case of VI graph represents slope. And slope is what? Slope is tan of theta. Now, sir, for RA, if we just write resistance of this, so we write, if this angle is 30, how much this will be? This will be 60, because total is 90. So we say resistance of A is nothing but slope of A. We say, sir, slope of A divided by resistance of B is nothing but slope of B. Now, slope of A means tan of this angle. How much A is making the angle? That is tan of 60 degrees. Divided by resistance of this B is nothing but tan of 30 degrees. Okay. Okay. Is this clear to each and every one, guys? Let me know in the live chat. Okay. Put up the values. Yes, 1/3. Put up the values and you'll get the answer. Let's move on to the next one. Resistance. Let's talk about the resistance. Let's talk about the resistance. Is it crystal clear, Ro? Is everything sorted? अरे वही यार लगा दे इसमें क्या लगाना है just put up the value of tan 60/30 okay whatever the answer is that is the correct answer And when it is 90 degrees means slope is infinite. In that case, we say slope is infinite. Now see, let's talk about the resistance. What is resistance? Let me just show you over here. Let's suppose we have a conductor over here. Let's suppose this is a conductor we have. Okay. This is the conductor we have. And we have another conductor over here. We have another conductor over here. Okay. Let me just make it over here only. This is the conductor. Now, inside this conductor, we have free electrons. We have free electrons. Listen to me very carefully. Now, as these free electrons move, as they move in a forward direction or in this direction or in this direction, listen to me very carefully. We say, sir, current is produced. Yes, current is produced. But it is not like these free electrons will move freely. Okay, there is no hindrance to them. No, there is actually hindrance to them. We say over here, we have atoms, ions, molecules over here. So they collide with these atoms, ions, molecules. So this become the resistance. This become the resistance. We say when electrons move in a conductor, we say they suffer collisions. They suffer collisions. due to which resistance is produced. Due to which resistance is produced to the flow of electrons. Due to which resistance is produced to the flow of electrons. Okay. So that's what we call the resistance over here. That's what we call the resistance over here. And if we talk about this resistance, sir, what is resistance? It is opposition to the flow of electrons, opposition to the current. More collisions these electrons suffer, more is the resistance. Now we say this resistance is directly proportional to length. If length of conductor is more, we say, sir, these free electrons have to face more collisions because lot of over here atoms, ions, molecules are present in the longer conductor. So we say resistance is proportional to the length. If length is more, they have to suffer more collisions, so resistance will be more. And we say, sir, this resistance is inversely proportional to the area of cross section. Now, if we make a bigger area over here, sir, in this bigger area, it is easy, sir, if let's suppose these are the atoms, ions, molecules. Sir, it is easy for these electrons to move over here because the collisions will be less if area of cross section increases. So we say resistance is inversely proportional to area. So we can clearly see in this particular case, sir, this if we combine these two, so R is proportional to L divided by A. Now replace this proportionality with a constant, and that constant is what we call the rho L divided by A, where rho is called resistivity of the material and R is called the resistance, L is the length of conductor, A is the area. What is resistivity? Resistivity basically tells you how much resistance will be created inside a conductor. If I say, let's suppose we have got two conductors. This is a first wire over here. This is another conductor over here. If I say resistivity of this conductor is more, resistivity of this conductor is less, means resistance will be more in this conductor, resistance will be more in this conductor, resistance will be less in this conductor. Resistivity gives you an idea. Resistivity gives us an idea how much resistance a material can produce. More is the resistivity of a material, more will be the resistance. Less is the resistivity, less will be the resistance. Is it clear, guys? So formula for resistance is rho L by A, where rho is the resistivity, L is the length, A is the area, and R is the resistance. That's what is mentioned on this particular slide, where rho is the resistivity or specific resistance. Resistivity does not depend upon length, area, and resistance, okay? It depends upon the material, nature of material. Is it clear? Is it clear to each and everyone? Guys. Let me know in the live chat, everyone with the fire symbols. Is it clear to each and everyone? Okay. Now, let's suppose we have got a conductor over here, okay? This is the conductor we have. This is the conductor we have over here. And the radius of the conductor is R. Resistivity is given as rho. And this length of conductor is given as L. Length of conductor is given as L. The length of conductor is given as L. Find the resistance of the given conductor. See, as we know, resistance is equal to rho L divided by A. Now we can say, sir, this resistance is equal to rho L. L is the length of conductor upon A. Now area is not given over here, but radius of this is given. So we can say, sir, instead of area, I can write pi r square, because area of cross section will be pi r square. Now the same question I am giving you over here. Now in this particular case, this is hollow. This is a conductor, but the conductor looks something like this. Let me make it over here. The conductor looks something like this. The conductor looks something like this, okay? And the radius of this is given as, the radius of inner conductor is given as, this is given as R, and the radius of this outer shell is given as 3R. Inside this is hollow, so current will flow from between the two conductors. From this surface, current is flowing. It is like, see, I have got one conductor over here, okay? And another conductor I am placing outside of the smaller conductor, okay? Cylinder, I have got two cylinders. And this is, current will flow from this area. Current will flow from this material. Current will not flow from the hollow side, because inside it is hollow, it is nothing. So current cannot. Sir, does it depend upon temperature? Yes, it depends upon temperature. That is what we have to study after some time. So we say current will not flow from this side, flow through this hollow part, okay? Now in this case, you guys are supposed to tell me, find the resistance of the concentric cylinders in the given figure. How much resistance will be over here produced to the flow of electrons to the current? How much resistance will be over here? Now over here, current will not flow through hollow part. So current will not flow through hollow part. Current flows, see, if I say current is flowing through this part only, not through hollow part. So we say this part of this particular conductor will only create the resistance. This will only produce the resistance, not the part which is inside hollow. Now, how to find how much is this? Let me just show you. How much is the entire area? From, see, if I tell you what is the area of this bigger cylinder, you say, sir, area of bigger cylinder is pi r square. R is how much radius of bigger cylinder is, that is 3r whole square. Listen to this very carefully, guys. Then you have how much is the area of smaller cylinder? Then we say minus pi into r square, because the radius of smaller cylinder is this. See, it is like, let me just show you something like this. This is the bigger cylinder. This is the smaller cylinder. Now, this radius is 3r, and this radius is r. If you have to find this, how much is this area? What will you do? Sir, total area minus this hollow area, you will get this area. Total area is pi into 3r square minus this hollow will be pi into r square. So this will be 9 pi r square minus pi r square. So that will be 8 pi r square. So we say in this case, so we say as here current flows through 8 pi r square area only. Guys, is it clear or you got confused over here? Is it clear? Current flows through 8 pi r square only. 8 pi r square area only. Now, you guys tell me what will be the resistance, sir? Resistance is rho L divided by A. Sir, R is equal to rho. What is the length of conductor? L divided by area. You will put up that area through which current is flowing. That is 8 pi r square. Because this area only will create the resistance. So that is 8 pi r square. Is it clear, guys? Or I am confusing you? I am confusing you, or is it clear to each and every one? Okay, great. Crystal clear. I'll give you the break at 8 o'clock. It is 7 right now. Break will be at 8. Now let's move on to this one. Okay. I hope this is visible. You are given a cube over here. Let me make it something like this. Let me make it something like this. This length is given as A. This is given as A. And this length is given, this side is having the length of C. And this is having the B. This is B. And current is flowing something like this. Current flows something like this. This is the current I. This is a conductor of cube-shaped conductor. Cube-shaped conductor. You are supposed to find a resistance. Find resistance in this cube-shaped conductor. How to find the resistance of this cube-shaped conductor? See, every conductor in which current flows produce resistance. How to find the resistance over here? We know, sir, the formula for resistance is rho L divided by A. Now, take the length of conductor, that one, through which the current is flowing. If current is flowing something like this, so take the length as A. Now, current is flowing along A. Over here, this current I is flowing along A. So, take this length as A. Here, length is equal to A. Okay. And this current is crossing this area. This current is crossing this area. So, this area will be how much? Length into breadth. Length is C, breadth is B. So, we say area is equal to C into B. Okay. Simply what I am saying is that if you have to find the resistance over here, take length of conductor, that one along which current is flowing. Here I is flowing along A, so length is A. Area will be, sir, that side through which current is crossing, so that is CB. So resistance will be your rho. Instead of L, we say A divided by, this is small a, rho A divided by BC. Let's suppose if I give you the question something like this. Let's suppose I'm taking the same cube over here. Now see, in this case, current is flowing something like this. In this case, current flows something like this. This is I. This length is given as A, and this is given as C, and this is given as B in this case. What will be the resistance over here? Sir, resistance is rho L by A. I told you take the length That one, take that one as length through which current is flowing. Current is flowing along C. So rho C divided by. Now area, it is crossing this area. How to find the area of this one? This length, that is B, multiplied by this length, that is A. So that was A into B. Is it clear? Is it clear? Is it done and dusted, guys? The resistance of a conductor is R and the length is L with radius R. Okay. We are given a conductor over here. Okay. And the length of the conductor is L. The radius is given as R. We are supposed to find its resistance. So resistance will be a rho L divided by pi R square. Now, the questioner says that if the length is doubled, if you basically take this conductor and if you double its length, this is L dash will become 2L. And radius is also doubled. This R dash will become 2R. Find new resistance. We are supposed to find R dash. Now see, sir, R dash will be rho L. What is L over here? That is 2L. Instead of L dash, because its length is 2L. So that is 2L. Divided by area. Rho L divided by area. What is the area over here? Area is pi R square. And what is R in this case? R is doubled. Over here, radius was R. Over here, it is 2R. So that is 2R whole square. So this will be rho into 2L upon. This will be pi into 4R square. 2 ones, 2 2s. So this radius will be R dash rho L upon 2 pi R square. Now, rho L upon pi R square. Rho L upon pi R square is R. So we can say this will be R divided by 2. So new resistance will be R by 2. New resistance will be R by 2. New resistance will be R by 2. Is it clear, guys? Each and every one, let me know. Is it clear? Is it clear? Now comes one more important topic that I want to teach you over here. Sir, see, guys, I told you the formula for Ohm's law. What is the formula for Ohm's law? That is V is equal to IR. Okay. And I told you the formula for resistance. R is equal to rho L by A. And now I will tell you the different formula, which is the actual formula for Ohm's law. And which is the actual equation for resistance. Which is the another one. I'll tell you the equation for resistivity. I'll tell you the equation for conductivity. This is something which is pure gold. Pure gold. Okay. That I will be giving you in this one. Okay. Everyone. Listen to me very, very, very carefully over here. My dear people, if I just tell you in this particular case, see, as sir, we have studied Ohm's law, resistance, resistivity. What will you teach now? I'll teach you something which is pure gold. Listen to me very carefully. As we know, sir, current I is equal to NEAVD. Relation between current and drift velocity already told you. Also, sir, we know VD is equal to EE divided by M into tau. This is the formula for drift velocity. Sir, E is the charge on an electron. Capital E is the electric field. M is the mass of electron. T is the relaxation time. Now, these two formulas already studied. Yes, sir. Now, from this first formula, can we just write, sir, I upon NEA is equal to VD. I upon NEA is equal to VD. Yes, sir. Let me just write over here. From first formula, I can write, sir, VD is equal to, I upon NEA, I upon NEA. Yes. Now, this formula, this one over here, let's call this as equation number second. This is first, and this is equation number third. Now see, sir, VD is equal to EE by M into tau. VD is equal to I upon NEA. Can we equate these two? Yes, equate second and third equation. Yes, sir, we can do it. So we can clearly see over here, I upon NEA is equal to, so this will be, sir, or so we can write, sir, EE divided by M into this tau will be equal to this, that is I divided by NEA. Okay. Yes, sir, it is crystal and clear. Now, my dear friends, can I take this? See, what I'll do over here is that, take this E, multiply with this E over here. So this will be E into E becomes E square. And this multiply this M over here. So what remains in this case is E is equal to, I am multiplying this E in the denominator over here. Already I is there, divided by E into E becomes, then we have N E square into this A, N E square into A. And if you take this tau also in the denominator, you can see this tau, and take this M in the numerator. So this will be, sir, M over here. So what remains from this side, that is E only, this is E. I'm just reshuffling it. And I'm doing nothing. I'm just reshuffling it. Now, my dear friends, as we as we know, see, electric field is equal to V divided by L. If we have a conductor, and you have connected a potential difference V, you have connected a battery V to it, potential difference V. Due to this battery, electric field is set up as E. The length of the conductor is L. And if somebody asks you, what is the value of this electric field in terms of potential difference, we say E is equal to V by L. In case of capacitors, I have told you, E is equal to V by L. Now, my dear friends, this is electric field in terms of voltage and length. So we can write, sir, over here instead of this, V divided by L is equal to, this will be I into M upon NE square A into tau. Now take this L, multiply over here. V is equal to I M L upon, then you have NE square A into tau. Just do one thing. Take this I and put it over here. Take this I, write it separately over here. It will not create any difference. Now, this is the formula which we actually got. Now, compare with, or you can write it directly. Just keep it over here. This MIL. This is the microscopic form of Ohm's law. Sir, we have studied Ohm's law, V is equal to IR. What if I tell you this is also V is equal to IR? But this is the microscopic form. We have basically entered inside the conductor. This is the microscopic form of Ohm's law. V is equal to MIL upon NE square A into tau. Sir, what is I? I is the current flowing through the conductor. Sir, what is M? M is the mass of electrons. Sir, what is L? L is the length of conductor. N is number of free electrons per unit volume. E is charge on an electron. A is area of cross section. T, tau is relaxation time. Now, my dear friends, I'll take the same formula as V is equal to, I'll just write this one, ML upon NE square A into tau. We say ML upon NE square A into tau, and then we multiply over here I. What if I tell you this is the Ohm's law? Sir, I'll just write compare. Compare with. Guys. I'll just write compare with V is equal to I into R. Now, or V is equal to R into I, just write R into I. Now see, sir, over here we have V, over here we have V. Over here we have I, over here we have R. But over here we have resistance, we have over here, sir, R is equal to, that is ML upon, we say N E square, then A into tau. So we say this is the actual, this is the actual formula. This is the actual formula of resistance. This is the actual formula of resistance. Sir, we have studied resistance R is equal to rho L by A. What is this? This is also rho L by A. Let me just give you the feel. I say compare with R is equal to rho L divided by A. My dear friends, you have R over here, you have R over here. You have length over here, you have length over here. You have area over here, you have area over here. But you have resistivity rho over here. You have M N E square into tau over here. So we say resistivity is equal to, sir, that is M upon, we say N E square into tau. Rest L by A, which this is the formula for resistivity. This is the actual formula for resistivity. This is the actual formula for resistivity. As I told you guys, this is a pure gold. You guys will love it, as I told you before only. Now see, sir, resistivity as resistivity is inversely proportional to the conductivity. Or conductivity is inversely proportional to the resistivity. You write it something like that. Okay? Write it something like this. Sir, conductivity is inversely proportional to resistivity. Now, this conductivity sigma is inversely proportional to resistivity is rho. Sir, what is conductivity? If I say I have over here a material, it has got more resistivity, means it will create more resistance, means it will have less conductivity. Conductivity means how much current will flow through this. More will be the conductivity of this material, more current will be flowing through this material. Less is the conductivity, less will be the current through this. So we say if we have a material, if its conductivity is more, its resistivity will be less. It will create less resistance. If we say if we have a material, its resistivity is more, its conductivity will be less. Now we can write this conductivity as 1 upon rho. 1 upon rho means, okay, where is rho? 1 upon rho means M upon N E square, or inverse of resistance. That will be simply N E square tau divided by M. Did you like this? Did you like this, guys? As I told you, this is pure gold. Tell me, how was it? The actual formulas. This you can find in the good books, okay? This you can find in the good books. Let me know in the live chat, guys. Everybody. I'm waiting for your comments only. I'll be sending the capacitor PDF also. Don't worry about that. Is it clear? Any sort of confusion anywhere, or this is crystal clear, Now, my dear people, let me just tell you over here. This is what we call the master concept. All of this, what I have told you in the previous 2 slides, is just mentioned in these 4 boxes. The first equation we have over here, I hope this is visible. Yes. That is VD is equal to EE by M into tau. Then you have I is equal to NEA VDV. Now from these two equations, you got V is equal to MLI upon NE square tau into A. Now compare it with V is equal to IR. Over here, you will get the resistance formula for resistance ML upon NE square tau into A. And then if you compare this with rho L by A, R is equal to rho L by A, you'll get the formula for resistivity. And from resistivity, if you find conductivity, okay, so we say, sir, conductivity is inverse of resistivity. So you'll get the value of conductivity. This is what I have told you in these two slides completely is available over here in this particular slide. This is one shot, not the first part. Okay, we have to complete the entire chapter. Is it crystal clear, guys? I want you to make the likes. Have we crossed the likes more than 400? Guys, if you have not liked it, like the session as soon as possible. That is mandatory. Okay, everyone. Okay. Great. Me sitting in the corner with 2 accounts. This is for you. Okay. Now, temperature dependence of resistance and resistivity. Temperature dependence of resistance and resistivity. What does it mean? Let me just tell you about this concept right now. Let me just tell you about this particular concept. Now see, let's suppose we have a conductor over here. Okay. This conductor has got some resistance. Okay. It has got some resistance. Now, at temperature, we say at temperature, we say T naught. Okay. We say at temperature T naught, or we say, sir, at temperature 0 Kelvin. It has resistance. R naught. We have got a material over here. We have got a conductor over here. The temperature right now is, let's suppose, 0 Kelvin or initial temperature Ti. Okay. And it has got the resistance of R naught. Now, if we increase or if we change the temperature, let's suppose increase, if we change the temperature, let me write if we change the temperature, okay, by any means, if we change the temperature to T final, we say its resistance will also change. Its resistance will also change. That's what we say. Temperature dependence of resistance. If you have a material, if you change its temperature, let's suppose you are increasing its temperature, we say its resistance will also increase. Its resistance will also change. Don't say increase. Its resistance will also change. By changing the temperature, resistance changes. So resistance depends upon temperature. Temperature dependence of resistance and resistivity. Sir, how does it actually happen? Let me just tell you over here. See, we know, sir, in a conductor, let's suppose these are the free electrons which move in a conductor. Okay. Now, inside this conductor, we have these atoms, ions, molecules over here. Okay, fine. As these electrons move, they have to suffer collisions. They have to face these collisions. Now, if you increase the temperature of this one, by any means, you are increasing the temperature. Okay, you are heating this. Whatever you are doing, you are sending the heat. You are increasing the temperature. We say, sir, whenever we increase the temperature of a material, these atoms, ions, molecules over here, they will start vibrating. They will gain energy. They start vibrating. If they will start vibrating, listen to me very carefully. If the vibrations increase, now these electrons which were moving have to face more collisions. As we say, as if we increase, as we increase temperature in a conductor, vibrations will increase. Vibrations will increase. So we say electrons face more resistance. Electrons face more resistance. So resistance will increase, resistance will change. Now, my dear friends, what will be the final value of resistance? So finally, it will be, resistance will be, listen to me very carefully. Sir, at 0 Kelvin, how much was the resistance? R0. And if you increase the temperature, to TF, how much is the resistance? That resistance will be RF. That is final resistance, or resistance at temperature T is equal to RF is equal to R0 into 1 plus alpha delta T. 1 plus alpha delta T. R0 is the initial resistance at 0 Kelvin. RF is the final resistance when you increase the temperature, when you change the temperature. 1 is 1. 1 is that which comes before 2. Then we have alpha. Alpha is the temperature dependence, temperature coefficient of resistance. Okay. Temperature coefficient of resistance and resistivity. And then you have this delta T. Delta T is the change in temperature. Delta T is the change in temperature. How much temperature you changed? Sir, it is nothing but T final minus T initial. And this alpha tells you over here. How much resistance will be created over here in case of different materials. So this will be the final resistance. Is it clear, guys? Now, remember this. In case of conductors, we said this alpha is positive. Just remember it as simple as that. And in case of semiconductors, we say the value of this alpha is negative. Because I'll tell you the logic. See, I'll tell you the logic over here. Listen to me very carefully. If I say, let's suppose, for example, we have a conductor over here. Sir, you increase the temperature of this conductor, its resistance will increase. Now, what will be the final resistance? RF is equal to R0 1 plus alpha delta T. Okay. Now, alpha is what we say temperature coefficient of resistance over here, which tells you, alpha tells you on increasing how much temperature, how much will be the increase in, how much will be the change in resistance. Simply. Now, my dear friends, if I say for a conductor alpha is positive, now see, this alpha is positive, means the final resistance will be R0 plus something, plus this R0 into plus something, that is R0 alpha delta T. So means sir, R0 is the initial resistance. So if you are adding something to the initial resistance, then only final resistance will increase. And we know, sir, when it comes to the conductor, on increasing the temperature, we know resistance increases, and resistance will only increase if you take alpha positive. Let's suppose if you take alpha negative, so it will be R0 minus something, means you are decreasing the resistance from initial resistance. So then that is invalid. See, what I'm trying to say is that if I have a conductor, we know, sir, if we increase the temperature of this conductor, its resistance will increase. If its resistance increases, why? Because it is a conductor. And that is only possible if you take alpha as positive. Because if you put alpha positive over here, then only something will be added to R0. Okay, so means then only final resistance will increase. If initial resistance is 5 plus something, let's suppose this is 2, 5 plus 2 is 7, so means final resistance is 7. Now if you say we will put negative over here, so it will be R naught, 5 minus 2, it will be 3, so that is invalid. Similarly, in case of semiconductors, we say alpha is negative. Let me know in the live chat if you understood what I'm trying to say. If you are not able to understand what I am saying, just remember directly for conductor, alpha is positive, for semiconductor, alpha is negative. Is it clear, guys? In the live chat, everyone, give me the signal. Then I have to move forward. Okay, battery. Now we need to talk about the battery. Now see, what is a battery? Sir, we know you have told us in capacitors also, the battery, the symbol of battery is something like this. This is what we call the positive terminal or higher potential. This is what we call the negative terminal, that is lower potential. This is how the battery looks like. And we say this battery is nothing but it is a source of energy. Source of energy. Sir, what does source of energy mean? It provides energy. It provides energy. So this battery provides energy to the electrons. This battery provides energy to the electrons due to which they move. It is like, see, as I told you, if you connect a battery over here to this conductor, what will this battery do? This battery will set up electric field. What is that? That is nothing but it is basically giving energy due to which these electrons were flowing in this conductor, which I told you. So that's why we say battery is a source of energy. It maintains the potential difference. Over here, it creates the potential difference. That is, let's suppose V, it maintains the, it supplies the potential difference, maintains the potential difference. Okay. Now, what I'm trying to say is that we have two types of batteries. The first one is non-ideal battery. Then we have ideal battery. Sir, what is an ideal battery? See, till now, in the circuits, we were using a battery like over there in case of capacitors. I told you we have a capacitor. We have one more capacitor and we are connecting a battery to it. Which battery was this? I was using the ideal battery. Sir, what does ideal battery mean? If we talk about the ideal battery. Sir, ideal battery means it is something like this. You have got a battery and it does not have the internal resistance. We consider its internal resistance R is equal to 0. Internal resistance. Sir, if we have a battery, does a battery have internal resistance also? Yes. Battery has its own resistance. That resistance, if I say we have a conductor, does this conductor have resistance? Yes. It has its own resistance. Similarly, if we have a battery, does that battery have internal resistance? Yes. It has its own resistance. And when we talk about the real battery or non-ideal battery, which we use in our real life, we consider its internal resistance. Non-ideal battery. Okay, so it is something like this. So this will be its internal resistance and this is the EMF. This is the potential difference, E or V, and this is internal resistance. We say as battery has its own resistance. Battery has its own resistance called internal resistance. Okay. And when we talk about the ideal battery, we consider here actually it has internal resistance, but whenever we consider its internal resistance is 0, means we have taken the non-ideal. We have taken the ideal battery. That's what is mentioned over here. For non-ideal battery, internal resistance is mentioned. For ideal battery, we say internal resistance is 0. Now, how to find the potential at point? Can you guys tell me what is the potential of this end? We have a battery over here. Potential of this end VA is 4 volts. Potential difference is 10 volts. What is the potential difference V? 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 Like the session, guys, if you have not liked the session yet. What is the potential difference V? Everyone. Ganesh, why are you saying 6? I told you it is higher potential minus lower potential. Higher potential is that side which has got this side has got which positive terminal. So this will be higher potential. This is VB. If you say VB, how to find this? I have told you, sir, higher minus lower. We say, sir, VB minus VA is equal to, sir, delta V. Now, sir, VB minus VA. Sir, previously you said VA minus VB. Over there, I have taken the battery something like this. This was A, this was B. That's why VA, do VA minus VB only when higher potential is from A side. Now, in this case, higher potential is from B side. Why are you marking the same wrong answer, guys, again and again? So we say VB minus VA will be equal to the delta V. Now VB is how much? We have to calculate. Minus VA is how much? That is 4 volts is equal to delta V. Delta V is this. We know, sir, this potential difference is equal to this. So that is equal to, sir, 10. If you take it over here, VB will come out to be 14 volts. 14 is the correct answer. Why are you marking? Why are you saying 6? Yes. Now, I don't want you guys to do this method. This was basically method 1. This is method 1. Okay. This is the old method. We'll not be solving the questions by using this method. Now remember method 2. Method 2. Method number 2nd, and which is pure gold. Which is pure gold. 24 karat. Okay. Pure gold. Now see, let me just tell you in this particular case, my dear friends, if you have to find the potential at any point, what is the first step that you will be doing is that select the path. Select the path. Select the path. Sir, what does that mean? That means if I am selecting the path, let's suppose I am selecting the path from A to B. From A to B. Means I have to move from A to B. Sir, what does that moving mean? I'll tell you. Sir, can you not select the path from B to A? Yes. That will also give me the correct answer, same answer. Let me just tell you, if you select the path, then step number 2 is move. Move along the path. What does that moving along the path means? Let me just tell you. If we are moving from A to B, first we'll write the potential of A, that is VA. This point has got potential VA. Then over here, after this VA, we reach this battery. Now, in case of battery, if you are going from lower potential to higher potential, listen to me very carefully. This is negative, that is lower potential. This is positive, that is higher potential. If you are going from lower potential to higher potential, then take its potential drop as positive. We say, sir, plus 10 volts. If we were going from higher potential to lower potential, then we would have taken it positive. If we move from lower to higher potential, then we take potential drop as positive. And if if we move from higher to lower, higher to lower, then we take potential drop as negative. This is what I was trying to say. So VA, then because our path is from A to B, so now over here we are moving from lower to higher, so we take it plus 10 is equal to, finally we reach point B, that is VB. Now what is the potential VA? VA is given as 4 plus this is 10 is equal to VB. So that is, sir, 14 is equal to VB. So over here also 14, over here also 14. This is the method number 2nd. Now see, I'll solve the same question by taking the another path. Let me just take the same question over here. And this is 4 volts, that is VA. And this is VB you are supposed to calculate. And this is 10 volts, that is potential difference. Now in this case, I'll take the path from B to A. From B to A. What is the first thing we are supposed to do? Select the path. Okay, select the path from B to A. Now, if we have selected the path from B to A, then move from B to A. First, we'll write the potential of VB. Why? Because we are moving from B to A. So it will be VB. Okay. Then once from B to A, once we reach the battery, sir, in battery, we are moving from higher potential to lower potential. See, if we move from higher potential to lower potential, we take its potential difference as negative. So its potential is 10 and it will be negative. Previously, when we were moving from lower to higher, we took as positive is equal to, finally we reached point VA. Now this VB, and if you take it over there, that will be VA. This is minus 10, it will be plus 10. VA is given as 4 plus 10 is equal to 14. Same answer again by 3 different methods. Is it clear, guys? Is it clear, guys? Now, solo. Okay. This over here we have resistance. Let me show you this question. I'll show you one and then rest of the questions you will solve. If I say, for example, we have to find potential VB in this case. We have to find this potential. What is the first thing that we do? Select the path. Select the path. Okay, yes. Let's suppose we are selecting the path from A to B, from this point to this point. This is point A and that is point B. Now see, over here, sir, in this case, we are given this point has a potential of 10 volts. And then in this case, we are given a resistance of 5 ohms. And then over here, we are given potential VB. That's what we are supposed to calculate. And current is also given in this case. How much current is flowing? 5 ampere. Remember, my dear friends, current always flow from higher potential to lower potential. So means if we talk about this resistor, just mark this as positive and mark this as negative. This is higher potential, this is lower potential. Because current flows from higher to lower. If it was something like this, this is the resistance over here. If I say current is something like this 5 ampere current, then I would have said this is positive and this is negative because current flows from higher to lower. Now, same is what I'm saying over here. This is from positive to negative. When you select the path, now move. Let's suppose first we'll write the point VA because we are moving from A to B. So this is VA. And then, sir, once we move from point A and we reach the resistance over here. And in case of resistance, my dear friends, we are moving from positive to negative, that is from higher to lower. And whenever we move from higher to lower, we take potential drop as negative. So means potential drop or potential difference in resistance we take as negative. So that will be negative. Now the question is, previously when it was battery over here, we were directly writing the potential difference of the battery, that is 10. But right now we have resistance over here. How to find the potential drop in resistance? That is IV is equal to I into R. Ohm's law. V is equal to I into R. I is the current in resistance. R is the resistance. So we say I into R. And you have to take this IR or this potential difference as negative because you are moving from plus to minus. and then you reach the point B, that is VB. So VA is given as over here 10 minus I is given how much, that is 5, into resistance is given as 5 is equal to, we say, sir, VB. 10 minus 25 is equal to VB. So VB will come out to be minus 15 volts. Can you solve? Is it clear, guys? Is it clear? Now, can you solve this question? Tell me what is the potential of this point. Let's call this as point B and let's call this as point A. Tell me the answer of this question, guys. What is the potential of this point B? What is the potential of this point B? Everyone. What is the potential of this point B? What is the first thing that we do? Select the path. Select the path. That is the first thing we do. So we are selecting the path from A to B. From A to B. So we select the path from A to B. Then write the potential from A to B. So we say, sir, first we'll write the potential of VA over here. And now, in this particular case, sir, current flows in this direction. Current is 2 ampere. So means this will be positive and this will be negative. Mention this positive and negative. And if we write the potential A, then in case of resistance, we are moving from minus to plus, that is lower to higher. So whenever we move from low to high, we take potential drop as positive. And its potential difference will be I into R. Its potential difference will be I into R. And then we reach this point B, that is VB. We reach this point B, that is VB. Now VA is how much? That is 8 volts plus I into R. I is given in this case, that is 6. Sorry, I is 2 and R is 6. So 6 into 2 is equal to, sir, VB. Now 6 into 2 is 12. 12 plus 8 is, that is 20 is equal to VB. So 20 volts will be VB. How many of you got the 20? Yes, great. Now tell me, what is VA minus VB? Find the potential difference VA minus VB in this case. Potential difference VA minus VB in this case. What is potential difference VA minus VB in this case? Everyone, let me know, guys, what is the potential difference VA minus VB in this case? And if you have not liked the session, like it as soon as possible. Everyone. Okay, what is the first thing we do? Sir, first thing we do is select the path. Select the path. Okay. So let's select the path from A to B. Okay. We say, sir, A to B. Now, the direction of current is this. So we say current flows from higher potential to lower potential. This is positive and this is negative. So we can write the potential VA. This is potential VA over here. Okay. And then you have over here, sir, in case of this resistance, you are moving from higher to lower. So we take it negative I into R. And in case of resistance, we write potential difference as IR. Now over here, it is a battery. Sir, in battery, we are also moving from higher to lower because this is positive terminal, this is negative. So, and this will be minus how much? That is 3 volts. Minus 3 is equal to, then we reached, sir, potential VB. VA minus IR minus 3 is equal to VB. Now, my dear people, can I just say, sir, this is VA minus I. I is how much? That is 2. And R is how much? Sir, that is 4. Minus 3 is equal to VB in this case. Sir, VA minus 2 4s 8 minus 3. And that is minus 3 is equal to VB. Now, sir, 8 minus 3 is minus 11. If you take it over here, so this will be, take this VB over there, VA minus VB will be 11 volts. Nobody in the comments have given me the answer. What are you guys doing? Okay, this was the question asked in NEET 2016. Tell me, find the potential difference between A and B. Find VA minus VB in this case. This was the question asked in NEET 2019. Find VA minus VB. Find VA minus VB in this case. VA minus VB. Find VA minus VB in this case. What is the value of VA minus VB in this particular case? I'm waiting for you guys to answer. See, what is the first thing that we do? We select the path. Let's select the path from A to B. Okay. The first thing we do is select the path. Select the path. Now, if we are moving from A to B, let me write the potential of VA first. Okay. Then over here, sir, current flows in this direction, means this is positive, this is negative. Over here also, this will be positive, this is negative. Now in this resistor, we are moving from positive to negative, higher to lower. So this will be minus I into R. And then in this battery, we are moving from higher to lower. So this will be minus 3 volts over here. And then in this resistor also, we are moving from higher to lower. So this will be also minus I into R over here is equal to, finally we reach point B. Okay. The last one we write it is equal to. Now VA we can write as it is minus I into R. I is how much? Current current flowing is 2. 2 into 2 is how much? We say, sir, 4 volt minus 3 volt minus I into R. In this case, sir, R is 1 and same current will flow over here also because this is in series. So 2 into 1 is 2. So that is 2 volt is equal to, sir, VB over here. Sir, 4, 3 is 7, 2 is 9. So VA minus VB will come out to be 9 volts. Great, great. A lot of people have given me the correct answer. Okay. Now, tell me in this case, find VA minus VB. Find VA minus VB. Find VA minus VB in this particular case. Can you tell me the value of VA minus VB over here? What is the value of VA minus VB? Yes, this session is useful for J mains also. VA minus VB. This is the point A and this is the point B over here. You guys are supposed to tell me VA minus VB over here. Everyone, I'm waiting for your answer only. What is the first thing that we guys are supposed to do? Sir, select the path. So let me select the path from A to B. Okay, that is A to B. Okay, then write the potential. See guys, 5 ampere comes from the upper side. This is the 5 ampere. And how much is leaving from this side? 2 ampere. So means If 5 ampere is the incoming current, 2 ampere goes towards right. So we say, sir, 3 ampere will go towards left. So 3 ampere will be in this branch. So 3 plus 2 is 5. Now listen to me very carefully. If this is the direction of current, means this will be positive and this will be negative. And over here, if this is the direction of current, this will be positive and this will be negative. I hope this is clear. Now move from A to B. So first of all, we write VA. This point is having the potential VA. Now over here, we are moving from lower to higher. In case of battery, we are moving from lower to higher. And we write that potential drop as negative. So this will be minus 6 volts. Over here, minus 6 volts. And in this resistor, we are moving from, because this is our path, we are moving from lower to higher also. So that is also, we take, sir, positive. We take from lower to higher as positive. Sorry, this is positive. From lower to higher, we take positive. This will be also positive. Plus I into R in this resistor. And then we reach this resistor over here. Sir, what happens with this upper resistor? We don't have to deal with this because this is our path. Leave it. So then reach over here. So this will be from higher to lower because this is our path. We are moving from higher to lower. So this will be minus I into R. And then in case of battery, we are moving from higher to lower because this is higher, this is lower. So this is minus 8 volt over here is equal to, sir, VB. And then we say, sir, in this particular case, this is VA plus 6 volts plus I into R. I is how much? I is 3. 3 into 5 is, we say, 15 volts. Minus I into R. I is how much? That is 2. This is this resistor. 2 into 2, that is 4 volts. Minus 8 volts is equal to, sir, VB. Now solve this and you'll get you'll get the answer. Okay? Minus 9 volt. Great. Is it clear to each and everyone, my dear friends? Is it clear to each and everyone? Okay. Okay. VA minus VB is minus 9. Now, similarly, this is your homework. Okay. This is one of the best questions in this category. This is your homework. This is what you are supposed to do at your home. We'll take a break at, wait for some time. So this is your homework. Okay. Now over here, in this case, you have to find VA minus VB. In this case, I'll tell you, select this path. This will be the path. Remove this. Okay. But you have to take the proper, what is the current over here? You should know that. Okay. Fine. VA minus VB. This is your homework, and let me know the answer of this question in the comments. Let's move on to the next one. Charging and discharging of a battery. Now, let me just tell you what is a charging of battery. What is charging of battery? What is charging of battery? What is charging of battery? Just a second. Now see, I'll give you the break, guys. Wait. Listen to me very carefully. Let me finish we just have to finish some topics and we'll take the break. Okay. In electrostatics also, we took the break at 8:30. Okay. Wait for some time and we'll finish these small topics over here. Sir, what does charging of a battery mean? Listen to me very carefully. Let's suppose we have a battery over here. This is the battery. This is a battery. And it has got an internal resistance. This is the internal resistance R. And this battery has a potential difference, or EMF, we say capital E. Okay. Now these are the ends of the battery. These are the two ends of the battery. Let's suppose this battery has got potential, this end has got potential Vx, and this end has got potential Vy. This end has got potential Vi. Now in this particular case, you are sending current inside the battery. This current is going inside the battery. What does the charging of battery normally mean? You take a cell phone, okay? It has got a battery and you supply, you plug in the cable. What does that mean? You are sending the current, you are sending the energy, you are storing the energy. So basically, when you are plugging in the cable means you are sending the energy, you are sending the current. So that's what we say over here. We have got a battery E and this is internal resistance R. Now in this case, you are sending the current inside the battery. This is what we call the charging of battery. So we say when current goes inside the battery, when current goes inside the battery, it gets charged. When current goes inside the battery, it gets charged. We say when current goes inside the battery, it gets charged. As simple as that. Because it is the charging of battery. Now, to find net potential difference in case of charging. Sir, what does that mean? Listen to me very carefully. Sir, this battery has got EMF E. If you are charging this battery, means this EMF, this potential difference should increase because you are sending the current, you are increasing the energy. Let's see if that happens or not. If I tell you in this particular case, sir, we have to find the net potential difference across the battery. That is, we have to find Vx minus Vy. Vx minus Vy is net potential difference. See, what is the first thing we do, sir? Select the path. We are selecting the path. Let's go from X to Y. Move from, we say X to Y. Move from X to Y. First, we'll write the potential of X. Listen to me very carefully. Sir, if we are moving from X to Y, we'll write the potential of X first. So we say, sir, Vx. And then in this battery, is it audible, guys? Is it audible? Once we reach the battery, we are moving from higher to lower. And this is the direction of current, means this will be plus and this will be minus in case of resistance. So then in case of battery, we say, sir, minus E, because we are moving from higher potential to lower potential. And then once we reach this resistance, this will be, sir, minus I into R. This will be minus I into R. Why, sir, minus I into R? Because in this particular case, my dear friends, listen to me very carefully. In this particular case, we are moving from higher to lower. In this particular case, we are moving from higher to lower. So that's why we say I into R is equal to, we say, we finally reach, sir, Vy. So we say Vx minus E minus IR is equal to Vy. Now take this Vy over there and take this E over here and IR over here. So we say, and this is I into small r. This is I into small r. So we say, sir, Vx minus, if you take it over there, Vy is equal to, so this will be plus E plus I into R. Now, my dear friends, if you take a look over here, clearly, if you take a look over here, this will be E plus I into R. This will be E plus I into R. Sir, what does that E plus I into R mean? See. Initially, what was the EMF of this battery? That is E. And once you send the current inside the battery means you are charging. So now its potential difference should increase. So that's why it came out to be E plus IR. So means plus IR has been added over here. Plus IR has been added over here. Plus IR. So that's why this is what we call the charging of battery. Net potential difference, or this is what we call the terminal potential difference. Across the ends of this one, this is what we call the terminal potential difference. Okay. So we say, sir, this will be nothing but E plus I into R, E plus I into R. Is it visible, guys? This is the dark mode on. Now see, when it comes to the discharging of a battery, what does discharging of battery mean? Sir, discharging of battery means, see, discharging of battery means, is it visible to everyone, guys? We'll take a break at 8:30, okay? So we say, sir, discharging of battery means when you are taking current out of the battery, means battery is already charged, okay? Your phone is charged. Now what you are doing is that, just a second. So means battery is charged. What you are doing is that you are using your phone, means now battery is drained. Your display, the display of the phone takes the current. Or you have the battery over here, you are connecting the bulb to this one. Now it is taking the current. Now listen to me very carefully. Can I just write in this particular case, over here, we say as, see, I'll make the battery over here. Let's make the battery over here. This battery has got EMF E, and this is the resistance, internal resistance R, and now in this particular case, this is the direction of the current, and current is going out. Now we have to find the net potential difference, across the ends of battery, Now see, sir, if we have to find the net potential difference, move from X to Y, select the path. So first we'll take Vx, okay? Then in case of battery, we are moving from higher to lower. So then it will be minus E, okay? And in case of this resistance, sir, the direction of current is towards left. So this will be plus and this will be minus, because current flows from negative to positive. So this will be minus and this will be, in this case, plus. In case of resistance, we are going from lower to higher. It will be plus I into R. Potential drop of resistance is I into R, and then is equal to, we reach the point Vy. Finally, this is the point Vy over here. Now, if you take this minus E over here, it becomes plus E. If you take plus IR over here, it becomes minus IR. So we say Vx minus Vy will come out to be E minus I into R. Clearly, we can see from the equation also, this is the discharging of battery. Because over here, IR gets subtracted from the EMF. Previously, in case of charging, we say, sir, IR gets plus, IR gets added to the battery, because we were charging the battery. In case of discharging, we say, sir, IR is subtracted from the EMF. I hope this is clear, charging and discharging of the battery. Is this clear, guys? Is it clear to each and everyone? Okay, we have a question on this one which was asked in NEET 2011. Now the question is, a current 2 ampere flows through a 2 ohm resistor when connected across a battery. We have got a resistor over here. And how much? That is 2 ohm resistor. Listen to me very carefully. And we are connecting a battery to it. There is a battery which has got, let's suppose, EMF E. So, and this has got an internal resistance R, small r. This battery is sending the current of, we say, 2 ampere to this resistance. We have a resistance 2 ohm and a battery is connected to this resistance which has got internal resistance small r. So this battery is sending 2 ampere current through this resistor. Then afterwards, the same battery supplies a current of 0.5 ampere when connected across 9 ohm resistor. The question says that the same battery is connected across 9 ohm resistor. Same battery E, and this is R. Okay. But over here, it is sending the current of how much? We say 0.5 ampere. Over here, this battery is connected to 2 ohm. It is sending 2 ampere. Over here, this battery is connected to 9 ohm. It is sending 0.5 ampere. Now, we are supposed to find in this case, we say internal resistance R of the battery. How much is the internal resistance? Now, can we use the Ohm's law in both the cases, sir? Over here, we say V is equal to IR. V is equal to I into R. Now, what is the value of V? V means this E. V is E. That is potential difference E. V is equal to E. E and then I. Sir, what is the value of current over here? That is 2 ampere. 2 and resistance. How much is the resistance in this circuit? That is this R, small r, plus this 2. So we say small r plus external resistance 2 over here. So we can write E is equal to 2R plus we say 4. Yes. Now come over here. Use Ohm's law over here also. V is equal to I into R. So we say V is how much? That is E. Is equal to I is how much? That is 0.5. We can write as 1 by 2 also. And then in this case, then we have R. R is how much? That is 9 ohm plus this internal resistance R, 9 plus small r. Now equation 1, over here E is equal to this, over here E is equal to this. Both we can equate. Let's call it first, let's call it second. So we say equate first and second. Equate first and second. So we can say if we equate first and second, 2R plus 4 will be equal to, we say sir, 2R plus 4 will be equal to 1 by 2 of 9 plus R. Now 2 into 2 becomes 4R plus 2 into 4 becomes 8 is equal to sir 9 plus R. We have to find the value of R. So take it over there and this will be 4R minus R is equal to 9 minus 8. So this will be 3R is equal to 1. R is equal to 1 by 3 ohm. R is equal to 1 by 3 ohm. Is it clear, guys? R is equal to 1 by 3 ohm. Now, we have got the combination of resistors. We have got the combination of resistors. We have got the combination of resistors. Now listen to me very carefully. Sir, what does the combination of resistors mean? What does the combination of resistors mean? Now see, we have a resistor R1 over here. Okay, we have a resistance R1 over here. We have another resistance R2 over here. We have another resistance R3 over here. Okay, this is the symbol of a resistance. This resistance has got resistance. This resistor had got resistance R1. This has got R2 resistance. This has got R3 resistance. Okay. Now, these three resistors, we can clearly see that are connected in series. So that's why we call it series combination of resistors. Okay. Now here, three resistors are connected in series, okay. So we have to find their equivalent resistance. So to find their equivalent or / net resistance, so we say if three resistances are connected in series, we have to find their net resistance, how much that will be. Now my dear people, can I just write over here, see, as in case of resistance, remember one thing, if you have connected a battery V to this, so battery is sending the current I. The current in case of series combination will be same. So we say as in series, we say current is same across all the resistors. So we say, sir, I1 is equal to I2, current in this will be equal to current in this will be equal to I3 will be equal to, sir, I. But we say, sir, potential difference will be different. Potential difference will be different. And we say in this particular case, my dear friends, the potential difference will be, sir, if I say potential difference across, this is V1. If I say potential difference across is V2 and potential difference across is V2 and this is V3. So we say, sir, net potential will be, sir, if I say this is 10 volts, some part of it will go in this, some part will go in this, some part will go in this. So we say V1 plus V2 plus V3 over here. Now, V is equal to I into R. We know, sir. Put in equation first. In equation first, we can write, sir, I into R equivalent over here, I into R net. V is equal to I into R is equal to, sir, in this one, V1 is equal to I1 into R1 plus V2 is equal to I2 into R2 plus V3 is equal to I3 into R3. Okay. Then we can write over here, sir, in this particular case, we say I is equal to I1 because I1 is equal to I2 is equal to I3. All the I's are same, so I will get cancelled. So we say R equivalent will come out to be R1 plus R2 plus R3. So in series combination, equivalent resistance is added. Now the question over here is if n ident EITICAL resistors, if n identical resistors are connected in series, if n identical resistors are connected in series, like something like this, 1, 2, 3, 4, and it keeps going till infinity. So we say, sir, this is R. How to find their equivalent resistance? We say, sir, R equivalent will be, sir, R1 plus we say, sir, R2 plus we say, sir, R3 plus so on. So this will be nothing but n times of R. So R equivalent will be simply n times of R. If you have identical resistors, identical resistors means similar resistors. And next we have over here, law of potential drop in series combination. This is what I have told you previously in case of capacitors. Let me just tell you. Let's suppose we have a resistor over here, another resistor over here, one more resistor over here. And you have connected a battery in this particular case, that is V. This is R1, this is R2, this is R3. Now tell me one thing, sir. Will the potential be same or will the current be same in case of resistance? We say, sir, current is same over here. Current is same across all. Now, as we know, sir, V is equal to I into R. Listen to me very carefully. I'll make you understand what potential law of potential drop is. If we have 3 resistors, we say, sir, current will be same in all the 3 resistors. Now we say V is equal to I into R. Now we say I is same across all the resistors. I is same across all the resistors. If I is same, can we say, sir, V is directly proportional to R? Yes. In case of series combination. Why? Because I is constant. So we can say, so it means that the one which has more resistance, the one which has more resistance will have more potential difference in series combination. Means the one which has more resistance will have more potential drop in series combination. Because why? Sir, in case of series combination, we say current is same. So V is directly proportional to R. So the one which has more resistance will have more potential drop. Example is, let's suppose you have got 3 ohm, 6 ohm and 18 ohm. I ask you the simple question, across which resistor potential difference will be more? Let me know in the live chat. Across which resistor potential difference will be more? 3, 6 or 18? 3, 6 or 18? Across which resistor potential difference will be more? 3, 6 or 18? Yes, yes. Now see, sir, across 18 potential difference will be more because V is directly proportional to R in case of series combination. Because V is directly proportional to R in case of series combination. Now see over here, listen to me very carefully. Listen to me very carefully, my dear friends. The questioner asks that find the potential drop across each resistor. You have to find the potential drop across each resistor. As we say in series combination, we say, sir, V is directly proportional to, as in series combination, we say, sir, according to law of potential drop, according to law of potential drop, we say V is directly proportional to R. According to law of potential drop in series combination, V is directly proportional to R. The one which has more resistance has got more potential difference. Now, let's suppose across this potential difference is X. Now, this 6 ohm is how many times greater than 3 ohm? You say, sir, 2 times. 3 2s are 6. So, across this will be 2x. And 18 ohm is how many times greater than 3? You say, sir, 3 6 are 18. Across this will be 6x. I have shown you this type of questions when we were studying the capacitors. I hope you remember. So see, clearly I can show you over here potential difference across 18 is 6 ohm. 6x. So means it is greater. Now we know now as V1 plus V2 plus V3 is equal to, sir, V net. Now clearly we can see over here this V1 is X plus potential difference across we assume 2x plus potential difference across this we assume 6x is equal V net is how much? That is 10. 6 plus 2 is 8. 8 plus 1 is 9. So 9x is equal to 10 volts. So x will be 10 divided by 9 volts. So means potential difference across 3 ohm is 10 by 9 volts. Similarly, if you ask me what is the potential difference across 3 ohm, you say, sir, across 6 ohm, you say, sir, V2 is equal to 2x. That will be 2 into, what is the value of x? That is 10 by 9. So that is 20 by 9. Similarly, potential difference across this third resistor is, you say, sir, 6x. That will be 6 into, what is the value of x? That is 10 by 9. So this will be 60 by 9. 60 by 9 volts, and this is volts. Is it clear, guys? Is it clear, guys? Is it clear to each and every one? Now we have parallel combination of resistors. In case of parallel combination, we have a resistance, let's suppose something like this. This resistance is what we call R1. We have another resistance, something like this. This is what we call the R2. We have another resistance, something like this. This is what we call R3. Okay. We say current in this resistance is, see, we have connected a battery to this entire circuit. This is the battery you can see over here. And this battery has a potential difference V. As we know, sir, battery sends the current. So this is the current sent by the battery. Now, when this current reaches over here, I, so some part of it will get distributed over here. Let's call that, sir, I1. This is I1 in this one. And in the second resistor, we say I2 will go. In the third resistor, we say, sir, I3 will go. So these three resistors are connected in parallel, okay, because they are connected in parallel. And in this particular case, we say, sir, this I gets divided into I1, I2, and I3. So we say this I will be equal to, sir, I1 plus we say, sir, I2 plus we say, sir, I3. So this is the current. So we say current in each resistor is different. We say potential will be same across each resistor. Current is different. And when it comes to the potential difference, sir, potential difference across each resistor will be same in case of parallel combination. Remember it, because all the three resistors are connected directly to the battery. So we say, sir, potential difference across first resistance is equal to across second is equal to V3 is equal to, sir, V. Okay. Now, my dear people, as we know, oh my God. What's up, bro? Oh my God. Oh my God. Somebody is over here. You wanna meet him? Guys in the live chat.
What's up, people? How are you?
How is the joke?
Long time. Long time, yeah? Guys, it's very cold here. Do you know that? It's freaking cold. I just got back home and directly I came up in the studio just to have a look what Yawar sir is doing and what you guys are up to. Hope you guys are enjoying the class, yeah?
Yo.
Right, people? Hope you guys are enjoying the class. I could see consistently people are sitting and enjoying the session.
Yes.
Perfect,
Naseems
guys.
are OP in the chats. Yes. Sir, break.
Break. Yes, sir will be giving break in 5 minutes. And it's going to be a proper 40 minutes break.
Yes.
Your dinner break it's going to be, okay?
Dinner break, 40 minutes.
40 minutes for the dinner break. And I hope you guys are ready for the chapter solution. Yeah?
Promoting the chapter solution over
Of
here.
course. Of course. And one more thing. On 31st of December, that means day after tomorrow, you are going to have one last session of the year with, of course, me. Right? I hope you guys are ready. It's going to be a casual interaction. You can ask me anything, whatever you feel like, but don't go too personal, yeah? Perfect, guys. So let Yawar sir finish it in 5 minutes. He'll be giving you the break for 30 to 40 minutes. It's going to be a dinner break, yeah?
Yes.
Perfect. No, I'm not married. He is. He's younger to me, still he is.
No, not married yet. Huh?
Carry on. We'll see you. Bye-bye.
We'll finish this topic and I'll give you the break of 40 minutes. Now see, we say over here, sir, as we know, V is equal to I into R, and I can clearly say I is equal to V divided by R over here. Now, from equation first, so from equation number first, this is the equation first. Instead of this I, we can say V divided by R equivalent is equal to V1. Instead of I1, I can say, sir, V1 divided by R1 plus, instead of I2, we say V2 by R2 plus, we say instead of I3, we can say V3 by R3 over here. But we know V1 is equal to V2 is equal to V3 is equal to V. So we can clearly say this V, we can put up over here V also. So we say V divided by R equivalent is equal to V by R1 plus V by R2 plus V by R3. Now you can cancel out this VV over here, and 1 upon R equivalent, this will come out to be 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clearly you can see over here. Okay, so we say this is the equivalent resistance in case of we say parallel combination. Okay, so in case of parallel combination, how to find the equivalent resistance? 1 by R1 plus 1 by R2 plus 1 by R3, as simple as that. Now if I say over here for we say two resistors, in parallel, if we have this resistor over here and if we have this resistor over here, both are in parallel. Let's suppose this is R1 and this is R2. How to find their R equivalent? Let me just tell you, as we studied, 1 upon R equivalent is equal to 1 by R1 plus we say 1 by R2 over here in this case. Now, my dear friends, if you do the cross multiply over here, we can write 1 upon R equivalent is equal to, so this R1 into 1 becomes R1. So this will be R1 plus R2 divided by R1 into R2. See over here, I am taking the two resistors only in parallel and I am finding their R equivalent. Now, see, if you take the reciprocal of this one, R equivalent, you can write that is R1 R2 divided by R1 plus R2. I want you guys to remember this directly because in so many questions from now onwards, we'll be putting up this equation directly. We'll not be using this. We'll be using this. R equivalent for two resistors in parallel is R1 R2 upon R1 plus R2, as simple as that. R1 plus R2. Okay. Now, if I say if we say n resistors are connected in parallel. So we say, sir, let's suppose this is the first resistor, n identical resistors are connected in parallel, something like this. Okay, so these, and it keeps going till n. This is R, this is R, this is R, this is R. If we have n resistors, identical resistors means similar resistors connected in parallel. If we have to find their R equivalent, how do we find? 1 upon R equivalent is equal to 1 by R1. What is R1 over here? That is R, plus 1 by R2, that is R, plus 1 by R3, that is R, plus 1 by R4, that is R, and plus so on up to n. Can I say this will be, sir, 1 by R equivalent is nothing but this is n times of, all of these are n times of 1 by R. Yes. Now, if you do the reciprocal, this R equivalent will be simply that is R by n. This will be simply that is R by n. Okay. Now, if n is equal to 2, you can write 2. If n is equal to 3, you can write 3 over here. So this was all about it. Okay. Let's now take a break. We say break till 9. We say 9:12. 9 break till 9:12 or 9:15. Break till 9:15. Let's take a break till 9:15. Okay. This is the part for you guys. Okay. Let's take a break till 9:15 and we'll come back at 9:15 exactly. And you guys have some dinner till then. Okay. And make sure you like this session, guys. If you have not liked yet, like this as soon as possible. All right, people. So, what's up? What's up? What's up? So, let the people join back to the session. And we will start. It's very cold here in Kashmir. Okay, guys. Hello. Make sure you like this session, guys. Okay. I can see different number of people in the live chat talking to each other, huh? Having fun. Okay. All right, people. Let's move. Okay. Love from Kulgam. Assalamu alaikum. Okay, great. So let's get started, guys. Okay. Now, see, let's talk about this. Just a second. Okay. Now, see, now we'll be basically talking about a law of potential drop. This is law of current distribution. Law of current distribution in parallel combination. What does a law of current distribution mean in parallel combination? Let's suppose we have got two resistors over here. This is R1 and we have got R2 over here. This is R2 and this is R1. Current in this is I2 and current in this is I1. Listen to me very carefully. Now, as we know, sir, V is equal to I into R according to the Ohm's law. V is equal to IR according to the Ohm's law. So from over here, we can say in this particular case, that is nothing but V divided by I is equal to, we say, or V by R is equal to, we say V divided by R is equal to I. I can write over here, yes. Now you guys tell me one thing. As we know, as in parallel combination, we say, sir, voltage is same across all the resistors. We say voltage across R1 is equal to voltage across R2. If voltage across all the resistors is same, so we say, sir, this voltage is same. So this current we can say is inversely proportional to the resistance. Current is inversely proportional to the resistance. If voltage is constant, we say I is inversely proportional to R. Now, my dear people, listen to me very carefully. This means that the one which has got more resistance, the one which has got more resistance, the one which has got more resistance has less current, in it. So why? Because we say I is inversely proportional to resistance in case of parallel combination. We say, sir, the one, that means if resistance is more, we say current is less. So means that resistor which is having more resistance in parallel combination will have less potential drop, will have less current in it. Example, let's suppose I have two resistors over here. The first one is 8 ohm. This is 8 ohm resistor, and then this is exactly 2 ohm resistor. I am asking you, find the current in each resistor. Find the current in each resistor. Now see, in this particular case, my dear friends, as we know, according to law of current distribution in parallel combination, we say, sir, I is inversely proportional to R. The one which has got more resistance has got less current in it. Now over here we can clearly say that if 8 is having more resistance than 2 ohms, so in 8 ohm current will be more. And if I say, sir, let's suppose current in 8 is X, how much will be the current in 2 ohm? I have shown you so many questions regarding this. We say if this is 8 ohm and this is 8 ohm, we say this is 2 ohm. 2 is how many times smaller than 8? We say 2 4s are 8, that is 4 times. So in this we say current will be 4x. If X is the current in 8 ohm, 4x will be the current in 2 ohm. And I told you, sir, when it comes to the parallel combination, the one which has more resistance has got less current in it. So we can clearly say over here, sir, if this I current is coming from over here, it gets divided in I1 and I2. So we say this 10 ampere only gets divided in X, 10x gets divided in X plus we say, sir, that is 4x. Okay, so we say, sir, this 10 is equal to 5x and x will be 10 divided by 5, that is equal to 2. So means in this case current is 2 ampere. In 8 ohm current is 2 ampere, and and we say, sir, I2 is nothing but 4x. So x is 2, 4 into 2 becomes, that is 8 ampere. Means, sir, in this case current is 8 ampere. In 8 ohm current is 2 ampere. In 2 ohm current is 8 ampere. Is it clear to each and everyone, guys? Let me know in the live chat with the fire symbols. Now comes the common potential or midpoint potential. This is very important. Midpoint potential is very important. Now see, listen to me very carefully, guys. Let's suppose we have a resistor over here. This is the resistor, okay? And this resistor is R1. And then we say we have got one more resistance over here. This is the resistance R2. Listen to me very carefully. We have R1 resistor, we have R2 resistor. Sorry. One end of this resistor is, it is having the potential, let's suppose V1. And this end of this resistor R2 has got potential, let's suppose V2. We have got two resistors, R1 and R2. One end of this R1 has resistance potential V1. This one end of this R2 resistance has got potential V2. And in between them, you can clearly see over here, this is the point which is common to R1 and this is common to R2. This point in between is the common end. This is what we call the common. This is what we call the common end. Okay. Now, if this is the common end, we have to find the potential of this common point. To find, we say potential of common point. As I have shown you this particular concept in case of capacitors also. Now remember this formula directly, because this will help us in solving the bigger, heavy problems. We say, sir, this common potential VC will be, that is nothing but, sir, V1. V1 is the potential of this resistor from one end, that is V1, divided by this resistance, we say, sir, R1, V1 by R1. Then plus, sir, potential of this end V2 divided by resistance of this resistor, that is R2, upon, then we say, sir, 1 divided by R1 plus 1 divided by R2. 1 by R1 divided by 1 by R2. 1 by R1 divided by 1 by R2. This is the common potential of this particular point which is in common. Let me just ask you, let's suppose we have got this question over here. We have got resistance in this case, that is R1. We have got R2. We have got the another resistance, that is R3. This potential is given as V1. This potential is given as V2. This potential is given as V3. And this is the common point which is joining, which is the common end to all the three resistors. This is joining these three resistors. Now in this particular case, if somebody asks you to tell me what is the value of this VC, this VC will be simply, sir, V1 divided by R1. This potential divided by this resistance. Then plus we say this potential V2 divided by this resistance, we say, sir, R2. Then plus this potential V3 divided by this resistance R3. Okay. And then we have 1 upon R1 plus 1 divided by R2 plus 1 upon R3. This is how do we find the common potential in this particular case. Now let's suppose if we have a question something like this. We have got a resistor of 10 ohms. We have got a resistance of 20 ohms. Okay. And we have a battery over here that is 20 volts. And we have a battery over here that is 10 volts. And in between we have one more resistor that is 5 ohms. My question to you is find the potential. Find the potential of Vm. Find the potential of Vm and current in 20 ohm resistor. And current in 20 ohm resistor. Current in this 20 ohm resistor. This is what you are supposed to calculate in this particular case. Now, my dear people, listen to me very carefully over here. See, when we were learning the concept of capacitors, when we were learning the capacitor chapter, at that point of time, I told you in order to solve this type of problem, what you are supposed to do is, see, the first thing, we have to find this potential over here. This is a circuit. We have to find this potential. The first thing you people are supposed to do, assume potential, assume zero potential at a point. Assume 0 volt potential at a point. Let's suppose I am taking this over here and I am assuming 0 volt. Sir, will it create any difference? No. We have got a circuit over here and we have to find this potential Vm. What is the first thing we can do over here? Assume 0 potential at a point. I am assuming 0 potential at this particular point. Am I fast? See. See. Let me just tell you, we have got a circuit over here And we are supposed to find the potential of this point first. And then you have to find the current in this 20 ohm resistor. This current you are supposed to calculate over here. Okay. What is the first thing that we'll be doing? Assume zero potential at a point. I am assuming zero potential over here. Now, if this point is zero, what is the potential of this point? Difference is 20. Sir, let's make it over here. Sir, this is 20 volts. This is point A and this is point B, 0 volts. I have told you, sir, this VA minus this VB. If this is point A, this is point B, VA minus VB is equal to this 20 volts, that is this potential difference. Now VB is 0, so we say VA minus 0 is equal to 20 volts. So VA is equal to 20. So this point VA, it has got a potential of, we say 20 volts. Okay, yes. Now, if this point is 0 over here, this potential difference is 10. This is how much we say this has got a potential difference of 10 volts plus 10 volts. This is what I have shown you previously also. We have done so many questions on this one. If this is 0, this is 20, this will be plus 20. If this is 0, this is 10, this is plus 10. I have shown you before also. Now, sir, it is going till same wire is going till over here. So this will be also plus 20 volts. Now same wire is going till over here. So this point will have also the same potential, that is 10 volts. Now I say redraw the figure. If I redraw this figure, let me just show you. Let's make this branch over here. We say, sir, it will be something like this. This is 10 ohms. And how much is this potential? This is plus 20 volts. And then we'll make over here, this is 5 ohms over here. And how much is this potential? That is 0 volts. And then I'll make this resistor over here. This is how much? That is 20 ohms. And this potential is nothing but, we say, plus 10 volts. Okay. And this is VM. Now, guys, sir, this looks common potential. Yes. Now we use the common potential formula. VM is equal to V1 by R1. You can see over here. V1 by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1 plus 1 by R2 plus 1 by R3. Now what is V1? V1 is this potential 20 over here. That is 20 divided by R1 is this resistance, that is 10 plus V2 is this potential, that is 10 upon R2 is this, we say over here 20 plus. Then we say V3, that is 0 upon by R3, V3 by R3, that is divided by 5. Then we have 1 by R1, 1 upon R1 is, sir, 10, 1 by 10 plus 1 by 20, 1 by 20, 1 by R2 plus 1 by R3, that is 1 divided by 5 over here. 1 divided by 5 over here. Is it clear? Is it clear till over here, guys? Let me know in the live chat if it is clear to each and everyone. Is it clear to each and everyone? Yes, great. So if we solve it, this will come out to be, that is 50 divided by 7. On solving, this will come out to be 50 by 7. So means this potential, this point has got a potential of how much? We say, sir, 50 by 7. 50 by 7. Let me make it over here. This will be 50 divided by 7 volts. This point has got 50 by 7 volts. Now, we were supposed to calculate the current in this 20 ohm resistor. We have to find the current over here. Now see, as current in, we say 20 ohm resistor. If we have to find the current in 20 ohm resistor, we say I is equal to delta V divided by R. Because according to Ohm's law, I is equal to V by R or V is equal to I into R. Okay. So we say, sir, I is equal to delta V by R. Now delta V is what? Delta V is the potential difference. Now, if you take this 20 ohm resistor, let me make it over here. We say, sir, this is the 20 ohm resistor. If we make it separately, this point has got potential, that is 50 by 7 volts we recently calculated. and this point has got potential of 10 volts we recently calculated. Okay, now you guys tell me one thing, sir. We know how to find the current in this one. We say, sir, I is equal to delta V divided by R. Now, what is this delta V? Delta V is the potential difference. That is, potential difference will be simply, sir, 10 higher potential minus lower potential. This end has got 10 potential. This end has got 50/7 potential. So, 10 minus 50 divided by 7 will be delta V upon resistance is over here, that is 20. Resistance is over here, that is 20. Okay. And if you solve this is 70 minus 50 is 20/7. So it will come out to be 1 divided by 7 ampere is the current. 1/7 ampere is the current. 1/7 ampere is the current in 20 ohm resistor. So this is what we were supposed to calculate. The current in this 20 ohm resistor and this midpoint potential. Now, my dear people, let's come on to this question. Find the current over here. Find current in 5 ohm resistor. 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 Now see, what is the first thing that we'll be doing in this particular case? Listen to me very carefully. We say redraw this. Redraw this figure. If we redraw this figure, see, how do we redraw it? Take this resistor over here and take this battery over there. Interchange their distance. Okay. So position. Let's suppose this is the resistance that is 5 ohm over here. And this is the battery I'll make from this side. Sir, will it create any difference? It will not create any difference. I'm just interchanging their position. And then you have over here this 4 ohm resistor, this 4 ohm resistor, okay? And its battery over here, that is nothing but we say 10 volts. We say 10 volts, okay? And then you have over here this battery in the third branch, which is nothing but we say 8 volts. We say nothing but 8 volts. Now, listen to me very carefully. Sir, over here also, in this type of question also, we assume 0 volt potential at a point. So I am assuming 0 volt at this point. Now, you guys tell me one thing. If this is 0, how much this will be? This will be also 0 because this is a straight wire. How much this will be? This is also 0. Now, my dear people, if this is 0, this is battery. Battery has got one end potential 0 volts. What will be the another end? Sir, we know this will be, sir, plus 8 volts. Why? Because 8 minus 0 will be equal to 8. This potential minus this potential has to be equal to this potential. So we say VA minus VB is equal to this delta V. Similarly over here, if this is 0 volt potential, this is 10. How much this point has to be? This will be minus 10 volts. Let me show you. See, this potential difference of these two ends should be equal to 10. We say, sir, this is VA, that is 0. This point is 0. Minus, this is VA minus VB. What is the value of VB? That is, sir, minus 10. 0 minus of minus 10 is, sir, plus 10 volts. See, this has got plus 10 volts of potential difference. So means if I am taking minus 10 over here, it is absolutely correct. Now, if this point has got the potential of 0 volts, if this is 0, this will be how much? That is plus 20 over here, plus 20 volts. I hope this is clear. I hope this is. And if this is 8 volts over here, this will be also plus 8 volts. Why? Because it is the simple wire going till over here. And this point will also have plus 8 volts. Why? Because this is the simple wire. You cannot say if this is plus 20, this will also be plus 20. No. Why? Because resistor is in between. Now, we were supposed to find the current in 5 ohm resistor. means in this resistor. Now I'll write over here current in 5 ohm resistor. So I'll take this 5 ohm resistor over here. This is the 5 ohm resistor. So we say this is 5 ohm resistor. This point is, we say 8 volt. This is plus 8 volt. And this point, another end of this is having how much? That is plus 20 volt. Now, to find current in this one, we say I is equal to delta V by R. That is delta V divided by R. So we say I is equal, delta V is how much? That is higher potential minus lower potential. That is 20 minus 8 divided by R. R is how much? That is 5. 20 by 8 is 12 by 5 ampere. How many of you got 12 by 5 ampere? Is it clear, guys? I just need the signal in the live chat. Is it clear to each and everyone? I just need the signal in the live chat. Is it clear to each and everyone? Guys, mark the like the session, okay? If you have not liked it. Okay, great. Let's move on to the next question. Now, find the current. Find the current in 2 ohm resistor. You guys are supposed to find the current over here in this 2 ohm resistor. What is the value of current? Find the value of current in this 2 ohm resistor. Can you guys solve it? How to know the direction of current? Direction of current will be always from higher potential to lower potential. Direction of current will be from higher potential to lower potential. So this will be the direction. This is higher, this is lower. So this will be the direction of current. Now see, in this particular case, could you please tell me what is the direction of current? Now see, sir, in this particular case, if we just try to have a look at the circuit, over here, you don't have to assume the zero potential at any point. Why? Because it is over here, grounded over here. It is earth, okay? This is grounded. Grounded means if you have grounded something means its potential is zero. If you see sometimes something like this, what is this? It means it is grounded. So means its potential is zero. As simple as that. So means over here potential is zero. Now if at this point, if this is zero, how much this will be? This will be also same wire is going till over here. Potential is zero. Now you see this battery. This battery has got 0 volt potential from upper side. How much will be from its another end potential? You say, sir, plus 8 volts. Why? See, this potential minus this potential should be equal to the potential difference. So 8 minus 0 is equal to this 8. Clear? Now, if this is 8, how much should be this particular, how much should be the potential of this point? Now, let's take this battery over here. Sir, this is the battery. This is 4 volt. This has got 8 volt. What should be the value of this potential VB? We are supposed to calculate this point. Let me show you. Sir, move from this point to this point. So this will be 8 volts. Okay. In case of battery, we are moving from higher to lower. So it will be minus 4 volts. 8 volt minus 4 volt is equal to, sir, VB. So 8 minus 4 is 4 volt is equal to, sir, VB. So this point has got the potential of 4 volt. VB, we got 4 volt. I hope this is clear, my dear people. I hope this is clear. Now, if we have to write the potential of this battery, let me just take this battery over here. This is 6 volt, this is 4 volt, and you have to calculate the potential of this point that is VB. Now, move from this point to this point, select the path. So we say we'll first write the potential, sir, 4 volt. Then we are moving from higher to lower, then minus 6 volt. And then is equal to, we reach the point VB. This is how we calculate. 4 minus 6 is minus 2 volt is equal to VB. means this point has got a potential of minus 2 volt. As simple as that. Is it clear, guys? Is it clear, guys? Yes. Now see, sir, we have to find the current in this 2 ohm resistor. Let me take this 2 ohm resistor over here. This is nothing but 2 ohm. And this point has got a potential of plus 8 volt. This point has got a potential of minus 2 volt. Sir, we say I is equal to delta V by R. We say, sir, delta V divided by R. Now, delta V is how much? You say, sir, that is higher potential minus lower. Higher is 8 and then minus of, this is minus 2. 8 minus higher potential minus lower potential. Lower is minus 2 divided by R. R is resistance, that is 2. So this is 10 by 2, which is equal to 5 ampere. So current in this is 5 ampere. Is it clear, guys? Is it clear to each and everyone? Is it clear? Hey, I need the signals in the live chat. Rest of the people are chatting over there. I want you guys to tell me. Is it clear? Now we have the cells over here. Now we have the cells over here. You have the series combination of cells. Now see, what does a cell mean? Cell means battery. Okay, cell means battery. And series and parallel combination of cells. First of all, let's talk about the series combination. Like we have resistors connected in series, similarly we have cells connected in series. This is the first cell over here, that is E1. E1 is the first cell which is connected over here, okay? E1 is the potential difference or EMF of this cell. And this cell has got internal resistance R1. As I told you, when it comes to a cell, cell has got the internal resistance. So this cell has internal resistance R1. And then, sir, we have got another cell. It has EMF E2 or potential difference E2 and it has got internal resistance R2. Then we have got another cell, that is E3. It has got internal resistance R3. Similarly, we have N cells. This is up to N. Okay, this is En. We have got N cells connected in series. These are the N batteries. N batteries connected in series. Now, here, N cells are connected in series. Like we had N resistors connected in series, over there we were finding the net resistance. Similarly, in this case, we have to find the net EMF. To find net EMF or net potential difference across PQ. We have to find the net potential difference across P2. This is the EMF of first cell, second cell. Now, if I write over here, sir, net EMF, how do we write it? It will be simply, sir, E1 plus we say E2, E1 plus E2, plus we say, sir, E3, plus we say, sir, E4, okay, and plus so on up to it will be En, okay. This is how do we find the equivalent EMF in case of cells in series. Means you have the batteries connected in series and they will ask you to find the net EMF. How do you find? E1 plus E2 plus E3, so on. And these internal resistance are also connected in series, and we know how to find the equivalent resistance in series, that is R1 plus R2 plus R3 plus R4 and so on, okay, up to Rn. Now, my dear people, If I say, if n identical batteries are connected in series, find E equivalent in that case. Now we are given over here n identical batteries, okay? What does identical battery mean? Means if this is having the EMF E, the next battery will also have the same EMF E, because they are similar, they are identical. Now, how do we find the EMF in this particular case? Sir, E equivalent will be E1, as they are in series. So it will be E1 plus E2 plus E3. E1 is how much? E, plus E2 is how much? E, plus E3 is how much? E, plus so on up to n, okay? And you can write all of these. Sir, this is n times, so this will be n times of E. N can be 1, 2, 3, 4 and so on. Now R equivalent in this case will be, sir, they have got the internal resistance R. So it will be R1 is R plus, R2 is also R plus, R3 is R and so on. So this will be n times of R. So equivalent resistance will be n times of R and equivalent EMF will be n times of E. So this is in case of cells in series. Now, if we have the cells connected in parallel, like we have this cell E1, its internal resistance is R1. We have another battery E2, its internal resistance is R2. So we say to find the net EMF in parallel. To find the net EMF in parallel. Now, listen to me very, very, very carefully. So we say, sir, over here, if we have to find the net EMF in parallel, we say, sir, this net EMF, that is E net in parallel will be, simply remember guys, what is the EMF of this one? That is E1. And what is the resistance of this one? That is R1. So you will say, sir, E1 divided by R1. In case of series combination, we are doing R1 plus R2 plus R3, but over here it is something different. E1 by R1, E1 divided by R1, plus this EMF is E2 divided by this resistance is, we say, R2. This is R2. Then upon 1 by R1 plus 1 by R2. This is how do we find the net EMF in case of parallel combination. Okay. And if they ask you to find the R equivalent over here, sir, these two resistors are connected in parallel. This is separately for EMF only. I know in EMF you will get R1 and R2 also, yes. But separately you have to find the R equivalent in this case. We know, sir, in case of parallel combination, if we have to find the equivalent resistance in case of two resistors, that will be R1, R2 upon R1 plus R2. As simple as that. Or we can write 1 upon R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now, if you have the question over here, n identical batteries are connected in parallel. Let me know in the live chat if this is clear to each and everyone. Let me know in the live chat if this is clear to each and everyone. Guys, is it clear to each and everyone? Let me know. Okay. Great. Now, if we have, let's suppose, n identical batteries connected in parallel. We have, sir, this E battery, then we have another E, then we have another E, another E. All of these are connected in parallel. And these are identical cells. Identical means they are similar. If this is E, this is E. This is our internal resistance of this. This is the internal resistance of second cell. This is the internal resistance of third cell. This is the internal resistance of fourth cell. Now over here, if you have to find the equivalent EMF, what will you say? Are connected in parallel. And these are N cells. See, how to find the E equivalent in case of parallel combination? You can see over here, E1 by R1 plus E2 by R2 plus E3 by R3. So I can write over here E1 by R1. What is the value of E1? That is E. So this is E1 divided by R1. What is the value of R? That is R. Then we have plus E2 by R2. E2 is also E. R2 is also R. Then we have plus E3 by R3. That is E by R. Then plus and so on up to N, up to N, up to N. And similarly, we have over here 1 by R1 is R, 1 by R2 plus 1 by R3, and you have plus so on. Now this E equivalent will be, this is how many times? This is N times. So we say N times of, that is E by R. This is N times of E by R. And this is how many times? This is also N times of 1 by R. This is N times of 1 by R. Now over here N, R, N, R, they will get cancelled out. What remains? That is E. So means E equivalent will be E. Means, guys, if you have N cells connected in parallel and they are identical, and if somebody asks you what is the equivalent in that case, you'll simply say, sir, equivalent in that case is the equivalent if the EMF of one single cell. EMF of one single cell is E, equivalent is also E. Is it clear, guys? Is it clear, guys? And if they ask you to find the R equivalent, we say, sir, R equivalent will be simply R by N. R equivalent will be simply R by N. Okay, great. Then you have mixed grouping. This is what we call the mixed grouping. Means when you have cells connected in series as well as you have cells connected in parallel. When you have cells connected in series as well as you have cells connected in parallel, that's what we call the mixed grouping. That's what we call the mixed grouping. Okay, that's what we call the mixed grouping. Now, let me just make you understand what this is all about. See, I'll write, sir, here cells are connected in series as well as in parallel. Here, cells are connected in series as well as in parallel. Cells are connected in series as well as in parallel. Okay, great. Now we have to find the equivalent. To find E net. To find E net in the mixed grouping, we have to find the net EMF in case of mixed grouping. Okay, now listen to me very carefully. If we say, sir, these cells are connected in series, N identical cells, this is E1, E2, E3 up to N, they are connected in series. And sir, we say these are also N cells in the second row connected in series. Similarly, these are up to M rows, N cells in M rows. Now listen to me very carefully. We say over here, if we talk about the first row, can you solve this first row? Can you find the equivalent of this first row? Sir, yes, it is very simple. E equivalent in the first row will be E1 plus E2 plus E3 plus E4, and that is simply N times of E, because I have told you if you have N identical batteries connected in series, their equivalent is how much? N times of E. So similarly, you will be basically doing it over here. So similarly, you will be basically doing it over here. You have to find the equivalent of these cells. Sir, equivalent of these cells will be, sir, E1 plus E2 plus E3, that is N times of E, as simple as that. So let's make it over here. Sir, that will be something like this. This will be N times of E, and this resistance will be also n times of R, because this is also n times. So we say, sir, this is n times of R. So we say in series E equivalent is nothing but n times of E. R equivalent is nothing but n times of R. And if we talk about the second row also, sir, second row will also have the same n times of E and n times of R. Because when it comes to the second row, this is also E, n times E in series. So similarly, we say over here, sir, it goes up to M. So this is also n times of E, and this is also n times of R. You can say it something like this. And this is how many rows? We say, sir, M rows. Like you have n cells in series, M rows in parallel. Now, my dear friends, if I just tell you over here, if identical cells are connected in parallel, what is their equivalent? Listen to me very carefully. Sir, if identical cells are connected in parallel and you have to find their equivalent, I told you its equivalent will be simply E. That is the EMF of one single cell. So I can say over here, sir, in parallel combination, E equivalent will be, sir, this has an equivalent of how much? We say, sir, that is n times of E only. Because this is also n times of E, this is n times of E, this is n times of E. So equivalent will be how much? That is, equivalent will be how much? You will say simply, sir, that is n times of E, or this is E. I hope you got it. Okay. Or you can solve this also. That will come out to be n times of E only. I hope you got it. How did this come? Let's suppose if I say this is E, then in that case equivalent will be E only. But this is n times of E. So this will be n times of E. And R equivalent over here will be how much? This is, sir, we know when you have resistors, n resistors connected in parallel, their equivalent resistance is nothing but we say R by N. But over here, how many resistors are connected in parallel? We say, sir, M resistors, because there are M rows. So we say over here R equivalent will be NR divided by M. Because M rows are connected in parallel. Guys, is this clear to each and every one? I want you guys to tell me in the live chat if this is clear to each and every one. Let me know in the live chat if this is clear to each and every one. Guys, in the live chat, is it clear to each and everyone? Let's move on to the next one. Find current through 10 ohm resistor. Okay, this is the 10 ohm resistor. You are supposed to find the current through 10 ohm resistor. So over here you have got the two batteries. Two cells connected in series. Now you have to find first their equivalent EMF. Here, first find the net EMF. Net EMF means net potential difference. Net EMF means EMF is also potential difference. Okay. You have to find the net potential difference in this case. And then you can do I is equal to V by R. Now, instead of these two batteries, if we find the net EMF, that is V net. See, guys, if you have to find the current over here, what will you do? You say, sir, I is equal to V divided by R, or a delta V by R. So V is how much? V is the combination of these two cells. How much they will give potential difference to this one. So first we have to resolve this. So that is V net is equal to V1 divided by R1 plus V2 by R2. Whenever you have two cells in parallel, their equivalent is V1 by R1 plus V2 by R2 upon 1 by R1 plus 1 by R2. Now over here, V1 is how much? That is 5 by R1 is how much? That is 1. Then you have V2 is how much? That is 10. And instead of plus, I write minus. Why? Why? Because the polarity is opposite. Polarity is opposite. In this case, this is lower side and this is higher potential side. This is positive terminal, this is negative. You can see opposite to this one. That's why I'm writing minus. So this will be minus V2 is 10 by R2 is how much? R2 is 2 upon 1 by R1, 1 by 1 plus 1 by R2, R1, R2, 1 by 2. See, this is 2 1s are, 2 5s are. 5 by 5 minus 5 by 5, so this will come out to be 0. So in this case, V net comes out to be 0. If net potential difference of this is 0, how much will be the current? Sir, current is V by R. V is how much? 0 by R, 0 by 10. So that is 0. Means no current flows in this circuit, in this resistor. Why? Because potential difference is 0. Is it clear, guys? Is it clear? Can you find, this is the ammeter over here, okay? You are supposed to tell me the reading of this ammeter. Reading of ammeter is nothing but you guys are supposed to tell me how much current passes through the ammeter. Find current I through the ammeter. Tell me, what is the current I in the ammeter? What is the current I in the ammeter? How much current this ammeter can detect? How much current this ammeter can detect? Can you guys tell me? Let me just tell you over here. See, the resistance is 1100 ohm. Means we have got these much of resistances which are connected in parallel. And how much this is? That is 1100 ohm. Okay. And battery is how much? We have got 220 volt battery connected over here. And these resistors are connected in parallel. Over here, resistors are connected in parallel. Now you guys tell me one thing. Could you please tell me, sir, how much will be the current in first resistor? You say, sir, I is equal to delta V divided by R. If you have to find the current over here in this one, you say, sir, I is equal to V by R. V is how much? That is 220. That is 220 divided by R is how much? You say, sir, that is 1100. This and this will get cancelled out over here. And this will be 1 by 5. Okay. So current in first resistor will be 1 by 5. Now what is the value of second resistor? This is also, sir, 1100 ohm. So the current, let's call this as I1. The current in the second resistor I2 will be also, that is 220. This battery is directly connected to this resistor also. So 220 divided by 1100, that is 1 by 5 ampere. Okay. Now, if I ask you how much is the current in this resistor, you say, sir, that is I3. That will also be, sir, 220 divided by 1100. That is nothing but 1 by 5 ampere. Now, you guys tell me one thing. Sir, in this case also current is 1 by 5. Current is 1 by 5. As you must be knowing that when it comes to current, remember this, current flows in a loop. Current flows in a loop. Current flows in a loop. So Sir, 1 by 5 ampere will come over here and will leave from this side. 1 by 5 ampere will come over here, will leave from this side. 1 by 5 ampere will come over here, will leave from this side. So 1 by 5 plus 1 by 5 plus 1 by 5, that is 3 by 5. So current, so this will show the current of 3 by 5 ampere. So current in the ammeter is, we say, 3 by 5 ampere. Current in the ammeter will be 3 by 5 ampere, because this is 1 by 5, this 1 by 5, and this 1 by 5 will go and enter this ammeter. Is it clear, guys? Is it clear, guys? Find, let me just change the question over here. Now, in this particular case, you guys are supposed to tell me, find the reading of voltmeter. The reading of voltmeter will be simply, see, you have to find the potential difference across, if this is point P and let's suppose this is point Q. If you find the potential difference across PQ, net potential difference, that will be the reading of voltmeter. Voltmeter is a device which measures the potential difference. And across this voltmeter, the potential difference will be the net potential difference of these cells. So I say across voltmeter, potential difference will be the potential difference will be the net potential difference will be the net potential difference will be the net potential of all the cells over here, of all the cells. Now, how to find the net potential of all the cells? Listen to me very carefully. My dear friends, if I just tell you in this particular case, see, this cell, these three cells are in series. If we find their equivalent, that will be 6 E1 plus E2 plus E3. 6 plus 6 plus 2, that is 14 volts. Let me redraw it. That will be over here, that is 14 volts. And these two resistances are in series. So if you add these two resistances, that is 4 plus 3 is 7 ohms. Okay. Then come on to the next branch. Now see over here, you have got 6 plus 1, that is 7 volt. That is 7 volt. You can add these batteries. And then you have this resistor, this resistor, this resistor. 3 plus 3 is 9, 9 plus 2 is 11. So we have this over here, that is 11 volts. Okay. And then you have voltmeter over here. Okay. Now you have to find the equivalent of these two. V equivalent in this case will be, sir, V1 by R1, that is 14 by 7, plus V2 by R2, that is 7 by 11, upon 1 by R1, 1 upon 7, plus 1 by R2, that is 1 upon 11. Solve it and you will get the answer. Whatever is the answer, that will be the reading of the voltmeter. Is it clear to each and everyone, guys? This was the question which was asked in JEE Mains 2019. Now, Can you solve this particular question we have over here? Can you solve this question? Can you solve this question we have over here on the screen? Now see, in this particular case, this was the question which was asked in JEE Means 2019. Find the potential difference between A and B over here. This is the point A and this is the point B. We have got a resistance over here 10, this is 10, this is 20, this is 10, this is a battery, this is a battery, this is a battery. Now, in order to find the potential difference across AB, sorry, what we'll do is that first we redraw this, redraw the circuit. Redraw the circuit. If we redraw the circuit, let me show you. See, this battery, let me just tell you one thing, sir. This resistance and this resistance will make it from one side. This resistance and this resistance goes with this battery, okay? See, this is one branch, this is another branch. In this branch, you have got 10 ohm resistor, you have got 10 ohm resistor, okay? Now, what we can do is, we'll basically make it something like this. Take it over there. This is the resistance, something like this 10. Then you have this battery over here. Then you have this resistor 10. This is 10. This is 10. Now I am interchanging their position also. Take it over there. 10 plus 10 becomes 20. So finally the diagram I'll make over here, that will be something like this. This 10 plus 10 becomes 20 ohm. And you have this resistor over here, that is 2 volts. Sorry, this is the battery, that is 2 volts. And then this is the point A. And then this resistance 20. This is, we have over here, that is 4 volts. Now, this resistance plus this resistance becomes 30. And you can make it over here. 20 plus 10 becomes 30 ohm. And then you have this battery, that is nothing but, we say that is 4. This is how do we redraw this particular circuit over here. Now, what we can do is assume 0 volt potential at this particular point. If we assume 0 volt potential at this point, how much potential will be at this point? Sir, this is also 0 volt because this is a straight wire. At this point also we say this is 0 volt. Okay. What I did is that I added this resistance with this resistance. I can do it. There is not a problem. Make it in the separate branch. 10 plus 10 is 20. That is 20. And we have this battery. This battery, I'll make it as it is. Then you have the middle branch. I made the middle branch as it is. Then from the left side, from the right side, you have this 20 plus 10 is 30. I'll make it 30 over here. And then you have this 4 volt. Now, if this is 0, this is 2 volts. How much this will be? This point has the potential of 2 volts. Okay, plus 2 volts. Because 2 minus 0 is 2. If this is 0 over here, this is 4. How much this point has potential? We say 4 volts. That is plus 4 volts. Now, if this is 0 volts and this is 4, how much this has the potential? That is, we say plus 4 volts, plus 4 volts. Now, let's redraw it again. Redraw again. Now, see, now we'll make this part. Let me just show you. First, I'll make this 20 ohm over here. Sir, this is 20, or let me just make it something like this. See, this 20 ohm, I'll make it over here. Don't get confused, guys. So this is nothing but 20 ohm. And this point has got potential of 20 volts. Sorry, plus 2 volts. Let me make it plus 2. And then you have the straight wire and you have got the point A over here. And you have this one you have in this particular case, that is 20 ohms. 20 ohms is this resistance. And this has got the potential of plus 4 volts. And then you have this resistance. This resistance is nothing but, we say 30 ohms. This is 30 ohms. And this end has got the potential of, we say, plus 4 volts. And you guys are supposed to tell me potential of A. What is the potential of A? Don't you think we can use the midpoint potential formula over here? Yes, sir. This is the common potential to all the three. Now, this potential we know. This potential we are supposed to find, that is VA. Now, VA will be how much? Sir, VA is nothing but, that is V1 by R1 plus V2 by R2 plus V3 by R3. What is V1? That is 2 by 20. That is 2 by 20 plus we have 4 by 30. We have 4 by 30. Then we say plus we have 4 by 20. We have 4 by 20 upon 1 by 20. 1 by 20 plus 1 by 20. How much is this resistance? Plus 1 by 30 plus 1 by 20 plus 1 by 30 plus 1 divided by 20. Okay. Guys, can you tell me, is it clear to each and everyone? And if you solve this comes out to be, that is 3.12. Okay, 3.12 volts. So we say, so VA minus VB is equal to 3.12 volts. Now you say, sir, this is the potential of this point VA only. Why are you saying, or this point VA only? Why are you saying VA minus VB? Because VB we assumed 0. VB we assumed 0. Let me just show you. If I say, sir, VB is 0. See, if I say, if VB is equal to 0, so then VB is equal to 0. So VA will come out to be 3.12. That's what I said. VA is 3.12. So it is not, even if you say VA minus VB, that is also correct in this particular case. Guys, this was one of the best questions, and this is very, very important. Very important. Is it clear to each and everyone? Is it clear to each and everyone? I want you guys to tell me in the live chat if this is clear to each and everyone. If this is clear to each and everyone. And this is one more question you guys are supposed to tell me. This was also asked in JEE Mains 2019. Do I need to repeat anything? Do I need to repeat anything? Or this is clear to each and everyone? Okay. If you have not liked this session yet, like it as soon as possible. Now, we are supposed to find the potential difference between A and B. This is the A and this is point B. The first thing you guys must know that current does not flow in the open branch. So current, we say, sir, current does not flow in the open branch. Current does not flow in the open branch. So we say in this case, the current over here is 0, and current in this case is 0 in this branch also, because this is open, this is open. Now if we redraw the circuit, redraw the circuit. If we redraw the circuit, listen to me very, very, very carefully. If we redraw the circuit over here, we can make it something like this. Sir, this will be this resistance and this battery. And then we have this resistance and then we have this battery. Then we have this resistance. Then we have this battery over here. And we can make it something like this. We can make it something like this. Okay. Now, my dear people, listen to me very carefully. But why do we have to remove these two branches? Because current does not flow in these two branches. They are open. So now this is 1 ohm. This is 1 volt. This is, we say 1 ohm. This is 2 volts. And this is 1 ohm. And this is, we say 3 volts. Let's suppose if I say, assume 0 volt potential at this point. If this is 0 volt, this will be also 0 volt. This will be also 0 volt. Now, my dear people, if this is 0 volt, this will be how much? This point has got a potential. This will be how much? This will be plus 1 volt. Why? Because 1 minus 0 is 1. If this is 0, this will be how much? This point will have potential plus 2 volt. If this is 0 volt, this point will have potential plus 3 volt. Okay. Now, this is the point. This is the point which is common. This is VC. If we find the potential of this VC, we'll get the answer. Now, we can say, sir, this VC is equal to V1 by R1. V1 is 1 divided by R1 is 1, because this is common point to all the three resistors. V2 by R2, V2 is 2 plus 2 by R2 is 1 plus V3 by R3, V3 is 3 by R3 is 1 upon, we say 1 by R1, 1 by 1 plus 1 by R2, 1 by 1 plus 1 divided by 1. Now, over here, you have to find the value of VC, that is V common. And if you solve this, this will come out to be, that is nothing but 2. This is nothing out but 2. So, potential of this point and this point is the same as potential of this point and this point. Why? Because no current flows in this branch, so potential at every point is same. No current flows in this branch, potential at every point is same. So we say if this is point A, if this is point B, so we say in this case, sir, VA minus VB is equal to 2 volts. Is it, guys, clear? Is it clear? Sorry. Is it clear to each and everyone, guys? And make sure you like this session. Okay, great. Now comes basically the next topic, that is power supply by the battery. Power supply by the battery. Listen to me very carefully. What does power supply by the battery mean? See, let's suppose I have a battery over here. Okay. This battery has got a potential difference V, and we know, sir, battery sends the current, let it supply the current I. Now, my dear people, we know, sir, battery is the source of energy. Battery provides the energy. If battery is giving current, means battery is giving what? Energy. As battery supplies energy. As battery supplies energy slash you say, sir, power. Power is what? Power is also energy. energy per second in unit, in one second, how much energy is being supplied, that is nothing but power. So if battery I'll get some water, guys. Huh? I'll get some hot water. Just a second. Just a second. Now see, we say battery supplies the current, means battery supplies the power. Okay. Yes. Now, my dear friends, battery is sending the current. Okay. Battery is sending the current, means battery is supplying the energy over here. Now, if somebody asks you how much power or how much energy does this battery supply? Okay. That is what we call the power supplied by the battery. Now see, sir, we say that power supplied by the battery will be P is equal to, we say how much is the potential difference or EMF, that is V, and how much is the current supplied, that is I. So power supplied is equal to P is equal to V into I. So P is equal to V into I. This is the power supplied by the battery. This is the power supplied by the battery. V is the potential difference, I is the current. V is the potential difference, I is the current. Okay, cool. Now, if I ask you, sir, we have this battery over here, and this battery supplies this current. Now the question is, where does this current actually go? Sir, you have a battery over here and you connect a bulb to it, means this current will go into the bulb and that bulb will glow. And that bulb will basically use that energy. So we say bulb, either you say bulb or you say, sir, resistor, it is one and the same thing. So this energy will be lost in the resistor. Resistor will basically use that energy. So we say power supplied by the battery will be lost or we say used in the resistor. So this resistor will use that energy, it will waste that energy or use that energy. Resistor can be bulb, resistor can be this can be anything. Okay, load, anything, bulb, whatever you say. Okay. Now my question to you is, my dear friends over here, if I ask you, sir, we know P is equal to V into I. This is power supply by the battery. And if you have to find how much is the power lost in the resistor. Now, as we know, sir, V is equal to I into R. We know, sir, V is equal to IR. So we can write this power is nothing but, instead of V, I can write I into R and then multiply this I. So I into I becomes I square. P is equal to I square into R. So we say this is the power lost in the resistor. or this is the power in resistor in terms of current and resistance. This is the power in terms of voltage and current. This is the power in terms of current and resistance. Also we say, sir, I is equal to V divided by R. According to Ohm's law, I is equal to V by R. Now, can we put this equation I is equal to V by R over here? So we say P is equal, instead of I square, I say V square divided by R square, and then you have this R over here. This R and square will get cancelled out. So we say, sir, this P is equal to V square by R. This P is equal to V square by R. So we say, so power lost in resistor, is, we say P is equal to V square into R, and P is equal to V square divided by R. P is equal to I square into R. P is equal to V square by R. Now, let me just tell you guys, we know, sir, if we have a resistance R, and if we say I is the current flowing in the resistance, R is the resistance, and if somebody asks you, how much is the power over here? You say, sir, P is equal to I square into R, or P is equal to V square divided by R. Now, if we have to make the graph between, power and resistance, if we have to make the graph between, we say, power and resistance. Sir, power is directly proportional to R and power is inversely proportional to R. Which is correct? We say both are correct. We say, sir, when power is directly proportional to R, it is only and only when current is constant, when current is same. Power is directly proportional to resistance only when current is constant. When this I is same constant, P is inversely proportional to R. And we say, sir, P is inversely proportional to R when P is inversely proportional to R, when we say, sir, voltage is constant, when voltage is constant. So if somebody asks you to make the graph between power and resistance, and he tells you current is constant, then the graph will be straight line. And if you have to make the graph between power and resistance, when he says voltage is constant, then it will be inversely proportional to this. Sir, can you please give some another example so that we could understand this more properly? Yes, I'll give you the another example. Let me just tell you over here. Let's suppose we have a resistance R1. We have a resistance R2. And then you have a battery V. Sir, this battery will send current I. That will go in this resistor, So, sorry. Now see. Just a second, guys. I'm having a lot of cough. Very cold out here. No, we cannot continue tomorrow. We have to finish it. See, the two resistors are connected in series over here. And we know, sir, in case of series combination, current is same. And when current is same, we say, sir, over here current is same. So we can say P is, so we can use the formula of power. That is nothing but P is equal to I square into R. and current is same, current is constant, so P is directly proportional to R. So means in case of series combination, power is directly proportional to R. Means the one, if I say, let's suppose in series combination, this is, let's suppose 10 ohm and this is, let's suppose 20 ohms, and we have this battery over here. If I say which will waste more power in this case, sir, battery will supply power, which will waste more power, 10 ohm or 20 ohm? We say, sir, P is directly proportional to R, so 20 ohm will waste more power or use more power, because in series combination I is same, I is constant, so P is directly proportional to R. Now my dear people, if I just tell you over here, we have got a resistance, and these are the two resistances connected in parallel. Okay, this is R1, this is R2, and in this particular case we know, sir, we have this R1 and R2, and in parallel combination, we know, sir, V is equal to same. Potential difference across each resistor is same. I have told you this. And if potential difference is same, we know, sir, P is equal to V square by R. If V is same, so we say P is inversely proportional to R. Okay, it depends which is same. If current is same, then we use P is equal to I square into R. If V is same, then we use P is equal to V square by R. Now over here, the one which has more resistance will consume less power. So means, let's suppose if we have this resistor, over here, this is 10 ohm and this is 20 ohm. Okay, they are connected in series. So if I ask you which will waste more power, which will consume more power, we say, sir, in parallel combination, P is inversely proportional to R. So we say over here, the one which has more resistance will consume less power. So we say 10 ohm will consume less power. Like in previous case over here, I told you, sir, 10 ohm will consume less power and 20 ohm will waste more power. Over here, 20 ohm will waste less power. Is it clear, guys? Is it clear to each and everyone? Let me know in the live chat. Is it clear to each and everyone? With the fire symbols, guys, I just need to know. Then we have Joule's law of heating effect. What is Joule's law of heating effect? Great. What is Joule's law of heating effect? Let me just tell you. Let's suppose we have a conductor over here. Okay, this is the conductor we have. Okay, this is the conductor we have. And in this case, if this is a conductor, we have, listen to me very carefully, and we say, sir, current is flowing inside this conductor. Okay, these are the electrons which are flowing inside this conductor. Okay, so we say, sir, current is flowing in this conductor. As current flows in the wire or a conductor, wire/conductor, we say it is heated. It is heated. Or it gets heat up. What does that mean? You say, sir, whenever you might have done this experiment at your home, whenever we say current flows in the conductor in a wire, sir, it gets hot. It becomes hotter. Okay, it becomes hotter. We say What? Okay. It becomes hot. Okay, hotter. Now see, whenever current flows through a conductor, through a wire, it becomes hot. You might have experienced this at your home. Okay, so we say when it becomes hot, it means that heat is released. You can feel that heat even if you touch it. It becomes hot means heat is released. So heat is released from the wire. Heat is released from the wire. Now my dear people, how much that heat is released, that is this is what we call the Joule's law of heating effect. Joule's law of heating effect tells us if through a conductor current flows, we say heat is lost in the conductor, heat is lost in the wire. Okay, heat is lost in the wire, heat is lost in the wire. So we say, my dear people over here, this is what we call the Joule's law of heating effect. Now to find how much heat is lost, how much heat is lost. To find how much heat is lost, we have a formula that is given by this Joule's law. That formula is equal to H is equal to, we say I square into R into T. I square into R into T. Keep this thing in your mind. If we have a conductor wire, my dear friends, and through this wire current is flowing, so we say heat is released. This conductor releases the heat. Heat is lost. How much heat is released? We say, sir, H is equal to I square into R into T. What is I? I is the current flowing through the resistor. Resistor, you say, if we say this is a conductor wire, it has the resistance. So we say where I is the current flowing in the resistance. And R is the resistance of this wire. R is the resistance of this wire. And T is the time for which current is flowing. T is the time for which current is flowing. And we say use this formula to find heat loss. Use this formula to find heat loss only if we say current is constant. If current is constant. Just a second. Okay, let me just show you over here, this one. Now see, so what I was trying to make you understand, let me just show you on this slide only. If we have, let's suppose we have, listen to me very carefully. If we have a conductor over here, okay, in this conductor, we say I is equal to 2 ampere current is flowing. So this current is nothing but, we say, sir, constant current. And we know, sir, heat is lost or released in this case. So that formula, in order to calculate the heat loss, you say, sir, I square into R into T. Use this formula to find the heat loss. Now, if I say we have a conductor over here, and in this case, sir, current is not constant. Let's suppose I is equal to T. Current is changing with time. When time T is equal to 1, current is 2. Current T is equal to 2, current is 4. So we say here I is not constant. So to find heat loss, heat loss, if we are supposed to find the heat loss in this case, we say, sir, H is equal to simply that is R integration of I square dt, integration of I square dt. My dear friends, what I'm trying to say is that if we have a conductor, and if through the conductor constant current is flowing, and we know, sir, it gets hotter, heat is released, how to find that heat? H is equal to I square into R into T. Use this only to find the heat when current is constant. And if current is variable like this, and you guys are supposed to find the heat loss, we can use this particular formula. Now let me show you the questions on this. Let's suppose we have this question. This is a resistor 2 ohm. This is a resistor 2 ohm. In this current, in this case, current is 2T. 2T current is flowing. In this case, current is 2 ampere. 2 ampere current is flowing. So you guys are supposed to tell me heat loss in both the cases in 2 seconds. Let me just tell you this one. This is the case 1 and this is the case 2. If I just talk about we say, sir, in case 2, clearly you can see I is equal to 2 ampere, means current is, sir, constant. 2 ampere, 3 ampere, 4 ampere, 5 ampere, this is constant. So if we have to find the heat loss, we use the formula I square into R into T. Sir, H is equal to I square. I is the current. That is how much? That is 2 ampere. That is 2 square into R. R is how much? That is 2 into T. For how many seconds? You say, sir, 2 seconds. That is 2. So 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is, that is 16 joules. So heat loss in this case is 16 joules. Now if I tell you, my dear people, that is nothing but you have to find the current in this. We say, sir, case 1. This is the case 1. We say, sir, in case 1, current is nothing but, that is 2T, which is variable. So means current is not constant. So we can say H will be I square. So we say H will be R integration of I square into dt. So we can write over here H is equal to R. What is the value of R over here? That is 2. Okay. And then you have integration of I square. I is how much? That is 2T. So that is 2T whole square into dt. And for how much time you have to find the heat loss? 0 to 2 seconds. So put the limits from 0 to 2. So this H will be is equal to, that is 2. This is integration of 2T whole square. That is 4T square. 4T square. Okay. And this will be dt from 0 to 2. You can solve it something like this. This is 2. Now see, this will be, sir, if this is 2, take this 4 out. 4 into 2 becomes 8. So this is 4 into 2 becomes 8. 4, take this. This will be 4 into 2 is 8. And then you have integration of T square. That will be T cube divided by 3. So from 0 to 2. So if you take this 4 out, 4 into 2 is 8, then integration of T square, that is T cube by 3. And you can write it something like this. This is H is equal to, that is 8 T cube by 3, and limit is from 0 to 2. So this H is equal to 8, and put the value of T as 2 cube divided by 3 over here. So H will be 8, and 2 into 2 into 2 is 8 by 3. So that is 64 by 3 joules. Is it clear to each and everyone, guys? Let me know. So if you have the constant current, how to find the heat loss? I square into R into T. If you have the variable current, how to find the heat loss? R into integration of I square into dt. Then you have the next topic, that's what we call the bulb. This is the topic that we'll be studying right now. Now see, what is the bulb? Bulb is which we use in our homes. That bulb only I'm talking about. Siri, full name, sis. Hey, what are you guys doing in the chat? Huh? Lot of people are writing over there, love you, something, something. Some people are saying, I am going, I'll need to eat some medicine, I am going. What is this you guys are doing? There are the other chatting apps where you can chat. Coming to my session and doing this stuff. No, they are not spamming, they are enjoying. And tell them to like the session. If they are enjoying freely in our session, tell them to like the session. Yes. Exactly. Okay, let's talk about the bulb. Let's talk about the bulb. Now see, let's suppose bulb is what? it is that bulb only which we use actually in our homes, okay? The bulb, okay? Simply. Let me make it something like this over here. This is what we call the bulb, okay? Now listen. Just a second. Now see, if you go to the market and if you buy a bulb over there, listen to me very carefully. If you go to the market and if you buy the bulb over there, it is mentioned, and if you check it, okay, if you check the box of the bulb, it is mentioned on the bulb, it is written over there, if the bulb is of 100 watt, it will be mentioned over there 100 watt, and it will be mentioned over there this 220 volts. Question is, what does this 100 watt mean and what does this 220 volt means? Listen to me very carefully over here. See, if you are going to the market, let's suppose I got this bulb from the market, and on this bulb it is mentioned 100 volts and 100 watts and 220 volts. Now see, if I say 100 watt is mentioned over here, 220 volt is mentioned over here, this is what we call the power rated and this is what we call the voltage rated. Okay, PR means power rated. This is power rated, and we say this VR, it means voltage rated. Voltage rated. Sir, what does PR and VR actually mean? It means that. It means that. What does it mean? If we it means that if we give a supply of 220 volts to the bulb, it will give us the 100 watt power. Sometimes you go to the market and you buy a bulb and you use it at your home. You say, sir, this is 100 watt bulb, but still it is not giving us that much amount of brightness or energy. We say in that case, you will not be supplying the proper voltage to it. So this power rated means, voltage rated means, if you give 220 volts is a fixed value. In India, this voltage rated, you will find it everywhere 220 volts. If you give 220 volts to this bulb, it will give you the power of 100 watts. Now, if you give less than 220, maybe it will not give you the exact value. Okay, so that's what is the meaning of power rated. Let's suppose I have got two more bulbs over here. Let's suppose this is the bulb. This is one more bulb. This is one more bulb. This is 50 watt bulb. Your father told you to get the 50 watt bulb from the market. This is 50 watt. And it will be over here mentioned 220 volts. This 220 will be mentioned at every bulb. Because in India, we get the supply of 220 volts, okay? And we say this is nothing but, let's suppose this is 75 watts, okay? This will be what we call the power rated. This will be what we call the voltage rated. This is what we call the power rated. And this is what we call the voltage rated. In America, you will get this all 110 volts. Now see, what does it mean? It means that if you give 220 volts supplied to this bulb, if you give 220 volts potential difference voltage to this bulb, it will give you 50 watt power. What does it mean? It means that if you give 220 volts supplied to this bulb, it will give you 75 watt power. I hope you got it. I hope you got it. What is the meaning of power rated and voltage rated? Okay, this is the meaning of power rated and voltage rated. Okay. Now, sir, bulb has a resistance. Bulb is a pure resistance. How to find the resistance of the bulb? How to find the resistance of a bulb? Let me just tell you, as we know, as to find resistance of the bulb. We say, sir, if we have to find the resistance of the bulb, we say, sir, power is equal to V square divided by R. Listen to me very carefully. We know one formula, that is nothing but P is equal to V square by R. Now, sir, over here, if we talk about the power, which power is given? That is power rated, that is PR. Because we know power rated of this bulb, that's why I am taking power rated. Then we have, it is what we call power rated or mentioned power. Mentioned power. And you have VR over here, that is VR square. And then you have, this is the resistance of the bulb. Okay. Because VR, you know. Sir, why are you mentioning PR and VR? Because PR is given. VR is given. That's why this will, power rated and voltage rated also helps us to find the resistance of the bulb. One more thing. Now, over here, from this we can say, take it over there. So we'll say resistance of the bulb, interchange their position. It will be equal to VR square divided by resistance of the bulb. Power of the bulb. Means power rated. So this is how do you find the resistance of the bulb? Means this power rated and voltage rated helps you to find the resistance of the bulb. If you have to find the resistance of this bulb, what will you do? Sir, resistance of the bulb is VR square divided by PR. We just recently calculated this. This is the formula. Now, how much is it? Sir, VR in this case is 220, its square divided by power rated is 50. Calculate, you will get the answer. In this case, if we have to find the resistance of the bulb, that is VR square, that is 220 square divided by, sir, power rated, that is 75. Solve it and you will get the answer. So basically, power rated and power voltage rated helps us to find the resistance of the bulb also. Now listen to me very carefully. Now listen to me very carefully. Now see, if I say, sir, as resistance of the bulb is nothing but VR square divided by PR. Okay. Okay, cool. Now, if I talk about, now let's talk about power consumed. Power consumed. Sir, what is power consumed? Listen to me very carefully. We say, sir, power consumed is nothing but, see, when it comes to the power rated means how much is the power mentioned. How much is the power mentioned? Okay. And when it comes to the power consumed is something different. Power consumed is something different. Listen to me very carefully. See, power rated is how much is the mentioned power on the bulb, and power consumed is how much it is giving you. Like, let's suppose you are bringing a bulb of 100 watts. Okay, 100-watt bulb you are bringing from the market. So this is what we call the power rated. How much is mentioned, how much company is claiming this will give you the power. But when you are using it, you are at your home, it is giving you only power of, let's suppose, 25 watt. So this is what we call the power consumed. This is power rated mentioned and this is power consumed. Why is it giving us a 25 watt only? Maybe you are giving less voltage to it. It depends upon the supplied voltage. Now see, this power consumed, I'll write over here. It is how much a bulb, it is how much a bulb is giving power. It is how much a bulb is giving power. It is how much a bulb is giving power. And it depends upon supplied voltage. Okay, it depends upon the supplied voltage. Now see, my dear friends, I can say, sir, this power consumed is equal to voltage supplied, its square, divided by resistance of the bulb. As P is equal to V square by R. When it comes to the power consumed, we write voltage supplied. When it comes to the power rated, we write voltage rated by RB, resistance of the bulb. But power consumed is how much power this is consuming. Consuming also means if this is consuming more power, it is giving more brightness. If it is consuming less power, it is giving less power. It is giving less brightness. So it is Vs square by V RB. Now we can write it something like this. Sir, PC is equal to Vs square divided by, instead of RB, can I put VR square by PR? Yes, VR square divided by PR, and if you take that in the numerator, that will be something like this. Now keep this in the bracket. So we say power consumed is directly proportional to the power rated. What does it mean? It means that if you have got 100-watt bulb and you have got 200-watt bulb, so 200-watt bulb will consume more power. Power rated is directly proportional to power consumed. 200-watt will give you more brightness. 100-watt will give you less brightness. Why? Because PC is directly proportional to PR. Is it clear till over here? Is it clear? Let me know. You got the difference? What is the difference between, you got the feel, what is the difference between power consumed and power rated? Power consumed is nothing but how much a bulb is consuming the energy. The more it will consume the power, more brightness it will give you. Power rated is how much is mentioned, how much they are claiming that it will give you the power. Okay. Now we have series combination of bulbs. Let's suppose we have got one bulb over here. Okay. We have got another bulb over here. We have got another bulb over here. Resistance of this bulb is R1, R2 and R3. Now in this particular case, if these three bulbs are connected in series, we have to find the net power consumption by the bulbs in series. To find the net power consumption by the bulbs in series. Now see, when it comes to the bulbs in series, the net power consumption will be, as I told you, sir, this bulb consumes power, this bulb will also consume power. We have different bulbs over here. Different bulbs consume different power. Now if you connect them in series, so how much they will consume the power in series, net power consumption, that will be 1 upon P1 plus 1 upon P2 plus 1 upon P3. Power of this one plus power of this one plus power of this one. So this will be the net power consumption in that case. Now the question over here is, see, if we have three bulbs, 1, 2 and 3, they are connected in series. We have to compare their brightness. Compare the brightness of the bulbs. Which will give more power? Which will consume more power? Or which will give more brightness? That's what we are supposed to say. See, as we know, we have connected three bulbs in series, different power. Let's suppose this is 25 watt, 100 watt, 200 watt. Okay. They are connected in series. We have to check which bulb over here will give more light, more brightness, which will consume more power. Let's suppose we say over here, as we know, we say, sir, power is equal to, that is simply, sir, P is equal to I square into R. Sir, power consumed is equal to I square into R. R means resistance of the bulb. As in this particular case, I is constant because in case of series combination, current is same across all. Now we say over here, sir, power consumed is equal to I square into R. We know this formula. So power PC is equal to resistance of the bulb. So we say if I is same over here, we say, sir, PC is directly proportional to the resistance of the bulb. Now listen to me very carefully. As resistance of the bulb we already studied, that is VR square divided by power rated. If this is the formula, now put this formula over here. So I can say power consumed is proportional to, instead of this resistance of the bulb, can we just write, sir, VR square divided by PR. Yes. Now voltage rated, it is constant, 220 volts. So we can say power consumed is inversely proportional to the power rated. This is very important. What does it mean? It means that the one which has got less power rated will consume more power. It means that the one which has got less power rated will consume, we say, more power, because power consumed is inversely proportional to the power rated in series combination. That's what I was trying to say. Let me show you the question on this one. Let's suppose we have got 25 watt, 50 watt and 100 watt, 3 bulbs in series. We have to compare the brightness of the bulbs. See, as we have to compare the brightness of the bulbs as we say over here. Listen to me very carefully. As we say, power consumed is inversely proportional to the power rated we say in series combination. So the one which has got less power will consume more power. Now in all the three, which has got less power rated? 25 is the less power rated, so it will consume more power, and the one which consumes more power will give more brightness. So here 25 watt has less power rated, so it will consume more power. If it consumes more power, so brightness of 25 watt is greater than brightness of 50 watt is greater than brightness of 100 watt. This will be the order. Guys, is it clear to each and everyone? I want all of you to let me know. The ones who are not putting up yes or no in the chats, I want those students also to put up right now. If this is clear. If not, let me know, as simple as that. If you have not liked the session, do like the session as soon as possible. Now see, parallel combination of the bulbs, power drop in parallel combination. If you have the bulbs connected in parallel, okay, and you have bulbs connected in parallel, this has P1 power, P2 power, P3 power. Now here bulbs are connected in parallel. Here bulbs are connected in parallel. To find the, here bulbs are connected in parallel. To find the net power consumed. In this case, in case of parallel combination, how do we find the net power consumed? We say, sir, net power consumed, P net in this case will be, that is simply power of first bulb plus power of second plus power of third, as simple as that. If n bulbs are connected in parallel, then P net is equal to n times of V. If n identical bulbs are connected. if you have these bulbs connected in parallel, okay, and you are asked to find their net power consumption, how much net total they consume power in parallel, this is the formula that you will be using. Now in this particular case, let me just tell you one thing. What is that? Let's suppose you have got a bulb over here. You have got one more bulb over here. You have got one more bulb over here. Okay, these bulbs are in parallel. As we know, in parallel combination, we know, sir, voltage is same across all. Potential difference is same across all. Okay, yes. Now, sir, we know we can use this formula, P is equal to V square divided by R. Now this P is nothing but power consumed. This V is nothing but voltage rated. Okay, and this is simply in this case resistance of the bulb. This is simply resistance of the bulb. As simple as that. Okay, resistance of the bulb, V square by R. Now this is voltage supplied, sorry. Okay, power consumed is equal to voltage supplied divided by resistance of the bulb. Now you guys tell me something, that is voltage supplied is equal to same. See, if I say these bulbs are connected in series, okay, now over here in this particular case, the voltage across this is equal to voltage across this is equal to voltage across this. So we say voltage will be same across all. So we can say if this voltage is constant, so power consumed is inversely proportional to the resistance of the bulb. My dear friends, listen to me very carefully. And we know what is the formula for resistance of the bulb. We recently calculated. Sir, resistance of the bulb is how much? Let me just show you over here. Resistance of bulb is how much? We say, sir, when it comes to the resistance of the bulb, that is VR square divided by PR. That is VR square divided by PR. So we say, sir, VR square divided by PR. PR is the power rated. And if you take this in the numerator, so PC is proportional to, this will be, sir, that is PR. VR is constant because voltage rated is 220, that is constant. What I'm trying to say is that I took 3 bulbs in parallel, and I'm saying that in case of parallel combination, voltage supplied, if this battery is supplying the voltage, that will be same across all. If voltage across same is all, we say, sir, power consumption is equal to Vs square by Rb. Sir, Vs is voltage supplied square divided by resistance of the bulb. As voltage across all is same, so power consumed is inversely proportional to resistance of the bulb. As the resistance of the bulb is VR square by PR, so if you take, it will be multiplied over here. So power consumed is directly proportional to the power rated. So the one which has more power rated will consume more power. So the one which consumes more power will give more brightness. Let me ask you the question over here. Let's suppose we have a question over here. Yeah. Let me just show you. We have a question over here. We have got a bulb. Okay. We have got one more bulb. Okay. We have got one more bulb. Okay. These are the 3 bulbs connected in parallel. Okay. Fine. Now, this is 25 watt. This is 50 watt. And this is 100 watt. You guys are supposed to tell me, compare the brightness of the bulbs. Now, my dear people, if we have to compare the brightness of the bulbs, you tell me one thing. As in parallel combination, we recently studied, sir, as in parallel combination of the bulbs, power consumed is directly proportional to the power rated. Power consumed is directly proportional to the power rated. And in series combination, we said, sir, power consumed is inversely proportional to the power rated. So means the one which has got more power rated will consume more power. So over here, 100 watt has more power rated. So it will consume more power. So it will glow more. It will glow more. I can say in this case, brightness of 100 watt is greater than brightness of 50 is greater than brightness of 25. This is the order. Is it clear? Is it clear, guys? Let me know. Is it clear to each and everyone? Now we have this question over here, which was asked in NEET 2019. Now the question over here is, I hope this is visible. Yes, this is visible. Now see, what does the question says? The question says that we have got 6 similar bulbs over here. These are the 6 similar bulbs over here. And a battery is connected to them. We have got a 6 similar bulbs over here. Okay, let me just make it over here. These are the 6 similar bulbs over here. Okay, these are the 6 similar bulbs. And resistance of each resistance of each bulb you consider as R. We'll take a break after 10 minutes. After 10 minutes, we'll take a break. So we have these 6 bulbs. So resistance of all these bulbs are, this is R, 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 this is R. All have the same resistance R. We are supposed to find the power ratio of power consumption first when all are glowing. Listen to me very carefully. Case number first. Let me just make you understand first, and then I'll tell you. See, first is when all the bulbs are glowing. We say if all these bulbs are glowing over here, if all these bulbs are glowing, means in that case, could you find the power? When all the bulbs are glowing, when all the bulbs are glowing, okay? In that case, you guys are supposed to tell me the power. Let's call that P1. We know, sir, power is equal to V square divided by R equivalent. Now over here, what is the value of V? V is given as E. So this will be E square upon R equivalent is how much? See, when all the 6 bulbs are glowing at that point of time, you have to take the resistance of all 6. So we say, sir, resistance will be simply, listen to me very carefully. This is R. These 3 are in parallel. So R equivalent will be R by 3. Whenever you have n identical resistors connected in parallel, their equivalent is nothing but R by n. Over here, n is 3, so R by 3. And these 3 resistors are also in parallel, so plus R by 3. Their equivalent are in series. So we say, sir, R equivalent will be R by 3 plus R by 3 is 2R by 3. So when all the 6 bulbs are glowing, at that point of time, you have to take the resistance as 2R by 3. That is equivalent of all the 6. So R equivalent will be simply that is 2R divided by 3. And if you take this in the numerator, that is 3 E square by 2R. This is power 1. And then the questioner says second, when first in case 1 it is saying when all are glowing, find power. Then in case 2 it is saying when 2 from section A and 1 from section B are glowing, then find power and then find the ratio. So the case 2 is when 2 from section B, 2 from section A and 1 from section B is glowing. Okay. Now see, in that particular case, if we say, sir, if 2 from this section, we call this as A section, we call this as B section. 2 from section A are glowing, 1 from section B are glowing. If only 2 are glowing from section A, we'll take the resistance of these 2 only. If 3 are glowing from section A, then we take the resistance of these 3. So we say in that case, R equivalent will be, sir, see, from section A, 2 bulbs are glowing. So take the resistance of only 2. So that is R and R in parallel. So it will be R by 2. So it will be R by 2. Then plus 1 from section B is glowing. Then take only 1 from section B. So that is plus R. So this will be 2R plus R. That is 3R divided by 2. Now in this case, how much will be power consumption? That is P2 is equal to V square by R. That is E square divided by R equivalent. That is 3R divided by 2. Now take this in the numerator. This is 2E square by 3R. Now finally what you are supposed to do is you have to find the ratio of P1 and P2. Sir, P1 divided by P2 will be, when it comes to the P1, that is 3E square by 2R, 3E square by 2R upon, and when it comes to the P2, that is 2E square by 3R, R, E square. So you can write this is 3 by 2. Take this in the numerator. So this will be 3 by 2. So P1 divided by P2 is 9 by 4. Ratio is 9:4. Is it clear, guys? Is it clear to each and everyone? We were supposed to calculate the P1 by P2. P1 is the power, net power, when all the 6 bulbs are glowing. P2 is the power when 2 from section A and 1 from section B is glowing. Great. Let's move on to the next one. We'll solve this question and we'll take a break. After this, because once we are done with this question, then we have to finish the galvanometer, ammeter, voltmeter, okay? That will be the separate discussion. So first we say over here, let's solve this question. Let's suppose in this question we have this was a question asked in NEET 2019. So we have a filament bulb of 500 watt is to be used in a 230 volt main supply. We have a filament bulb. We have a filament bulb of 230 of 500 watt and 100 volt is its voltage rated. Means it can accept only 100 volt supply, and a 230 volt main supply is used over is basically given to it. This is a battery having 230 volt supply. When a resistance R is connected in series, and it works perfectly fine, we have to find the value of this resistance. We are given a bulb 500 watt, 100 volts, 230 volt battery is used. We have to find the value of resistance. Now guys, listen to me very carefully. This is giving the 230 volt supply. Now in this case, how much supply voltage this will take? It can take only 100 volts. If you give it more than 100, it will burn out. So this will take 100 volts, and from 230, how much is remaining? That is 130. So 130 will go in this one. Okay. If there was no resistance present over here, then this bulb will burn out. Why? Because you are giving 230 directly to this bulb. Over here, resistance is in series. So if this takes 100, this will take 130. Now see, because its limit is only 100. Now see, sir, we have to find the value of this resistance R. As we say, sir, power is equal to V into I. Let's first find the current. As battery supplies the current, let's find that current. We say, sir, power is equal to V into I. Power in this bulb is 500 is equal to voltage in this bulb is 100, and this will be I. This. So I will be nothing but 5 ampere. Now this 5 ampere will go in this bulb and in this resistor. Same 5 ampere goes in a resistor R because they are connected in series. Now over here, we can say V is equal to I into R, and R I can write V divided by I. Now V is how much over here? How much is the voltage across this resistance? That is 130 divided by how much is the current in the resistance that we calculated, that is 5. So this will come out to be 26 ohms. So value of resistance is 26 ohms. Break till we say twelve three. Break till 12. That will be 12 a.m. Huh? We have only few topics remaining now. 80% of the current electricity is done. 80% current electricity is done. Let's make it break till 12:05. Okay, guys. Is everything visible? Let's move on to the new topic. That's what we call the galvanometer. Okay, that's what we call the galvanometer. Let's talk about the galvanometer over here. Let's talk about the galvanometer over here. Okay. Now see. We say this galvanometer, it is a device. It is a device used to detect and measure the current. Okay, so if you have to measure the current anywhere, if you have to detect the current anywhere, we say we use this device which is called the galvanometer. So galvanometer basically helps us to detect the current and measure the current in a circuit. I'll tell you each and every single thing. Listen to me very, very, very carefully. We say, sir, this galvanometer has a small range. Okay, it has small range, and produces large error. Okay, what does that mean? See, galvanometer has a small range means the current galvanometer is able to measure is a very small. It measures very small currents. And second thing is it produces large error. Let's suppose if we use a galvanometer in some circuit, and once we basically measure the current by using galvanometer, the error is very large in the results. Okay, now see. So let me just tell you over here. Error produced in a galvanometer. So we have a galvanometer. Okay, let's suppose we have this galvanometer. If we use this galvanometer anywhere to find the current, we say it produces large error. Okay, now listen to me very carefully. Let's suppose we have a circuit. I'll tell you how error is actually being produced in the galvanometer. That's what I'll make you understand over here. How error is actually being produced in the galvanometer. That's I'll make you understand. Let's suppose we have a resistance over here. That is 2 ohm. And a battery is connected 10 volts. If I ask you the simple question, how much is the current in this resistance in this circuit? You say, sir, I is equal to V divided by R, and V in this case is 10 volt. R is that is nothing but 2. So this will come out to be that is 5 ampere. As simple as that. Now, sir, we have a device. That's what we call the galvanometer, which is used to measure the current. Now use galvanometer to measure the current. Use galvanometer to measure the current. So listen to me very carefully. We took the same 2 ohm resistor over here, same battery over here, but right now we are connecting a galvanometer over here to this entire circuit. And the resistance of the galvanometer is basically 3 ohms. Okay, so this is 3, this is 2, and in this case we have a connected over here that is 10 volts. Why we have connected the galvanometer? In order to measure the current over here. So now in this case, when we have now use the galvanometer to measure the current, after using the galvanometer, we will check if the current comes out to be the same. This is what we call the true value of current, I true, which is actually the current over here. Let's see, after using galvanometer, will we get the same current in this one or not? If we get the same current, means there is no error produced in the galvanometer. Let's check. So we say, sir, I is equal to V divided by R. V in this case is, sir, 10, and R in this case is, sir, equivalent resistance. The resistance of galvanometer 3, and this is 2. Galvanometer has its own resistance, that is 3 plus 2 is nothing but 5. And this will be nothing but, we say 5 ones, 5 twos, that is 2 ampere. Now, this is what we call the measured value of current. I measured. Now, what is the true value? 5. What is the measured value? That is 2 ampere. So, means there is a huge error in the reading of this galvanometer. Now, if I ask you, check percentage error. Okay. How many percent error actually occurred over here? How to find that? We say, in order to find the how much percent error is exactly produced in the reading. So let's check that. How do we find that? We say, sir, I true minus I measured upon I true. True value of current minus measured value of current upon true value of current. And then if you have to find in percentage, multiply it with 100. So I can further write it something like this. So this will be percentage error is equal to I true, that is 5 ampere. We say this is 5 minus I measured. I measured is how much? That is 2 ampere. We say, sir, that is 2 upon 5. And then you have multiplied by 100. So you can write 5 minus 2 is, that is 3 divided by 5 into, we say, sir, 100. And this is 105 into 20. So 3 into 20 is 60%. So by using the galvanometer, how much error actually came in this one? That is nothing but, we say, 60% error occurred over here. So that's what I told you. Sir, this galvanometer is a device which is used to detect and measure the current. It has a small range and produces large error. It produces large error. If you send large current through it, it will burn out. Is it clear now? Is it clear, guys? You got it? How galvanometer is producing the error? You got it? Is it clear, guys? I just need to know in the live chat. Great, great, great. Now see, sir, we know this galvanometer, it produces large error. Okay, so we say it is a bad galvanometer. Now we need to make a new galvanometer. I'll write over here, make new galvanometer. Okay, even I say good galvanometer. Good galvanometer. Sir, what does good galvanometer mean? That galvanometer which produces, we say, less error, and measures large current, okay, measures large current. So now that's what we call the ammeter. Ammeter is also a galvanometer, but it is the modified version of galvanometer. As galvanometer has large error, it has, we say, sir, galvanometer has large error. We say, sir, it measures small currents. Now make that galvanometer which produces less error and which has large currents over here. Okay, which measures larger currents. So we say that's what we call the ammeter. That's why it is conversion of galvanometer into ammeter. Okay. So now we say to make galvanometer from ammeter. To make galvanometer from ammeter. Let me just tell you how do we make it. See. Let's suppose we have a galvanometer over here. This is the galvanometer. It has got resistance G. Okay. As we know, sir, in this galvanometer, how much amount of current it can measure very small amount. Let's call that Ig. Ig is the current that the galvanometer can measure. If you send more current than Ig through the galvanometer, it will burn out. So in order to make this galvanometer an ammeter, how do we do it? Let me connect a resistance which is called a shunt resistance to this in parallel. This is the shunt resistance which is connected in parallel. So we say connect a shunt resistance in parallel to galvanometer. Connect a shunt resistance in parallel to galvanometer, and it becomes ammeter. Sir, what is ammeter? Ammeter is also a galvanometer which is used to measure the current, which produces less error and measures large currents Okay. Okay. And most importantly, when it comes to this shunt resistance, we say, sir, this shunt is very small. There is a reason behind it. Why do we keep this shunt resistance as very small? Now listen to me very carefully, guys. If you have to make the galvanometer, the ammeter from galvanometer, what will you do? You will connect a shunt resistance parallel to this one. Now, it will measure the large currents. Let me show you how. See, let's suppose the current coming from this side is, let's suppose I is a large current. Now the question is, how much galvanometer can basically measure, or how much current can flow through the galvanometer? That is Ig only. If you send more than Ig through the galvanometer, it will burn out. Now, if Ig goes over here, we say, sir, this is another branch. Through this branch, how much current will be there? We say I minus Ig. I minus Ig will go into this, So this shunt, why, sir? This shunt resistance is small. So current always prefers to go through that path where less resistance is present. So over here, this shunt is small. So this resistance is small resistance. If the current comes from over here, so it will prefer to go through that path which has less resistance. So we say, sir, over here, if let's suppose 100 volts, 100 ampere is coming. So 10 ampere will go through this one, 90 ampere will pass through this shunt. So we say, sir, now this instrument is called ammeter. This instrument is called ammeter. We say this is I, and Ig will go in this one, and this will be I minus Ig. Now, this is the galvanometer. I hope you got it. From galvanometer, if you are supposed to make the ammeter, just connect a shunt resistance. We say Ig is the current which can go through galvanometer, and rest of the current will go through shunt resistance. Now we have to find what should be the value of shunt resistance that we should connect over here. To find shunt resistance in ammeter. You tell me one thing. If I say, sir, over here, shunt resistance and galvanometer both are connected in series. So means the potential difference across this shunt, let's call that Vs, will be potential difference across this galvanometer, that is Vg. Why, sir? Because both are connected in series. So we say as shunt and galvanometer are in series, both are connected in series. So I can write over here, that is potential difference across galvanometer will be equal to potential difference across shunt. Potential difference across galvanometer will be equal to potential difference across shunt. Okay. Now, when we have to write the potential difference of the galvanometer, how do you write? Sir, V is equal to IR. V is equal to IR. Now, over here in this galvanometer, how much is the current? That is Ig. And how much is the resistance? That is G. So we can say this will be Ig into G is equal. Now, voltage across this shunt, that is V is equal to IR. V is V. I is how much? I minus IG. I can write over here. I minus IG is the current in shunt. And then IG into I into R. What is the resistance in the shunt? That is S. S is the resistance of the shunt. That is S. And this S is what we are supposed to calculate. Now, my dear friends, can we find the value of S? This will be simply, that is Ig into G upon I minus Ig. I minus Ig. This is the value of shunt resistance when it comes to the galvanometer, when it comes to the ammeter. If somebody asks you from now onwards, how much is the shunt resistance we are supposed to use in case of an ammeter? So this will be the shunt resistance. Let me show you the question number 1 on this one. We are given a galvanometer of resistance 100 ohms. Over here we have a galvanometer. It has got a resistance of 100 ohms. Okay, is used to measure 10 ampere current. So means this galvanometer can measure how much current. Ig is equal to 10 ampere. Okay, so 10 ampere can flow through this galvanometer. Find the value of shunt resistance. A shunt resistance is being connected over here, means now it becomes an ammeter. Find the value of shunt resistance if connected in parallel, so that its range becomes 50 ampere. Means it should be able to measure how much? We say, sir, 50 ampere. Now 50 ampere should come from this side. Only 10 ampere can flow through galvanometer, because galvanometer, through galvanometer small currents flow, and rest of the current will go through this one. So we say, sir, in this case, this will be I minus Ig, because Ig is the current through galvanometer. This will be I minus Ig. Now you guys tell me one thing, sir, we have to find what should be the value of shunt. Sir, shunt is equal to Ig into G upon, we say, I minus Ig, as simple as that. Now Ig is how much? That is 10 into, sir, G is how much? G is 100. Okay, upon I minus Ig. I is how much? We say, sir, in this case, I is, that is 50. Okay, minus Ig is how much? I is the current measured by ammeter, that is 50, minus we have 10 over here. Okay, so this will be 100 into 10 into 100 upon, this will be 40. This and this will get cancelled. 100 by 4 is 25 ohms. So the value of shunt should be 25 ohms in order to calculate the current of how much? 50 ampere. So shunt should have the value of 25 ohms. Then only it will measure the current of 50 ampere. Guys, let me know in the live chat if this is clear to each and everyone. If this is crystal and clear. Let me move on to the next question over here. In this case, we are given a galvanometer, okay? And in this galvanometer, we are given a galvanometer, and in this galvanometer, 0.2 I of the main current passes through galvanometer. 0.2 I of the main current passes through the galvanometer. If we say I is coming from this side, so 0.2% of that current passes through the galvanometer. It will take 1 hour. It will take 1 hour, okay? So we say 0.2 I will pass through this galvanometer. Sir, how much is remaining? We say, sir, 99.8 I is remaining. That will pass through the shunt. Okay? If total is 100%, 0.2% will go through galvanometer. How much is the remaining? You say, sir, 99.8%. 99.8 plus 0.2 is 100. So that will pass through the shunt. And resistance of the galvanometer is given as G. Shunt is given as S. You guys are supposed to tell me find the resistance of ammeter. We have to find the resistance of ammeter. See, As a whole, we call it ammeter. As a whole, we call it ammeter. This is galvanometer. This is shunt. So ammeter means both. Means a resistance of galvanometer plus resistance of shunt. That will be the resistance of ammeter. That's what we are supposed to calculate. See, resistance of galvanometer is given. If we find the resistance of shunt, then we will find their equivalent in parallel combination. That will be the answer in this case. See, here, let's find the shunt first. Let's find the shunt first. We say, sir, shunt is nothing but Ig into G upon I minus Ig. This is how do we find the shunt. Now, Ig is how much? We say, sir, current through galvanometer, that is 0.2I, which is given. 0.2% of main current passes through the galvanometer. Okay. Now see, we say Ig, that is 0.2I into G. Into G, yes, this G, because G is the galvanometer resistance upon I minus Ig. I minus Ig is how much? That is current through shunt. That is 99.8. We say I. Now you can write over here, I and I will get cancelled out over here. 2 you can write over here 2 by 10 into G upon, instead of 0.2 you can write 2 by 10. It is one and the same thing, 2 by 10. Okay. And then you have G upon 998. This is 999.8. You can write 998 divided by 10. This and this will get cancelled out. 2 ones are 2, 499s are. So answer will be G upon 499. Means shunt. So the value of shunt is how much? Value of shunt is nothing but G upon 499, where G is the resistance of galvanometer. Now you guys tell me one thing. We got the value of shunt. We know the value of galvanometer. Both are in series, both are in parallel. As resistance of galvanometer and shunt are in parallel. So we say resistance of ammeter will be, listen to me very carefully. If we have two resistors in parallel, how do we find their equivalent resistance? We say, sir, R1, R2 upon R1 plus R2. Now you just tell me one thing. R1 is resistance of galvanometer. Resistance of galvanometer is G. Resistance of shunt is G by 499. So it will be G into G by 499 upon, we have G plus G upon 499. So this will be G square, G into G becomes G square upon 499. Then we have whole divided by, this is 499G plus G, that is 500G divided by 499. This will get cancelled out, and this square and G will get cancelled out over here. So what remains is resistance of ammeter will come out to be G by 500. So this is the resistance of ammeter. Is it crystal and clear, guys? In the live chat, give me the signal. Give me the signal in the live chat, guys. Is it crystal and clear to each and everyone? HSP sir is in the chat. Thank you so much, sir. Thank you so much, sir. Means a lot. HSP sir saying great energy. Okay. HSP sir himself is a legend. He is one of the true legends, honestly. Okay. Let me just. This is the question from one more from this ammeter only, galvanometer and ammeter. This I'll keep as homework. Okay, this I'll keep as homework. Now let's talk about the galvanometer as a voltmeter. Let's talk about the galvanometer as a voltmeter. Listen to me very carefully. Now see, sir, previously you said when it comes to the galvanometer, this galvanometer is a device. This galvanometer is a device which is used to measure the current. Okay, sir, does it measure the potential difference or voltage also? Yes, it is a device which measures, we say voltage also. That is potential difference. Okay, voltage or potential difference. But the problem is it produces large error. It produces large error here also. In case of while measuring the current, this galvanometer was basically producing the error. Over here also, while measuring the potential difference or voltage, it produces the error. Let me show you how this galvanometer produces error while measuring the potential difference. Let's suppose we have a circuit something like this. We have 20-volt battery. This is 2 ohm resistance. This is 3 ohm resistance. Now in this case, if I ask you to tell me the potential difference across 3 ohm resistor, find potential difference across 3 ohm resistor. Let me show you how do we find it. First of all, let's find the current in the circuit. You say, sir, I is equal to V divided by R. V is how much? That is 20 divided by R. R is how much? Resistance in the circuit is 3 plus 2 is 5. So 20 by 5. That will come out to be 4 ampere. Now this 4 ampere will go in this 2 ohm resistor as well as in this 3 ohm resistor, because this is in series. Both the resistors are in series. So 4 ampere will go in both the resistors. Now listen to me very carefully. If we have to find the potential, we say, sir, potential difference in 3 ohm resistor. Can I just write, sir, V is equal to I into R? Yes, sir. So we say V is equal to I is how much? That is 4 into R. In which resistor you want the potential difference? 3 ohm. So 4 into 3, that is nothing but 12 volts. Okay. So potential difference across this AB is nothing but 12 volts. Let's call this as A. Let's call this as B. Now this is the true value. That is true value of potential difference which we actually got. Now, if we have to find the potential difference using galvanometer, now we will use the galvanometer and check if the error comes or not. Now we are using the galvanometer over here to find the voltage across this 3 ohm, So we have the same circuit over here, 2 ohm resistance. But right now I am using a galvanometer. I hope this is visible. Yes, we are using a galvanometer of 6 ohm resistance. This galvanometer I am using the 6 ohm resistance. Now, after using the galvanometer, we have to measure the voltage. Now you tell me one thing, sir. Can you find first current in this entire circuit? Yes. Now see, sir, this is 6 and this is 3. If you find the equivalent of this 6 and 3, that will come out to be 2. Sir, how? R equivalent is equal to 6 into 3 upon 6 plus 3. That is 18 by 9. That is equal to 2. So means 6 and 3 are having the equivalent of, let me make the figure once again. So this is 2 ohm resistor, and equivalent of this resistance and this resistance is nothing but, we say, sir, that is 2 ohm. And I'll take it over here. This is the battery. That is 20 volts. This is the battery. That is 20 volts over here. Okay. Now, my dear friends, this was the point A and this was the point B. Now, can you find the current in this one, sir? We say current is V by R. V is 20 by R is 2 plus 2 is 4, 20 by 4. And that comes out to be 5 ampere. Okay. Now, in this circuit, current is 5 ampere. Now, if I ask you to tell me, how much is the potential difference across AB? You say, sir, potential difference across AB is equal to V is equal to I into R. Sir, I into R. Sir, I we got that is 5 into. Sir, R is how much over here across AB? Right now, it is, sir, 2, 5 into 2. So this comes out to be 10 volts. See, guys, without using the galvanometer, potential difference across AB came out to be 12 volts. After using the galvanometer, sir, this galvanometer G of having 6 ohm resistance, we calculated the potential difference across AB. That came out to be 10 volts, and this is what we call that. This is what we call the measured value. Now, if we find the percentage error in galvanometer, so that will be, sir, V true minus V measured upon V true. Sir, how much is the V true over here? V true value is nothing but, we say, sir, that is how much? That is 12 volts. We say this is nothing but 12 minus, sir, measured came out to be 10 upon true value is 12 volts, and multiply this with the 100. Over here also multiply with 100 to find in percentage. So you will get it. This is 12 minus 10 is 2 by 12. That is 1 by 6. So this will be 100 by 6. That is 16.6%. So error in this case came out to be 16.6%. Wasim's are OP in the chats, huh? Okay. So this is the error produced by galvanometer while measuring the voltage also. Is it clear, guys? Okay. Now listen to me very carefully. Now we say conversion of galvanometer into voltmeter. Previously, we converted galvanometer into ammeter. Now we will be converting the galvanometer into voltmeter. Here, we will convert galvanometer into voltmeter. Sir, what is voltmeter? Voltmeter is a device which measures the potential difference and which produces less error. Because when galvanometer is measuring the potential difference, it produces large error. So we say we will use the voltmeter, so it will produce less error. Now let's suppose we have a galvanometer over here. See, previously, when we made the ammeter from the galvanometer, what we actually did is we connected the shunt resistance in series, in parallel, sorry. Now, in order to make the voltmeter from galvanometer, so what we do is that we will connect the shunt in series. We say here, we connect the shunt resistance in series. Okay, this is the shunt resistance. Now the question is, sir, over there we calculated what is the value of shunt. That was Ig into G upon I minus Ig. How to find the value of shunt in this case? Sir, we say, let's suppose the potential difference across this is, let's suppose that is V. Okay, and how much is the current which can flow through the galvanometer? That is Ig. Ig is the current flowing through the galvanometer. Now listen to me very carefully, my dear people over here. Listen to me very carefully. Now, could you please tell me what is the value of this V? You say, sir, V is equal to I into R. I is the current in this case, that is Ig. And resistance is how much? That is resistance of galvanometer plus resistance of this shunt. We have to find this shunt only. Now take this and divide it over here. V upon, we say sir, Ig is equal to, we say sir, G plus S. Now if we find this S, so S will be simply take this G over there, V divided by, we say, Ig minus this G will be the value of shunt over here. So means from now onwards, you will remember that if you have a galvanometer and if you have to make an ammeter from the galvanometer, you will connect a shunt resistance connected in parallel. And if you have to make a ammeter from this, you will connect a resistance shunt S dash in series. By connecting the shunt resistance in series, it becomes the voltmeter. And now again, if you have to make this as a ammeter, you connect one more shunt resistance S double dash in series, in parallel, sorry. And if you have to make again it a voltmeter, then connect one more resistance, shunt resistance S triple dash in series, it will become ammeter. Is this clear? Is this clear, guys? Is this clear? Each and everything, let me know in the live chat. Is this clear, guys? Okay. And what is the value of shunt resistance in case of voltmeter? That is V by Ig minus this galvanometer G. Let's solve the question on this one. Let's first solve this question. A galvanometer has a resistance of 100 ohm. This is a galvanometer which has a resistance of 100 ohm. Okay. And gives a full scale deflection of 30 milliampere. Okay. If it is to work as a voltmeter, then the required resistance added will be, we are given a galvanometer and a shunt is connected in series because we have made this a galvanometer. And in this case, it measures the current, it measures the voltage, V is equal to 30 volt. Okay. And how much current can flow through the galvanometer? That is given as 30 milliampere. We are given a galvanometer, 30 milliampere can flow through the galvanometer. Resistance of galvanometer is 100 and voltage across this entire galvanometer is nothing but, voltage across this entire voltmeter is nothing but 30 volt. And the shunt resistance is connected in series. We have to find the value of shunt resistance. We know, sir, shunt resistance is equal to, we recently calculated in the last slide how much it came out to be. Listen to me, that is V upon Ig. We say V upon Ig minus G. V upon Ig minus G. We say V upon Ig minus, we say G. So S will be, what is the value of V? V is 30 volt upon, what is the value of Ig? That is 30 milliampere. If you convert it in ampere, then multiply with the 10 raised power minus 3. Then you have minus G. G is given as 100 ohms. This is 100 ohms. 30 and 30 will cancel. 10 raised power minus 3 will go in the numerator. It becomes 10 raised power plus 3 minus 100. 10 raised power plus 3 means 1000. 1000 minus 100 is equal to 900 ohms. So in this case, this shunt has to be equal to 900 ohms. Is it clear, guys? We are given a galvanometer, a shunt resistance, means this is a voltmeter. We have to find the value of shunt in this case. Just the simple question. Voltage across this voltmeter is given 30 volts. Current in the galvanometer is given 30 milliampere. Galvanometer resistance is 100 ohms. And this is how you find the value of shunt in case of, we say, voltmeter. Is it clear, guys? Let me know in the live chat. Now you have this particular question. In this question, what is given is that you have got a voltmeter VA. Its resistance is R. You have got another voltmeter VB. B, its resistance is 3 divided by 2R because that is equal to 1.25R. And you have got this voltmeter C, it has got resistance as we say 3R. Okay. This A has got resistance R. This B has got resistance 3 by 2R. This has got resistance R. Now we are supposed to find what is the reading of this voltmeter? What is the reading of this voltmeter and what is the reading of this voltmeter? Reading of voltmeter means how much potential difference they are measuring. How much voltage A, B, C are measuring, or how much voltage is across, potential differences across A, B, C. If I say 10 volt is across A voltmeter, means it is measuring 10 volts. Its reading is 10 volts. If I say, sir, 20 volt is across B voltmeter, so means it will measure, its reading will be 20 volts. Now listen to me very carefully, my dear friends. If we talk about voltmeter B and C, we say, sir, B and C are in parallel. So if B and C are in parallel, we can clearly see that voltage across C or potential difference across C will be equal to the potential difference across B, because in case of parallel combination, voltage is same, potential difference is same. Now let's find their R equivalent. Let's find their R equivalent. Sir, R equivalent in case of parallel of two resistors is nothing but R1, R2 upon R1 plus R2. If you have two resistors in parallel and you are asked to find their equivalent, this is how do we find it? Sir, what is R1 in this case? R1 is 3 by 2R. 3 by 2R. What is R2 in this case? That is 3R multiplied by 3R upon what is R1? That is 3 by 2R plus then you have 3R. If you solve it, this will be 3 into 3 is 9R square. 9R square by 2 upon you have 3 into 2 is 6R. 6R plus 3R is 9R. 9R divided by 2. 2 and 2 will get cancelled. 9 and 9 will get cancelled. R and square will get cancelled. So this will be R. Means, my dear friends, over here, this is what we call X. And this A has a resistance of R over here. And equivalent of B and C came out to be also R. And this is also R. And this is, let's suppose, Y. And let's suppose this is point P. Okay, this is point P. Now, my dear friends, see, if this is R, if I say, sir, potential difference across this will be, let's suppose, 10 volts. This is also R, potential difference across this also will be 10 volts. Why? Because both are having the same resistance. Both are having the same resistance. If I say this is 10 ohm, across this potential difference will be same as across this. So means potential difference, listen to me very carefully. Sir, if I say potential difference between these two is, let's suppose, V1, okay? Let's suppose these two is V1. Listen to me very carefully. So that will be potential difference across C as well as potential difference across B. Why? Because both are in parallel. Now, potential difference across P and Y is, let's suppose, V1. So X and P also is V1. Why? Because both are having the same resistances. So in this case, potential difference across A is equal to potential difference across B is equal to potential difference across C. So we say, sir, VA is equal to, sir, VB is equal to, sir, VC. Guys, let me know in the live chat if this is clear to each and everyone. If this is clear to each and everyone. Let me know. I want you guys to give me the signal. Is it crystal clear? Guys, this question. This and this are having equivalent of resistance R. So potential difference across will be same as potential difference across this resistor, because this is also R. So that's why potential difference across all will be same. Now comes the meter bridge. This is the last concept, okay? And we are done. It'll not take more than 10 minutes. And we are done with the class. Guys, if you are not like this session, make sure you like it. Now see, my dear friends, over here. Let's talk about the wheatstone bridge and meter bridge, and we are done with the entire current electricity. Sir, wheatstone bridge. What is a wheatstone bridge? Let's suppose we have a resistance, let's call it R1, and we have a resistance, let's call it R2, and we have one more resistance, let's call this as R3, and we have one more resistance, let's call this as R4, and we have a resistance over here, let's call this as R5. Let's call this as R5. Now see, my dear friends, over here, if I say, if I say R1 by R2, ratio of R1 by R2 is equal to R3 divided by R4. If I say this resistance by this resistance is equal to this resistance by this resistance, let's suppose this is R by R is equal to R by R. 1 by 1 is equal to 1 by 1. Then remove R5 resistor, and solo it. Let's suppose what I'm trying to say in this case, because see, the wheatstone bridge actually says that if you have got 5 resistors and you are supposed to find the equivalent over here, we say if we have to find the equivalent over here, it becomes very complicated because this is in the middle branch. Okay, so we say, sir, if R1 by R2 is equal to R3 by R4, then we can remove this middle branch, because in that case we say potential of this point A is equal to potential of this point B. So no current will flow through R5. Remove R5 because no current flows through it. Okay, let me just give you the question. If I say, let's suppose, for example, question is, let's suppose, for example, you have got a resistor, you have got one more resistor, you have got one more resistor, and you have got one more resistor. This is R, this is R, this is R, this is R, and this is also R. Find R equivalent in this case. How to find the R equivalent? Sir, these two are not in series, these two are not in series. How do we find it? We say over here, it is a wheatstone bridge. What does that mean? That means here R1 by R2 is equal to R3 by R4, okay? Then we can remove, if this condition satisfies, wheatstone bridge says, if this condition satisfies, you can remove the middle resistor. Remove R5. So we say what remains over here. So this will be, sir, R. 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 This is R. This is R. This is R. This is R. Now in this particular case, you can say that, sir, these two are in series. Now if these two are in series, we say, sir, R plus R is 2R. Okay, and these two are also in series. So we say this is the upper resistor, these two in series, and this is the lower resistor, this is also 2R. Now 2R and 2R are in parallel. Their equivalent will be simply, that is simply, we say that is R by 2. That is 2R divided by 2, and 2 will get cancelled. So equivalent will be R. So means with the help of Wheatstone bridge concept, with the help of Wheatstone bridge, yes, this is already, that was the Wheatstone bridge in case of capacitors. So with the help of Wheatstone bridge concept, we can solve these circuits. Now, my dear friends, on the same concept, there is a meter bridge. There is a meter bridge. Let me just tell you, meter bridge. Guys, I have covered all the concepts, okay? All the problem patterns and all the concepts. Now, what is a meter bridge? We say it is an instrument. It is an instrument used to find the value of unknown resistance. Unknown resistance. It is an instrument used to calculate the value of unknown resistance, and it works on the principle of Wheatstone bridge. It works on the principle of Wheatstone bridge. So this meter bridge helps us to find the unknown resistance. Let me show you. Let's suppose we have got over here, this is a resistance, let's call it P. And this resistance is known. Known means which we know how much, what is the value of this known. And then you have another resistance, that is what we call the Q. This resistance is unknown resistance, okay? So we don't know what is the value of this Q, we have to find it. And we take a wire over here. Listen to me very carefully. We take a wire over here. And this wire over here is 100 centimeters long. This is how much? 100 centimeter long. Okay, this is 100 centimeter long. Okay, that's why we say that's why we call it meter bridge. Okay, and to this entire setup we connect a battery. Now, my dear friends, this is let's suppose a resistance of this wire is R and length of this wire is L. Listen to me very carefully. This is what we call the meter bridge. Now, what I'm trying to say in this particular case is, guys, we have got P is known resistance, Q is unknown resistance. And over here, we have to find this unknown resistance. How much is this? What is the value? If I say this is 10 ohm, what is the value of this Q? That's what we are supposed to find with the help of this meter bridge. So it is an instrument used to find the value of unknown resistance. And it works on the principle of Wheatstone bridge. What is Wheatstone bridge? R1 by R2 is equal to, if R1 by R2 is equal to R3 by R4, then remove the middle one. Now see, we say over here, one concept I'll be showing you over here. That is resistance per unit length. Resistance per unit length. The resistance per unit length means lambda is equal to R divided by L. What does that mean? See, this entire 1 meter wire has R resistance, okay? And its length is L. So L length has R resistance. If I say unit length has how much resistance, that is what we call the resistance per unit length. Resistance of 1 unit length. Unit length has how much resistance? How to find? Total resistance upon total length. Total resistance upon total length. I hope you got it. Okay. This is total resistance upon total length. Now listen to me very carefully. Sir, one more thing we need to add over here. That is a galvanometer used to measure the current and a jockey. Sir, why do we have to use this jockey? I will tell you. See, this entire wire has got resistance R and its length is L. That is how much? That is 100 centimeters. Listen to me very carefully, my dear people. See, we have to find over here, that is unknown resistance. To find unknown resistance Q. Now see, what we will do is that keep on sliding the jockey. Keep on sliding the jockey. Keep on sliding this jockey over here. Keep on sliding this jockey over here until you find the balance point. Until you find the balance point. Keep on sliding the jockey until you find the balance point, my dear people. Until you find the balance point, my dear people. So we say over here, keep on sliding the jockey until you find the balance point. Sir, what does that balance point mean? Balance point means when no current flows through the galvanometer, when current through this will become zero. When current flowing through this wire becomes zero. That is what we call the balance point. So you have to keep sliding this. So once you get that balance point, means then no current will flow through this jockey over here. So means that is when current is equal to zero through galvanometer. When current is zero through galvanometer, that's what we call we say balance point. Now, my dear friends, if I just, don't you think it exactly looks like a wheatstone bridge? See, can you tell me, sir, let's suppose we got the balance point at length L1. Let's suppose we got the balance point at length L1. Let's suppose we got balance point at L1. Okay, L1. Now, could you please tell me how much is the resistance of this L1? Sir, we know resistance per unit length. How to find resistance, sir? How to find the resistance of this one? From here, can we not write R is equal to lambda into L? Yes. Now, resistance of this length will be how much? That will be lambda into this length L. So this resistance R, let's suppose this is R1 and this is R2, this is R3. Let's suppose this is R. This resistance R will be lambda into L1. This has got a resistance of lambda into L1 because this is how we find it. You find it lambda R is equal to lambda into L. Now, if this is L1, how much will be this length? How much will be this length? You say, sir, this length from this point to this point will be, total is 100 centimeters. This is L1. Can I say this will be 100 minus L1? Yes, sir. And how much will be the resistance of this part? That is nothing but, sir, length of this part multiplied by lambda. So that is lambda into 100 minus L1. Now, guys, you have got one resistance P over here. You have got another resistance Q over here. And you have got this resistance over here, that is lambda L1. And you have got this resistance over here, that is lambda into 100 minus L1. What I am trying to say in this case is, see, entire rod has length 100 centimeters. If we got the balance point at, suppose, let's say L1, how much will be the resistance of this? How to find resistance? Lambda into L. So lambda into length of this part is L1. What will be the length of this part? That is 100 minus L1. And if you have to find the resistance of this part, that is lambda into 100 minus L1. Now, make it like a wheatstone bridge. Make it like a wheatstone bridge. So we say, sir, the first resistance will be, let's call this as P. Sir, the second resistance will be over here. See, this is P and this is the second resistance, that is lambda L1. This has got the resistance of lambda L1. Sir, this third resistance will be, sir, Q, which we are supposed to calculate. And this resistance will be how much? 100 minus L1 lambda into lambda. And then you have this in between, in which current is 0. This was the jockey or the galvanometer in which current is 0, because we got the balance point. See, when we say current is 0, let me recall the wheatstone bridge. Let me recall the wheatstone bridge over here. See, what does the concept of wheatstone bridge say? Sir, if potential of this point is equal to potential of this point, or if R1 by R2 is equal to R3 by R4, then potential of this point is equal to potential of this point, or current is 0 when potential across the ends is same, current is 0 in the resistor. If no current flows through the resistor, we can remove it. Same concept I am using over here, my dear people. Sir, current in the middle resistor is 0. Current in this jockey is 0 because we got the balance point. So here, we say if current in this is 0, you can remove this. Here, it is a wheatstone bridge. So we say, sir, that is R1 by R2, P divided by lambda L1 is equal to Q R3 by R4, that is lambda into 100 minus L1. Okay, and you can cancel this and this. From here you can get the value of Q. So this is the concept of wheatstone bridge in nutshell. It helps us to find the unknown resistance. Let me show you the question and that will give you the more feel. We say, sir, we are given a 5 ohm resistor and X, and this layer has got 100 centimeter length, and current in this jockey is given as 0. Current in the jockey is given as 0. And balance point is at L1. Over here, balance point is at L1 is equal to 20 centimeter. Okay, we are supposed to find the value of X. How much is this resistance? Now you guys tell me one thing. Here, you guys tell me one thing. We say, sir, this resistance divided by this resistance, that is 5 divided by, how much is CC? If you have to find this resistance, you say, sir, R is equal to lambda into L. Now over here, that will be lambda into L. L is how much? That is 20. So 20 lambda. And how much will be this resistance? How much will be this? How much will be 20 into lambda? How much will be, sir, this resistance? You say, sir, if this is 20, this will be 100 minus 20, that is 80 centimeter. So its resistance will be 80 lambda. Now, my dear friends, if I just make it over here, it will be exactly like wheatstone bridge. So because current is 0 in the middle branch, so this is 5 ohm, and this is, sir, X from over here, and this is, sir, another resistance, and this is, sir, another resistance over here. This is 20 lambda, and this will be 80 lambda over here. Okay, now over here we can clearly see that if we have to find this resistance, you say, sir, 5 divided by 20 lambda is equal to R1 by R2 is equal to R3 by R4, that is X divided by 80 lambda. This lambda and lambda will get cancelled. This and this will get cancelled. 2 1s, 2 4s. 5 4 is equal to 20. So X is equal to 20 ohms is the correct answer in this one. So this wheatstone bridge simply helps us to find